Hi everyone, I welcome you all to the live session on SQL full course by Intellipaat. This session is conducted by multiple experts who will be teaching you everything about SQL from basics to advanced level, along with hands-on demo and interview preparation. Before we begin the session, make sure to hit the subscribe button and also hit on the bell icon so that you will never miss an update from us. On saying that, let's see the agenda of the day. Firstly, we will begin with Introduction to Database and Database Management System. Then after that, we will explain you a few basic topics of SQL like aggregate function, indexes and encapsulation, and lot more interesting topics as well. Then after that, we will learn about SQL applications and process to install SQL. Post that, we will learn about Database Administrator and MS SQL Server. Once we finish with that, we will tell you how to become a SQL developer, what are the skills required and how is the career path of a SQL developer. Then lastly, we have covered SQL interview questions and answers. So this is the agenda of the video. Now let's begin the session.
We live in a world which is surrounded by data, right? So what is data? In my opinion, data can be considered as the facts which are basically related to any object which we are talking about. So, data can be age. Well, age is a data. You can put that in numerics. You can put that in a form where people can take note out of it and sense out of it, because age can be anything from 0.1 all the way till 100 and much more as well, right? So age is a numeric in which we can gauge something and get something out of. And then if you're thinking about the other forms of data, again we have video data as well, right? So video is what we call as unstructured data. But then if you do not know what unstructured mean, do not worry. At this point you need to know that pretty much video is a form of data as well. And then there are other data as well. When you think about all the data we generate by leaving messages to each other on WhatsApp, or leaving tweets on Twitter, sharing photos on Instagram, or putting some updates on our timelines on Facebook. So all these stuff and lots more is what we call as data, guys. So this brings us to the question, what is a database? You might have heard of data. So if you've heard of database, guys, head to the comments section and put down the comments. As usual, we all love an interactive session. And you guys are very good at it as well, guys. So head to the comments section and put your opinions down. So what is a database? Well, a database is basically nothing but a very systematic collection of data in the most simplest terms. So why would we go about needing the systematic collection of data? Well, it's pretty much to support some sort of storage where we can hold the data, maintain the data, and eventually we can we have to have the ability to manipulate the data in a very easy way, to be honest. So to give you examples of what databases actually are, if you guys remember, when we were a couple of years ago, we used to get these telephone directories where there used to be all the numbers. It's called yellow pages in a couple of countries as well. So that is a very good example of a hard copy of a database. And the contacts option on your mobile phone right now is also a database. Well, then coming to power generation. Power generation, you might not know, has a huge database of what power is being consumed by what house and whatnot, because again at the end of the day you get billed for the power you use, and this data goes to your local electricity power supply board. And again, this forms a very big database as well, because pretty much they need to know what the power they're generating versus what's being used, and many other details as well, guys. And then coming to social media, as I just told you, uploading images, uploading statuses, uploading stories, whatnot. So all of these are stored in a database in secure data centers, what we call, especially when it comes to social media and the privacy things. So pretty much all of these are stored in the database, and it is stored securely, guys. So basically this brings us to the question, why would we ever go about needing a database? Well, I've pretty much tried to keep this session very simple, and these are the reasons that I can pretty much think of why pretty much we would need a database. The first thing in my opinion is that we need a database because managing large amounts of data is a hassle, because You might say, you know what, I can store data in a spreadsheet and it's going to be fine. But then when you think about very large amounts of data, large chunks of data, and throw it all into one sheet and make it work, it might not work, or it might be extremely difficult even if it works, right? So let's say the size of the data increases from a couple of tens of hundreds of records to thousands and millions of records. So when this happens, it will create a huge problem if you're using spreadsheets to maintain this data, and at the end of the day it is going to hurt with respect to efficiency, time, and whatnot as well, right? So this is the first point of why you should need a database. And the second thing is the accuracy of the data, because when you think about it, doing data entry pretty much into a spreadsheet sounds very easy, but then it becomes extremely difficult to pretty much track how accurate the data is on the spreadsheet, because at the end of the day, if you cannot have a method where you can validate the spreadsheet to find out if your data is accurate or not, it doesn't make sense. And again, think about this: manual validation of thousands and millions of entries and verification of the same are pretty much near impossible, and even if they were possible, pretty much it brings the efficiency right down to zero, right, in my opinion. So this brings us to the third reason of pretty much why we would need a database, guys. So in my opinion, again, it's the ease of data uploading, because with the database you have very good amount of flexibility to pretty much update the data present, manipulate it, play around with it, create it, delete it, whatever you want at your convenience. So you do not have to wait for the person who created the spreadsheet go through millions of entries and do all of that. So again, the best advantage of a database is that multiple people can edit the data at the same time. This brings up the efficiency and pulls it from 0 to 100, almost 100 in my opinion, guys. So what do you think about the efficiency when it comes to the database technologies of today? Head to the comment section and do let me know. So on that note, this brings us to the next reason why you should consider a database. It is pretty much because of data security, because we do have passwords for spreadsheets and whatnot, but then the data is considered to be less secure, and it makes it gullible, because everyone can pretty much get access to all of these files. They can do some changes, remove whatever they want, or add whatever unnecessary stuff, and it hurts the data at the end of the day. But then with databases, pretty much you can have something called as security groups, privilege accesses, and so much more. So at the end of the day, here you can pretty much restrict access to a certain number of people, certain people with the privilege to access the data, manipulate the data, and whatnot. So your data will be in good hands at the end of the day. So what does that mean? Well, adding on to that, this brings us to the next point, which is data integrity. Data integrity is one of the big questions today when we are storing data in spreadsheets as well as databases, because again, we've already spoken about how data can be gullible when we've put it in spreadsheets, but then when you put it in a database, you are assured of accuracy. Number one thing, it is extremely efficient. Number two, and number three, your data is consistent, because multiple database service providers today pretty much go about giving you very good integrity checks, very good access controls, privilege accesses, member accesses, and so much more. So this brings us to something you might have heard of, or you might have used in college, or you might not know as well. It's called as DBMS. Well, DBMS pretty much means Database Management System, guys. So what is DBMS? Well, DBMS in the most simplest terms is basically just a collection of programs which enables the user, whoever is using this particular DBMS softwares, to go about accessing a database, creating a database, manipulating the data, deleting the data. So basically this gives the user an interface where he or she can talk to the database and pretty much work with the database, edit the database, delete the database, and do whatever the person wishes to if he has the right access. And this basically gives the person a very good interface, guys. So I have three facts for you with respect to the database management systems. And the first thing is that DBMS is not a new concept. It was first implemented pretty much in 1960. So that is how old a database management system is. And then when you can think about it, the person who pretty much gave us the first DBMS system pretty much is called as Charles Bachman. And his IDS is considered to be the first DBMS. IDS is basically integrated data store, is what Mr. Charles chose to call his first DBMS machine, guys. And then the third important fact is that today we know that the database technologies have evolved so much, and all of the functionalities have been given, and these functionalities increase every quarter, every year, every month. And then the database systems today are so powerful, it drives millions and millions of gigabytes of data every single day. Yes, millions and millions every single day, guys. I can say millions of millions as well, because the world, the entire world is basically a big data problem. So having a place where we can handle all of these, store all of these, and manipulate all of these is always a blessing, guys. So this brings us quickly to the introduction to SQL. Well, so what is SQL? Well, SQL is one of the standard languages we use when we go on about dealing with relational databases, which can be used to create, read, update, and delete database records, guys. So these are some of the operations we can perform. So what does SQL stands for? Well, SQL is simple. It stands for Structured Query Language, guys. You're going to find out why we call it the query language in just a moment. But then you read the term relational databases. So what is a relational database? Well, a relational database is basically just a type of database that stores and provides accesses to all the data points which are related to one another. Well, how are these data related to one another, guys? So basically, when we call it a relational database, there has to be some relation with respect to the data. Using SQL and all the DBMS, we call it the RDBMS because it's relational database management systems. Here we have the data organized in tables, which you'll see in just a second, and then we map the data so that the database knows what's important and what's not, and we do this using something called as keys. Well, keys such as primary keys, candidate keys, secondary keys, all of these provide relation between one column of the data to the other column of the data, guys. You'll see all of this in a couple of moments. But then coming to a little bit more about relational databases. Well, relational databases are pretty much based on what we call as a relational model, where we pretty much map one concept to another, the other concept is mapped to another, and we have this interdependency, interrelationships which are built throughout the data, guys. And then this makes it very intuitive and extremely straightforward. Pretty much it gives us a very straightforward way of representing the data in the form of tables, as I just mentioned. And then the other good thing about the relational database, as I already told you, is that each row has something called as a record, and there is some unique ID called as key as well. Again, we're going to check all of these in the upcoming slides. And then we have something called as columns, which any data table will have. And then these columns basically hold all of the data, and each record in this column basically is mapped onto a unique thing. And then we go on about establishing something called as interdependency relationships and much more among all of the data present, guys. And if you're wondering how SQL is pronounced, it is pronounced as either SQL or it's called SQL, guys. Pretty much you will find developers, enthusiasts, and many others either calling it SQL or SQL. So whenever you heard of the term, whenever you hear the term SQL, make sure to map it into SQL, guys. It's pretty much simple and straightforward. So coming to a little bit more about relational databases, there are some flavors of SQL that I thought I should tell you guys. Well, here are some of the examples of relational databases. We have MySql, we have Oracle SQL, we have Microsoft SQL, we have Sybase, and we have many more flavors of SQL as well. The subtle differences in between all of these providers are pretty much in the form of syntaxes of how we pretty much talk to the database. And there are some proprietary syntaxes as well, where the syntax only works with Microsoft SQL Server, and it might not work with MySQL and so on. But then it is recommended for all the beginners to pretty much go on to start with MySQL, and then pretty much jumping to any of these other providers, other flavors of SQL, it becomes very easy if you're a master of MySQL, guys. And on that note, make sure you stick till the end of the video, where as usual I'm going to give you a very attractive offer just for the viewers of this particular video, where you can fast track your way to becoming a MySQL expert, guys. So on that note, we need to quickly check out what a query looks like. So a query is something very simple. It is the actual, let's say, the code we write, guys, in terms of SQL. Well, a query will look something like this. Think about you entering this in a shell or in a particular workbench, guys. So we have something called a select star from data 1, where age is less than 20. So if you know a little bit of SQL, then pretty much you can make sense out of this. But then if you do not worry, because I'm going to walk you through what each of these mean. Well, so basically we're going to be viewing a lot of data present in the database, right? So select statement is pretty much used to pick data from the actual servers and then show it to us. Star pretty much means that, show everything that is present. Everything from where? Well, everything from a particular database that we have. And that database in this particular name is called as data1. And so do you want to just see everything from data 1? Well, no, I want to see some stuff from data 1 where the age of a person, let's say we are talking about a table which contains details about a lot of human beings or college people, school people and whatnot. So we just want to find out who all are less than the age of 20. So when you think about it, instead of just seeing millions or thousands of entries of students who are aged various from 3 to 100, but then when you're thinking about efficiency, then we need to bring it down to a certain condition where we go on checking it, right? So instead of just seeing thousands of entries, let us say we only require 11, and we're going to see 11 entries when we put the condition saying age is less than 20, because there are only 11 people who are less than 20 years old, guys. So pretty much this is what a sample SQL query will look like, and we'll just be doing very simple operations at the end. You can follow along in. So on that note, this brings us to the applications of SQL. So SQL has a couple of applications, and let me tell you one by one. SQL can be used as a data definition language, DDL for short. What this basically means is that you can pretty much create a database on your own, define its structure on your own, use it on your own, and just discard it when you're done with it. So this doesn't have to be just you. This can be among hundreds and thousands of people. You can scale it obviously, but then know that with respect to data definition language, you have all the right where you can individually create a database, define the structure, and delete it when you're done with it as well, guys. And this brings us to the next application, which is data manipulation language, because SQL can be used as DML as well. So what it basically means is that when we have something already in establishment, like data which is already present in our database, we need to go on changing something in that database. We need to update a database, we need to delete a row, we need to update a column, and so much more. So in that particular case, we can use SQL as a data manipulation language where you can pretty much alter stuff in the table. You can go on adding, removing, and whatnot. So this brings us to the next application, which is the DCL, guys, data control language. So data control language is mainly concerned with your data in terms of how you can avoid corruption and how you can avoid misuse as well. So pretty much, as you know, data has to be protected, and misusing data is extremely easy, even though with all the security measures these days. So SQL can pretty much be used in terms of DCL, where we can protect the databases against corruption and misuse in a very good way as well, guys. And the next application of SQL is pretty much that it can go on to be used as a very good client server language. You can pretty much program on the client side and the server side, where you can connect front ends and back ends together, where we have an entire architecture which is set up what we call as the client server architecture, where there is one server, and then there are lots of clients. I'm sorry about that. There's lots of clients, connected to that particular server, and then we pretty much, go on querying and talking to the server, getting the details from the server for each individual client, and more, guys. So the next application pretty much is what we call as the 3-tier architecture. The 3-tier architecture is something very similar to the client server client architecture, where pretty much we have something called as an application server, we have a database, and all of these together in terms of the server, the client, and the database form the 3 basic tier architectures, guys. So it's the client, it's the server, and the database, where the data is present, and it can go through the server, where it can go to multiple machines, or pretty much you can have it come to the server and talk to the client directly as well, guys. So on that note, what do you guys think about the applications of SQL? Can you think about any direct applications of SQL? If you can think of it, make sure to head to the comment section right now. we can check out the basics of SQL tables really quickly, guys. Well, as I've already told you, let's have a quick recap. A table is basically a database object which is comprised of rows and columns in SQL. We already saw that it is the structured way of going about using data, a table, and then it can also be defined as the collection of related data held in a table. It is related by the forms of keys, which I told you. But then there are two things that I really want you guys to visualize, which is basically fields and records. Well, fields are very simple, guys. Fields are the column where we have specific data under that. Well, consider the snapshot I have given in your screen. We have a field called as e_salary. Let's say it's employee salary, and this salary pretty much is the information which we provide. But then we have one header under which the salaries are all quoted, right? So this basically is the salary field. This entire column is what we call as a field. And then when we come to records is something very simple, because what is the record corresponding to a particular field? Well, let's say we want the record of the employee name Annie. Here Annie pretty much goes on to be the employee ID 3. It's under the employee name. We searched it through the employee name, right? So we said we want to find out Annie. So Annie is pretty much the employee's name, and the employee's name was the field, and the record was number 3, right? So it's pretty simple. Records give us an entire description, a complete information of all the entities present in that particular data set, guys. So we already have a lot of data on the screen, but then when we highlight one row, the Annie's row, pretty much this row gives us the complete information about that particular employee, guys. So this is what we call as a record. Let me quickly step back where you can see fields again. So this is the field, guys. The field is the column. The record is a single entity which gives us complete information. I hope I was clear with that. So this brings us quickly to the data types which are present in SQL, guys. So I will not go in depth because we need to keep this tutorial to the scope of all the viewers present tonight with our session. So basically know that you can have numerical data, character data, date and time data, and much more. With respect to numeric data, we can have integer data, decimal data, and all of these as well. So basically what you have on your screen is a data type, but with the corresponding range of the numbers that you can use. So you can see a big number there which is 922337203654775 right? So this one particular number, if in case you want to put in a number, say you want to put a phone number, you want to put an address or whatever it is, and you need this amount of number, the huge number, then you go on to use the data type what we call as the big int, guys. Then the normal integer supports pretty much in the data range that you can see on the screen. A small int is a fairly smaller number, somewhere around 32,000, and tiny int is even smaller, where it only supports positive numbers between 0 and 255, guys. And then with decimals, as usually you have a huge number, access to huge numbers on the negative side and on the positive side as well, guys. So this brings us to characters. There are three main data types. One is the char, one is the varchar, and the text. Again, pretty much it is as simple. At this point of time, you need to know that you can have 255 characters at once when you're declaring something, when you're declaring the name of a data type, or when you're putting in the actual data for the data type as well, guys. So but then we have something called as text, where let's say you want to put in a description of something. So this, it will be a limit if we actually say 255 characters, right? So for that particular case, the standard SQL manufacturers pretty much have given us a range of 65,535 characters, where you can pretty much, I think that should suffice most of the applications where we're using the data type text, where we are actually putting out some sort of description, guys. And then this brings us to the date time data type. Well, basically you can go on to using date format in the format year, month, day, and then you can go on to use the time as well, time in terms of hours, minutes, and seconds as shown on your screen. And we can just use the data type year by showing by seeing the format on your screen as well, guys. So y pretty much means 4 numbers. If you have to put it down right now, it's 2019, it's 2019. So that'll be the format of the year for now, guys.
We'll be installing Microsoft SQL Server. So all you have to do is go to Google and then type Microsoft SQL Server download, and you'll get these search results. Now, out of these searched results, click this one where you see SQL Server downloads from the Microsoft site. So we are into the site now. If I scroll down, we see 2 free editions. We have the Developer Edition and the Express Edition. So I'd be downloading the Developer Edition. I'll click on download and the download would start. Now this is the downloaded file over here. SQL Server 2017 SSEI Development. So we get this window over here and we have three options: basic, custom and download media. So I'll click on custom. Now we see that we have a media location where the SQL Server will be downloaded, and I'll click on install. So see that the download is successful and our installation will begin shortly. Here I'll click on installation and I'll select this one. So I'll be installing a standalone installation of the SQL Server. So let us wait for this to open. Right, so here I click on next. Now I already have one instance of SQL Server, so I'll be installing a new one. So I'll select this perform a new installation of SQL Server 2017. And then I'll select this free edition. I'll click on next. After that, I'll accept this license agreement and again I'll click on next. So we have all of these features over here. So I would just need the database engine services. So I'll select this and again I'll click on next. So I'd have to name the instance for the server which I'm installing. So I'll name this server as, let's say, Sparta. Similarly, I'll give the same instance ID over here. I'll click on next. So again, I'll click on next over here. So we see that we have two authentication modes, Windows authentication mode and mixed mode. I'll select the mixed mode and then enter the desired password. Let me put in my password over here. I'll add the current user. So the current user has been added. Now I'll click on next again. Right, so we are finally ready to install SQL Server. I'll click on install. Right, so once the installation is done, I would also have to install the SQL Server management tools. So these SQL Server management tools basically help us to connect with the database. I'll click on this. And this will redirect us to the Microsoft web page. And over here, I'd have to download the SQL Server Management Studio, and I'll be downloading the latest version. And this is the downloaded file over here, SSMS setup ENU. I'll click on this. So over here we have these three options: repair, uninstall and close. Now I have these three options because I've already installed Microsoft SQL Server Management Studio in my system. And if you're installing this for the first time, you'll have the install button over here. So you'd have to click on install and the install would be done automatically. Right, so once you install the SQL Server Management tools, go to the search tool and type Microsoft SQL Server Management Studio. Click on this and Microsoft SQL Server Management Studio will start. So over here you would have to specify the password which you gave while creating the instance and then click on connect. And to start writing your SQL commands, click on new query over here. And then you can happily implement all of your SQL commands. Right, so this was the installation of Microsoft SQL Server. So who is a database administrator? Well, a database administrator is someone who directs or performs all activities related to maintaining a successful database environment. So now that we know who is a DBA, let's look at some of the roles of database administrator. So a DBA has to take care of the initial installation and configuration of a new Oracle or SQL Server database. The system administrator sets up hardware and deploys the operating system for the database server. Then the DBA installs the database software and configures it for use. As updates and patches are required, the DBA has to handle this ongoing maintenance. A DBA has to also take care of backup and recovery of databases. So DBAs have to create backup and recovery plans and procedures based on industry best practices that make sure that the necessary steps are followed. Another role of DBA is to maintain security of the database. So a DBA needs to know potential weaknesses of the database software and the company's overall system and work to minimize risks. In case of a security breach or irregularity, the DBA can consult audit logs to see who has done what to the data. The DBA has to also take care of access control. That is, he has to verify which users can be granted access to the system and which users should be denied. Then a DBA has to also monitor databases for performance issues. So if some part of the system is slowing down the processing, the DBA may need to make configuration changes to the software or add additional hardware capacity. So now that we know what are the roles of a DBA, let's look at the types of DBA. Let's start with production DBA. So a production DBA is responsible for maintaining databases within an organization. The production DBA often gets involved when all the design decisions have been made and he or she has to keep things up and running. So the production DBAs basically take over after applications have been created, and they would have to keep the server running smoothly, back it up, and plan for future capacity needs. Then we have application DBA. So an application DBA focuses on a specific business application. He or she would be an expert in SQL and would implement the application business logic using SQL or any other query language. They would be also responsible for performance tuning of the database application. Next, we have development DBA. So the development DBA focuses on tasks related to building an effective, usable database environment to support the creation and maintenance of applications. Development DBAs need to be skilled in the process of data modeling and normalization to ensure that databases are designed to promote data integrity. Then there's UAT DBA. So a UAT database actually stands for Under Application Testing Database. And the UAT DBA is completely responsible for the testing and development of UAT database. And finally, we have Data Warehouse DBA. So a warehouse DBA is responsible for analyzing and understanding the data provided. It is his responsibility to study and track patterns for analytics and business intelligence. Hence, a warehouse DBA handles a more significant amount of data for a more critical function.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which SQL keyword is used to retrieve a maximum value? A. Most. B. Top. C. Max. D. Upper. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, let's understand what is MS SQL Server. So, Microsoft SQL Server is a relational database management system, or RDBMS, that supports a wide variety of transaction processing, business intelligence, and analytics applications. So, Microsoft SQL Server is built on top of SQL. It is tied to Transact SQL, or TSQL, which is an implementation of SQL from Microsoft that adds a set of proprietary programming extensions to the standard language. Now, let's look at the evolution of SQL Server. So the SQL Server database platform that we know today began with the SQL Server 7.2 release in 1998. So Microsoft re-architected the core database engine code in SQL Server 7.2 to address the database's scalability issues, transforming it from a departmental database into a true enterprise level database. Perhaps even more important, Microsoft added OLAP services, which would eventually become SQL Server Analysis Services. Then the SQL Server 2000 release saw Microsoft continuing to push the platform into enterprise. This release boosted scalability through large memory and address windowing extension support. The company also expanded SQL Server's data handling capabilities with the new XML data type. And then came SQL Server 2005, which was a major milestone. Microsoft added CLR integration, plus this was the first release to include the popular SQL Server reporting services subsystem out of the box. Microsoft also had replaced data transformation services with the new SQL Server integration services in this release. And in SQL Server 2008, Microsoft refined SQL Server's enterprise capabilities, adding transparent data encryption as well as the file stream and geospatial data types. SQL Server 2008 was also the first release with built-in row and page compression for tables and indexes. Then came SQL Server 2012, which expanded SQL Server's BI capabilities with the addition of Power View, which is a graphical data navigation and visualization tool. In this release, Microsoft also added always on availability groups, which extended SQL Server's high availability and disaster recovery options. The next release was SQL Server 2014, which provided a new in-memory capability for tables that could fit entirely in memory. It also provided a new hybrid disaster recovery and backup solutions with Microsoft Azure, enabling customers to use existing skills with the on-premise version of SQL Server to take advantage of Microsoft's global data centers. Then SQL Server 2016 released, which added new built-in JSON support in SQL Server for JSON imports, exports, parsing, and storing. A new poly-based query engine was also added to integrate SQL Server with external data in Hadoop or Azure Blob Storage. And the latest release is SQL Server 2017. And with this release, SQL Server is no longer just a Windows-based RDBMS. We can now develop applications with SQL Server on Linux, Windows, Ubuntu, or Docker and deploy them on these platforms. This release also has support for Python. So our data scientists can now more easily perform machine learning right inside of SQL Server. Now let's look at the different editions of SQL Server. So first we have the Enterprise Edition. So SQL Server Enterprise Edition includes both the core database engine and add-on services, and with a range of tools for creating and managing a SQL Server cluster. So it can manage databases as large as 524 petabytes, and it supports 640 logical processors. Then we have the Standard Edition. The SQL Server Standard Edition includes the core database engine along with the standalone services. So it differs from the Enterprise Edition in that it supports fewer active instances, that is, fewer number of nodes in a cluster, and it also does not include some high availability functions such as hot add memory and parallel indexes. Then we have the Web Edition, which is just a low TCO option for web hosting. And then we have the Developer Edition. So this edition includes the same features as Enterprise Edition, but it is limited by the license to be only used as a development and test system and not as a production server. And finally, we have the Express Edition. So it is basically a scaled down free edition of SQL Server, which includes the core database engine. While there are no limitations on the number of databases or users supported, it is limited to using one processor, 1 GB memory, and 10 GB database files. Now let's learn about instances. So you can consider an instance to be one complete installation of SQL Server, and each instance manages several system databases and one or more user databases. So an instance is either the default unnamed instance or it is a named instance. A default instance does not require a client to specify the name of the instance to make a connection, but a named instance is identified by the network name of the computer plus the instance name that you specify during installation. So the client must specify both the server name and the instance name when connecting. And a computer can have only one default instance and all the others must be named. Now let's go ahead and install SQL Server into our systems. So we can install SQL Server from this site over here, Microsoft SQL Server downloads. So I'll click on this link. So this is the website, and for this course I'll be using the Developer Edition. So all I have to do is click on download now and it'll be downloaded. Now let's look at the different system databases in SQL Server. So when we install Microsoft SQL Server, the system databases are automatically created on every SQL Server instance. These system databases allow the database engine and administrative applications to properly manage the system. And these are the available system databases: Master, Model, MSDB, and TempDB. So let's start with Master Database. The Master Database contains all of the system level information for SQL Server, all of the logins, linked servers, endpoints, and other system-wide configuration settings. The Master Database is also where SQL Server stores information about the other databases on this instance and the location of their files. So if the Master Database is not present, SQL Server cannot start. Then we have the Model Database. So the model database is used as a template whenever a new user database is created. So modifications made to the model database, such as database size, collation, recovery model, and other database options are applied to any databases created afterward. Then we have MSDB, which is used by SQL Server agent for scheduling alerts and jobs. So MSDB also holds backup history. So using the MSDB tables, it's possible to determine when each database and file group was last backed up. Then we have TempDB, which is basically a workspace for holding temporary objects or intermediate result sets. One interesting thing about TempDB is that it is recreated every time the SQL Server service is started. And any objects that we've created in TempDB will be gone once the server restarts. So one of the most important tasks of a database administrator is to back up and restore the databases to ensure that there is no data loss. And for this purpose, the SQL Server backup and restore component provides an essential safeguard for protecting critical data stored in our SQL Server databases. So to minimize the risk of catastrophic data loss, we need to back up our databases to preserve modifications to our data on a regular basis. And this is where a well-planned backup and restore strategy helps in protecting our databases against data loss caused by a variety of failures. Now it's time to restore and backup the AdventureWorks database. So I will right click on this databases folder over here, and since I want to restore the AdventureWorks database, I will select this option, restore database, and I will set the source to be device, and I will add a device. So that would basically be the file which I have to add. So I will go to the D drive. So inside D drive, I have this AdventureWorks folder, and this is my database over here, AdventureWorks 2014. I'll click on OK. Again, I'll select this and I'll click on OK. So I have successfully added this AdventureWorks 2014 database. Now I'll click on OK, and I'll just wait for the database to be restored. Right, so we get this message that database AdventureWorks 2014 has been restored successfully. Now, if I open this databases folder, I will refresh this, and we see that we have this AdventureWorks 2014 database over here. Now my next task would be to make a backup of this database. So for that purpose, I will right click on this and then select tasks, and I have this option of backup. I'll select this. Now I will remove all of the previous backup models which I had created. So I will select this. I'll click on remove. Now I will click add and add a new backup. Let me name that to be new backup. I'll click on OK. Now again, if I want the TSQL code for this, all I have to do is select this script, and this would be the TSQL code to get a full backup of this AdventureWorks database. So now I'll select OK. Again, let me wait till the backup is completed. So get this message that the backup of database AdventureWorks 2014 has been completed successfully, right? So first we went ahead and restored this AdventureWorks 2014 database, and after that I made a full backup of this database. Now let's look at recovery models. So a recovery model is basically a database property that controls how transactions are logged, whether the transaction log requires backing up, and what kinds of restore operations are available. And all of the backup, restore, and recovery operations are based on one of these three available recovery models, which are simple, full, and bulk logged recovery models. So let's start with simple recovery model. Well, as the name suggests, it is the simplest among the available models. So when we choose the simple recovery model, SQL Server maintains only a minimum amount of information in the transaction log. And while using the simple recovery model, we may restore full or differential backups only. So it's not possible to restore such a database to a given point in time, and we may only restore it to the time when a full or differential backup occurred. Therefore, we will automatically lose any data modifications made between the time of the most recent full or differential backup and the time of the failure. So the simple recovery model requires very less administration, and it is easier to manage in the full or bulk log models. But there would be higher data loss if a data file is damaged. So next we have full recovery model. So with the full recovery model, all the transactions are fully recorded in the transaction log file, And this allows us to design a disaster recovery plan that includes a combination of full and differential database backups in conjunction with transaction log backups. And in addition to preserving data modifications stored in the transaction log, the full recovery model also allows us to restore a database to a specific point in time, and hence no work is lost due to a damaged file. Next, we have bulk log model. The bulk log recovery model is a special purpose model that works in a similar manner to the full recovery model. The only difference is in the way it handles bulk data modification operations. So, the bulk log model records these operations in the transaction log using a technique known as minimal logging. So, this saves significantly on processing time but prevents us from using the point in time restore option. So now let's change these recovery models in SSMS. So this would be the command to set the recovery model to be simple. So set recovery simple with no wait, go. Let me just execute it. So see that commands have been completed successfully. Now if I want to change this recovery model from simple to full, all I have to do is write full over here. Now I'll click on execute. So this time we have changed the recovery model from simple to full. Now again, if I want to change this recovery model from full to bulk logged, all I have to do is type in bulk underscore logged over here. I'll click on execute. Right, so this time the recovery model which we're using is bulk logged. Now let's see how can we plan a backup strategy. So after we have selected a recovery model that meets our business requirements for a specific database, we'd have to plan and implement a corresponding backup strategy. So these are some of the questions which we'd have to keep in mind while planning a backup strategy. How many hours a day do applications have to access the database? And how frequently are changes and updates likely to occur? And are these changes likely to occur in only a small part of the database or in a large part of the database? And these are the different types of backup models which we can use. So we have full backups, differential backups, file and file group backups, partial backups, copy-only backups, mirror backups, and transaction log backups. So a full backup, as the name implies, backs up everything. It is the foundation of any kind of backup. So this is a complete copy which stores all the objects of the database. That is tables, procedures, functions, views, indexes, so basically everything. So the full backup will be able to easily restore a database in exactly the same form as it was at the time of the backup. Then we have differential backup. So you can consider a differential database backup to be the superset of the last full backup, and it contains all changes that have been made since the last full backup. So if there are very few transactions that have happened recently, a differential backup might be small in size. But if you made a large number of transactions, the differential backup could be very large in size. Then we have file and file group backup. So whenever the database size and performance requirements make a full database backup impractical, we can create a file backup instead. So a file backup contains all the data in one or more files which are known as file groups. Then we have partial backup. So partial backups allow us to backup only a subset of the data files. So these partial backups will make a backup copy of the primary file group and all read-write file groups, and by default they will omit any file groups designated as read-only. This means that partial backups are only relevant for databases that contain read-only file groups. Otherwise, a partial backup will capture exactly the same data and objects as an equivalent full database backup. So next we have copy-only backup. So a copy-only backup is a SQL Server backup that is independent of the sequence of conventional SQL Server backups. Usually taking a backup changes the database and affects how later backups are restored. However, occasionally it is useful to take a backup for a special purpose without affecting the overall backup and restore procedures for the database. And this is exactly where a copy-only backup can be used. Then we have mirror backup. So mirror backups are actually identical copies of the same backup, and these identical copies are stored on multiple locations. So this increases the protection level by having additional copies of the backup set. And in case one of the copies gets lost or is corrupted, we can use the mirrored copy to perform a restore. So finally, we have the transaction log backup. So transaction log backup allows us to backup the active part of the transaction log. So after we issue a full or differential backup, the transaction log backup will have only those transactions that were created after those other backups had completed. So now let's implement backup models in SSMS. So now again I will select this AdventureWorks database, right click on it, I will select tasks, and since I want to backup, I'll click on backup. So this time I want a differential backup. So I'll select differential and all I have to do is click on OK. And before that, if I also want the TSQL code for this, all I have to do is click on script. And this is the TSQL code to get the differential backup of this database. I will click on OK. So you see that the backup of the database has been completed successfully. Now similarly, if I want to get a transaction log backup, I'll right click this, tasks, backup, and this time instead of choosing full, I'll select transaction log. And again, if I want the TSQL code, I'll click on script. So I'll just click on OK over here. So this time we have a transaction log backup of the AdventureWorks 2014 database. So now let's understand what is point in time recovery. So point in time recovery allows us to restore a database into a state it was in at any point of time. This type of recovery is applicable only to databases that run under the full or bulk log recovery model. So now let's implement point in time recovery in SSMS. So I have this AdventureWorks 2014 database over here. I'll right click this, select tasks, I'll click on restore, database, and I have this timeline option over here. So I'll select timeline and I will set a specific date and time. So I want to recover this database from 2 hours back. So I'll set this to be 18 and I will click on OK. Right? So this is how we can do point in time recovery. So again, if I want the TSQL code for this, all I have to do is click on script. But for now, I'll click on OK.
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
So we have successfully got the point in time recovery of this database for 2 hours back. Now we'll see how to import and export data in SSMS. So I have this happy database over here and I want to import a flat file into this database. So for that, I'll right click this. I have the option of tasks and over here I have to select import data. I have to set the data source. So the data source would be a flat file source. Now let me browse that flat file. So I have this new file over here. I'll open this. Now all I have to do is keep clicking on next. So this is the data which is present in this flat file. Click on next and then I'd have to set the destination. So I want to store this into my database. So the database would be SQL Server native client. Now this will be stored in this happy database. I'll click on next, and I'll have to click on finish over here. So we see that we have successfully imported this flat file into our database. And now let me refresh this. Let me have a look at the tables over here. So we have imported this new file into this database. Now let me go to this database first, which would be happy over here. So select star from new file. I'll execute. Right? So we have successfully imported the dataset. Now what I'll do is add a new row to this file and export this into a new file. So insert into new file. It will be values and then let's see the name is Anne and her age is 3. I'll execute this. Now let me look at the modified data. So that will be select star from new file. So we have successfully added this new record. Now I would want to export this data. So this time again I will right click this database and I will select tasks. Over here I have the option of exporting data. Now the source would be SQL Server native client. Now this time the database is again happy. I'll click on next. I'd have to choose a destination. So the destination would be a flat file. I'd have to choose a file name over here. So I want to store this into new file 2. and I'll click on next, next. So over here I'd have to choose the table which I want to export. So I want to export this new file. I'll click on next. Now next again, and I'll click on finish. So this time we have successfully exported this data from SSMS. So dynamic management views and dynamic management functions are system views and system functions that return metadata of the system state. On querying the related system objects, database administrators can understand the internals of SQL Server. So these dynamic management views allow us to monitor the performance of SQL Server instance and diagnose issues with it. Now let's look at some of the properties of dynamic management views. So dynamic management views are composed of both views and table valued functions. Some of them apply to the entire server and are stored in the master database. Others are specific to each individual database. And all of these DMVs start with the prefix DM underscore. Now let's look at some categories of DMVs. So DMVs can be divided into many different categories, and in this session we'll be looking at three of those. So we'll be looking at database related DMVs, SQL Server OS related DMVs, and execution related DMVs. So let's start with database related DMVs. First we have DM underscore DB underscore file underscore space usage, which returns the space usage information for each file in the database. Now we will use this DMV to get the total number of free pages and total free space in megabytes available in all files in tempdb. So let me just run this command over here. I will click on execute. So the total number of free pages available in tempdb are 3592 and the total free space is 28 MB. Next we have DM underscore DB underscore log space usage, which returns space usage information for the transaction log. And we will use this DMV to get the total free log space in megabytes available in tempdb. Now again, I will run this command in SSMS. I'll click on execute. So see that the total free log space is 5.74 MB. So this is the total free log space in tempdb. Next we have DB underscore partition stats, which returns page and row count information for every partition in the current database. And this time we will get the counts for all partitions of all indexes and heaps in the AdventureWorks 2014 database. Let me click on execute. So these are all of the partition stats for all of the indexes and heaps in the AdventureWorks 2014 database. So here we have different statistics such as index ID, partition number, the data page count, and so on. And over here we have the reserved page count, the used page count, the row count. Right, so these are all of the partition stats which we can get from this DMV. Next we'll head on to SQL Server OS related DMVs. So first we have the DM underscore OS buffer descriptors, which returns information about all the data pages that are currently in the SQL Server buffer pool. So with this command over here, we'll get the cached page count for each database. Again, I'll run this command in SSMS. I'll click on execute. So these are the different databases which I have in SQL Server, and this is the cached page count. So in MasterDB, I see that there are 137 cached pages. In MSDB, there are 9. In Sparta, there are 6. And in AdventureWorks, there are 304. Next, we have DM underscore OS threads, which returns a list of all SQL Server operating system threads that are running under the SQL Server process. So this query over here is used to find workers along with time used for execution that are running threads which are actually not started by SQL Server. So this is all of the information about the threads which are not yet started by SQL Server. So we have different columns. We have the OS thread ID, the creation time over here, the kernel time, user mode time, and over here at the back end of it, we've got the address associated with each of these threads over here. Now it's time for the third category of DMVs, which is execution related. So first we have DM underscore exec connections, which returns information about the connections established to this instance of SQL Server and the details of each connection. And this command over here is used to gather information about a query's own connection. So for this query, we see that the session ID is 51 and we have other columns as well. So we have the host name over here. This is the host name. We have the program name over here. We have the login name. and we have the original login name, the connection time, and the login time. So next we have dm_exec sessions, which shows information about all active user connections and internal tasks. And this command over here, it finds the users that are connected to the server and returns the number of sessions for each such user. So we see that there are two users currently. One is NT service Ignis, another is SA. And for the first user, the session count is 1, and for the second user, the session count is 50. So those were some of the dynamic management views. Now we will work with Activity Monitor. So SQL Server Activity Monitor is a feature in SQL Server Management Studio that displays information about the SQL Server processes and their effect on SQL Server performance. So the Activity Monitor consists of these expandable panes. So we have overview, we have processes, resource weights, data file IO, recent expensive queries, and active expensive queries. Now let's go ahead and start Activity Monitor in SSMS. So over here, I would have to right click on this and then select Activity Monitor. So we have opened up Activity Monitor. So this overview pane over here, it contains the graphs for the most important SQL Server instance information. So this %processor time, it tells us the percentage of time the processor spent to execute threads that are not idle. And then we have waiting tasks. So this over here gives us the number of tasks that are waiting for processor, IO, or memory to be released so that tasks can be processed. Then we have database IO. So this gives us the data transfer rate in megabyte per second, and it could be either from memory to disk, disk to memory, or disk to disk. And finally we have batch requests per second, which gives us the number of SQL Server batches received by the instance in a second. Now let's look at the processes pane. So this processes pane shows us the information about the currently running processes on the SQL Server databases and who are running those processes. So we have information for session ID, we have user process, we have login name, and so on, right? So we see that these are the users over here, and these are the databases which the users are currently working on. You see that the user SA has worked on TempDB, MasterDB, and this AdventureWorks DB. After that, we have the resource weights pane, and this provides information with respect to a thread which is waiting for a key resource such as memory, CPU, or network. So these are all of the threads which are waiting for something. And then we have the next pane, which is data file IO. So this pane shows information about the database files on the SQL Server instance. So for each database, all the database files are listed. So we have all of the different databases over here, TempDB, master, model, and so on. And these are different files which are part of this database. And then following on, we have the recent expensive queries pane. So this pane shows all the expensive queries in the last 30 seconds which use up a lot of resources, whether it is memory, disk, or network. And finally, we have the active expensive queries, which shows all the currently active expensive queries running. Now we will work with the performance monitor. Now sometimes there might be issues which occur outside of SQL Server that may cause performance problems in SQL Server. So this is where we can use Performance Monitor. So Performance Monitor is a monitoring tool which is shipped with Windows, and it helps in tracking various performance counters and monitors overall system and application performance. And these counter values are shown in real-time graphs which can be saved in log files and used for analysis. Now let's work with Performance Monitor in SSMS. So to open Performance Monitor, I'd have to click on Tools and then select SQL Server Profiler. I will just give the connection name and the password over here. I will connect. Now again, inside the SQL Server Profiler, I have this Tools tab. So I'll select this and then select Performance Monitor. Over here, I will select Performance Monitor, and we see that there is a graph which tells me about performance of the system. Now if I want to add some counters, I would have to click on this plus symbol over here, and I can add all of the performance counters. So let's say I want performance counters related to memory. So let me go to the memory section over here, and inside memory, maybe I want to add available megabytes. I will add this. I will add committed bytes. free and zero page list bytes. So this is memory. Again, in logical disk, maybe I want the cache bytes. I would also want the commit limit. Now similarly, under physical disk, I would want the disk read time and the idle time over here. Now all I have to do is click on OK. Now if I want to get a report of this, we see this change graph type and I will click on report. So this is the report which I have. So we see that available megabytes, this is the available megabytes, cache bytes, committed limit, committed bytes, and the free and zero page list bytes over here. And we have the percent disk read time under physical disk, percent idle time under physical disk, and we also have the processor time over here. Now let's see how can we trace SQL Server activity using SQL Server Profiler. So whenever we are working with really long and complex SQL queries, we have to make sure that all of those tasks are performed accurately. This is where tracing all these tasks becomes important. So SQL Server provides a tool called as SQL Server Profiler for exactly this purpose. So Profiler is a tool for tracing, recreating, and troubleshooting problems in MS SQL Server. And it lets developers and database administrators to create and handle traces and replay and analyze these trace results. Now let's go ahead and work with SQL Server Profiler in SSMS. So we are back to SSMS. Now I'd have to click on Tools and then select SQL Server Profiler. Again, I will give in the password and then establish the connection. Let me click on Connect. Now I'd have to give a new name to this trace. So I will name this as New Trace, and then maybe I will also save this to a file. So let me give in the destination. So I'll save this in my C drive. I'll click on Save over here. Now I can also set the trace time. So let me schedule it. So I want this SQL Server Profiler to run for at least 1 hour, and again over here event selection. So this is where I can set all of those events which I want to be traced. So I'll click on this show all events and let me add some events over here. So I want to trace the cursor prepare, cursor unprepare option, and let me go to the objects tab over here, and I want to know whenever an object is altered, created, or deleted. Similarly, let me go to this performance tab and I want to know about auto stats, and now all I have to do is click on run. So we see that the trace has started and we get all of the information over here. So we have the detailed information of whatever is happening. So you have the event class, text data, application name, NT username, login name, and so on. And we also have the reads, writes, and the duration for the reads and writes over here. So this is how we can work with SQL Server Profiler. So why do we need data integrity? Well, data integrity is used to maintain accuracy and consistency of data in a table. So whatever data we have with us, we need to make sure that it is correct, error-free, and useful. And data integrity can be grouped into these categories. So we have entity integrity, referential integrity, domain integrity, and user-defined data integrity. So entity integrity ensures that each row in a table is a uniquely identifiable entity, and we can apply entity integrity to the table by specifying a primary key, unique key, and not null. Then we have referential integrity, which ensures the relationship between two tables is proper, and we can apply this using a foreign key constraint. And then we have domain integrity, which ensures the data values in a database follow defined rules for values, range, and format, and we can enforce these rules using check and default constraints. And finally, we have user-defined data integrity, which can be enforced through triggers.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following SQL clause is used to delete tuples from a database table? A. Delete. B. Remove. C. Drop. D. Clear. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Aggregate functions. Okay, so what are aggregate functions? As the name suggests, these functions operate on a collection of values and returns a single value. For example, if you want to, so in case you want to get the maximum of salary from the employee table, this is how you write it. You say select max of salary from employee. Let me just quickly change the connection to our own database. Intellipaat 17th, this one I guess. Okay, so if I want to get the maximum of salary from the employee table, I just say max of salary and it gives me 5,000, which means that 5,000 is the maximum salary, that is maximum salary amount present in the employee table. Okay, now if you see here, it shows as no column name. The reason is when you aggregate a column, the column name goes off. So you need to give it an alias name so that you can see the name of it. So here I say max salary, and when I execute it, see, now you get the column name as max salary. Now you can also filter your data. Let's say you want to get only the maximum salary where the address is India. So you say address equal to India. So now it will give you all the maximum salary which belongs to India. Okay, for the employees belonging to India. I think it's IND. Let me see, what do we have in them? So let's start from employee. Yes. Oh, I have a space, my bad. So here India. Let me execute this. You see, so you can also apply your filter conditions before your aggregation. So the where clause works before, or it is executed prior to getting the maximum. So first it filters the data to get all the employees where address is India, and then gets the maximum of salary. Similarly, if I want to get the minimum of salary, I say select min salary from employee, and here I see that the minimum salary is 1,000 for the whole employee table. If I want to see the average salary, I say select average of salary from employee, and it gives me 3071. Okay, which is nothing but, so average is nothing but sum by count, isn't it? So when I say select sum of salary divided by the count of employee ID from employee, it would give me the exact same amount. Let me show you by executing both of these queries so that you can confirm. See, when I execute these two, you see both of these has 3071. Okay, so this is how you can get your average. Now you can either take a count of employee ID or you can do a count star. So there are multiple ways in which you can count it. Like for example, you can say count one, you can say count star, or you can say select count employee ID, for example, okay, from employee. Now all these will return you the exact same output. See, it gives 7, 7, and 7. The problem with this is that when you say count star, it gets, so this one, it gets all the data into memory and then counts the records. In here, it gets all the employee IDs into memory and then counts the records. Now the problem with this approach is the nulls in the employee ID might not be counted as a row. So that is the demerit associated with counting only a specific column. Okay, if it is a primary key, you can go ahead and calculate it. You can go ahead and count it. But when you count it, count any other column which is nullable, let's say, then if it is null, if one of the row is null, then it won't count it. So basically, let's say in the employee table, if one of the employee ID had null, it would have counted only 6 rows instead of all the 7. So that is the demerit associated with this. The demerit associated with this is it takes the whole table into memory, because we are saying count star, right? So star means the whole table. So it takes the whole table into memory and then counts the rows, which is again a bad approach. I mean, why do we want, for a very simple count operation, why do we want SQL Server? It doesn't makes any sense at all, right? But then there is the count one. Now, what does count one mean? One is basically a integer value. It's a plain number. Okay. Now here I can say, let's say this. Let's say select star from employee. Sorry, select star from employee. What do I get? I get the whole employee data, right? So if I say comma one, this is another column, right? One is another column. So here I get all the ones. See here? So it basically, you remember we used to derive column here right? Like we used to say year of something, it used to give us one more column. So similarly here, I'm just hard coding it to 1. So when I run this, it gives me all the ones here. Now, if I remove the star, let's say I remove the star, what will happen? So when I remove the star, it will basically give me ones for every record in the employee table. And then I can do a count of 1 in here. This is the most efficient way of counting it, because it is now not taking everything into memory, but just taking the hard-coded ones into memory and just counting them. As simple as that. Okay, so we can use any hard-coded value as an acknowledgement to count the number of records in the table instead of counting the star. So these are all the aggregate functions that are available with SQL Server. Okay, so moving on. So next, let's talk about user-defined functions. So what are user-defined functions and why do we create them? So the user-defined functions are, so we have spoken a lot about the system-defined functions, the functions that the system provides to us. Now let's say we want to create a function for our own use, which is not easily achievable with the system-defined functions. In that case, we create our own user-defined functions. Okay, now what are the different types of user-defined functions that we have? The first is called as the scalar value function, which you already know returns only a single value. Okay, and then we have the table valued function, which returns the output in the form of a table. Now, if you have realized, the system-defined functions doesn't have any table valued functions as such. Okay, they are mostly scalar valued functions. User-defined functions, we can create table valued functions, and they are again of two types. One is inline or single line table valued function, and the other is known as multi-line or multi-statement table valued function. Now, what is an inline table valued function? The function in which there is only one single line that returns the table is known as a single line table valued function. Easy definition. Okay, and the second one, which is a multi-line, is a function which has multiple lines that helps us return the output in the form of a table. So clearly the function that returns the output in a single line is called a single line table valued function. The function which returns us the output in the form of a table using multiple SQL statements is called as multi-statement table valued function. So let's start with talking about scalar valued user-defined functions. Okay, and these are functions which we write. Earlier, system-defined functions were functions that are provided by default with SQL Server database. Okay, but scalar valued user-defined functions are functions that we write that accepts input parameters and returns a single value. So a single value could be 1, 2, 5, 10, Dinesh, John, anything, today's date, and it can return any data type. That means it can return varchar, it can return integer, it can return date time and whatnot. Also, a single function at a single point in time will return only one data type. That means you cannot use a scalar valued function to return two values with two different data types, because it is a scalar valued function. It can only return a single value at any point in time. Now, let me show you how to create a user-defined function. The example that I'm going to give you is how to create a, or how to generate a full name from two given input parameters. I know you can do it with other system-defined functions, but yes, just giving you an example as to how you can create your own user-defined function. So here you say create or alter. Now, why do I say create or alter here? The reason why I say create or alter is because, let's say I'm creating this function for the first time in the server. Our motive whenever we are executing any type of SQL query is that our query should never give us any error. Okay, it should not throw any error at any point in time. So we need to prepare our query which is re-executable. That means irrespective of how many ever times you execute, it should not throw any error. Now, when I only say create function, that means every time I run this query, it'll try to create that function. And let's say it created the first time. The second time when you ask it to create, SQL will say that, hey, it's already there. I cannot create it again. So you need to alter the second time. Okay, right. So here, if I say only create, it'll throw me an error if it already exists. But if I say create or alter, SQL will automatically identify if this function is present in the server, in the database or not. If it is present, if it is already existing, then it will alter it. If not, it will create it. Okay, so here I say create or alter function, and then we give a name to the function. Now giving the name is also an art. It's also an art, okay, to be frank with you. Very few people I've seen give good names to their objects. Okay, you need to build this quality in yourself. Okay, you need to make sure that any object that you're creating, it could be a table, it can be a view, it can be anything, any type of object that you're creating, you need to ensure that you give a proper name to your object so that anyone else looking into that can understand what exactly is it, does it contain, or is it going to do. So here, first of all, I prefix it with fn underscore. Now this is also an important aspect. Why? Because here, from here onwards, any object that we're going to create, I would say, except for tables in the database, any object that you create, make sure that you give them a prefix so that you look at it and know what type of an object it is. So here, when I give a prefix of fn underscore, I know that, okay, this is a function. So I give it a name saying fn underscore so that I know it's a function, and then name that justifies the purpose of that particular function. So here I say get employee full name, that is this function is going to give us the full name as an output. And then you remember when we were executing functions, we were passing input parameters. You remember? So with this, with our function also, we can design it to design so that the user can pass input parameters. So this is where we define how many input parameters can be passed to the function. So here I say the first parameter is first name, the second parameter is last name, and both of these are of varchar 50 characters in length. Now if you have observed, these have at the rate as a prefix. That's the reason they are called as input variables or input parameters. Remember when we were talking about variables, I said that you need a at the rate in the front which categorize them as variables. So here I say this function is going to take two input parameters, and then is a very important aspect again of the function, which says here I'm going to specify what is this function going to return as an output. So this function I say is going to return varchar 101 characters long. So the first name is of 50 characters, last name is of 50 characters. Now if I'm generating a full name, obviously I'll separate these two with a space. So that's the reason I give 101, 50 plus 50 plus 1 for the space. So this function is going to return 101 characters in a string of 101 characters as begin, and then we specify the core of our function. That means what is this function going to return. So here I say return, and if you see here I say select, I trim off the first name, basically to trim off the spaces if there are any. So let's say there are some spaces in the front of the name or at the end of the name, I just trim off those spaces, and then I concatenate it, I add a space in between, and then the last name. Okay, and now let me create this function. So see how many ever times I executed, it doesn't throw me an error because I have the create or alter here. Now where can you find the functions in the server? Go in here, go to the databases. In this database, go to programmability, and in here you will find functions and then scalar valued function. See, this is the function that we just created, function underscore get employee full name. And if you see the parameters, see it accepts two parameters, one is first name, one is last name. Now how do we call these? You already know, right, how we call this. So we usually say select and then the function name, right? Select and then the function name and then the input parameters, isn't it? We used to pass John and Smith. Let's pass John and Smith as the first and the last name, and I give it an alias name saying as full name. And this, when I run it, it gives me an error. It says the function is not a recognized function name. Now, this is something odd, isn't it? The reason is you need to specify the DBO before your user defined scalar valued function call, so as to ensure that the optimized what actually happens is when I say select and then I put the function name, SQL automatically anticipates or assumes that it is a system defined function. It doesn't understand that it could be a user defined function as well. So it always looks into the collection of system defined functions. So how can we force SQL Server to look into the user defined functions? By specifying the schema name, because no system function will be created or can be created in the DBO schema. This is basically for the users only. So when I say DBO dot, now it should work. But this is not ideal in case of tables, isn't it? In tables, we don't specify the DBO schema name because by default it is the DBO schema. But the case is a little different with only user defined scalar valued function. So that's the reason we need to put DBO in here. So when I pass John and Smith, see, it gives me the full name as John and a space and then Smith. Similarly, if I pass Dinesh and Kumar, it would give me Dinesh Kumar as output. Now, if I want to probably show you one more example, create or alter function, let me create one more function which will add numbers for us. So the input parameters should be two numbers. Let's say number 1 and number 2, both are integers. And obviously the sum will also be an integer. So I say returns integer as begin, and here I return saying select number 1 plus number 2 because this function is going to add up numbers for us, right? Now this I'm showing you very simple examples, okay, but you can think of any redundant job that you're planning, that you are doing at your job place, and try to put it in a function. But again, you need to remember that no DML operations are allowed. So only redundant select operations can be put in the functions. And now if I run it, I create this function and try to, so this one also is create or alter, and if I try to run it, it gives me 3, the sum of 2. 10 plus 15 gives me 25. Simple. And this is the same notes that I was explaining you earlier. So the next topic that we're going to talk about is on the user defined functions. I told, so till here we spoke about the scalar valued function, basically the function that returns a single value. Now let's see how can we design a function that will return as a table as an output. So the first one that we're going to talk about is the inline or the single line table valued function. Basically, the table is returned as a result of action from the given parameters, but it is derived from a single select statement. That means, as I told you, the body or the definition of the function contains only one SQL statement. So how do we do it? I say create or alter function. Again, I give it a name, fn underscore get employee details. So this is the name that I give to my inline table valued function. The parameter, it accepts only one, which is employee ID, and it returns, you see here, now I say table. So earlier we were specifying either varchar or integer. Now we are specifying as a table. So it returns a table as an output as, and then in the return, you see here I don't specify begin and end. The reason is we know that the function has only one SQL statement inside. And when you have only one SQL statement, you don't need to specify the begin and the end. Okay, basically for single line function you don't need begin and end, but for scalar valued and for a multi-line table valued function you will need the begin and end. So only for this one you can skip the begin and the end. I mean, that's not a part of the syntax. So here I say return, and then if you observe, I'm saying select. So this is one select command, you realize, right? So here I say select, and then I can call my scalar valued function inside the table valued function. This is the function that we just created above, didn't we? So here I say select dbo dot this function name, and then I pass two columns that I have, the employee first name and the employee last name as full name. So I first select the function and then salary and then address. So this is something that you can only do with scalar valued function, not with table valued. Okay, and I say from employee, where employee is equal to @employee ID. Now what is @employee ID? Is the input parameter. So whatever parameter the user sends for that particular employee, it would display the full name, the salary, and the address. Audrey asks, what is the purpose of putting the @ sign in front of the employee ID? As I told, these are input parameters or the variables, right? So for SQL to identify that these are parameters, we need to specify, we need to put at the rate in front of it. So this is basically a naming convention. For parameters, you need to put at the rate in the beginning. So now let me create this function. It says commands completed successfully. And now, how do we call a table valued function? So it's going to return as a table, right? So we are going to call it exactly how we call tables. So I say select star from function name in bracket the input parameter. You remember the scalar valued function, we used to just say select and then the function name, DBO and then the function name. But here, as it returns a table, we say select star from and then the function name. And if I execute, it gives me full name, salary, and address. Okay, because in the function we have specified a full name by using the function, salary, and the address, only 3 columns. So this is how you can execute or call your table valued functions. No DBO is necessary here, because for table valued functions it can easily look it up on the table valued user defined functions. Only for scalar valued functions you need to specify DBO.
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Let's move on. Okay, next up we have multi-line or the multi-statement table valued function. Now, as I told you, this will have more number of SQL statements in the definition. So how do we create it? The same syntax, create or alter function. We give the name. So here I give fn underscore, which basically represents that this is a function. And then I have get employee details, and you see ML. ML means multi-line. So I give it a name so that I can distinguish. Earlier I gave get employee details, now I give get employee details ML. And then the input parameter is the same, which is employee ID. And then here, if you remember earlier we used to say returns table, returns varchar, returns integer. But now here, in case of multi-line table valued function, we need to say returns, and then we have to specify a table variable. When we were speaking about the temporary tables, so here I'm specifying a table variable with the name @emp, and I specify the columns here, which is employee ID, full name, and salary, and the data types obviously. And then I say as begin, and then at the end I specify end, and inside this I specify my whole SQL statements, I mean all of my SQL statements. Now what do I do here? I say insert into the table variable the columns, and then here I select the employee ID goes into the employee ID column, the full name goes into the full name column, and the salary goes into the salary column from the employee, where emp.employee ID is not equal to the input parameter. You see here? So here what I say is, if I pass, let's say 5 as my input parameter, then except for 5, insert all the other employees into the table variable. So first it would do that into the table variable. Next, it would update the employee IDs which are 2 and 5. The salary will be updated to 5,000. So I write a quick update statement here. And then I delete the records which are 6 and 3. All I'm doing it from the table variable, if you remember, if you see here. Because if you remember, I told you one important aspect of functions, that is it does not allow us to perform any DML operations on the physical tables, right? So in that case, I mean the only exception in that is that we can do it on the table variables. Okay, so here I say insert into EMP. First I insert all the employees except for that, and then I run an update to update the salary to 5,000 for 2 employee IDs. I delete 2 employee IDs from my EMP table variable, and then I insert one hard-coded record. Okay, I try to insert one record into the table variable, and then I say return. Now what does the return keyword do? The return keyword would basically return this EMP table as an output. Okay, so here I already specified the returns keyword, isn't it? I mean I specified what should be returned. So when I say return, SQL automatically understands that, okay, that EMP table variable should be returned to the user. So now let me execute this. So we now have multiple lines of SQL statements inside the function, isn't it? And now when I execute it, see, I say select star from function and I pass the ID as 4. And here when I run it, see, this is the output that I get. I get the employee ID, full name and salary, basically the structure of the table variable. And the if you see, first what we did was we inserted everything except for the input employee ID, right? So what did we provide as an input? We provided 4. So it does not have a 4 clearly, as you can see. And next what we have is I updated for 2 and 5, I updated the salary to 5,000. So here if you see, for 2 and 5 the salary is 5,000. Now this is all being done on the table variable, mind it, okay? The table, employee table, isn't touched at all. Here I said delete from EMP where employee ID in 6 and 3. So you should not be seeing 6 and 3 here. And also end of it, I just inserted a record with ID 100, which is here. Okay, so this is how a multi-line table valued function works.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which SQL keyword is used to retrieve a maximum value? A. Most. B. Top. C. Max. D. Upper. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So what are the other operations that we can perform on functions using in where clause? So I've already shown you how to use the function in the select. Here I can select after star, I can add one more column like you already know and pass 2 columns in this, first name and last name. And when I execute this, it would give me a whole of employee data and then 1 column at the end that would say full name. Okay. And next you can also use, so this is only for scalar functions, okay, scalar valued functions. Now you can use scalar valued function in select as well as in the where clause also. You see, in where I specify the function name and then I pass the 2 values as input, basically the columns, and say equal to John Smith. So now it'll return me only that employee which has the full name as John Smith. See, it returns me employee ID 2 which has the name as John Smith. So this is only on the scalar valued functions. You see here, only on scalar valued function you can use them in the select and in the where clause as well. Okay. Now for the table valued functions that we have, you can use them to join with other tables. Okay, so to join table with the table valued functions with other tables, there are 2 options. Like we have joins to join tables, we have cross apply and outer apply to join functions to the tables. Now as I told, these are only the table valued functions, so we cannot join the scalar valued functions because those only return a single value, right? But the table valued functions returns a table, so we can join that with other tables. So first let's talk about the cross apply. The cross apply is similar to an inner join. So how do we write it? You need to remember this syntax, okay? It's a little different from how we write joins. Here I say select star from the employee table and then cross apply. Here I say select star from the function and then I need to pass the input parameter. I give it an alias name, say as fn, and this is like your join clause. Okay, this where clause it acts like a join clause here. So I say where e.employee ID is equal to function.employee ID. So this is like your on clause in the join as x. Okay, so this whole thing I name it as x, and when I run this, you would see that it gives me the data which is an inner join between the employee table and this multi-line function. And obviously without the where clause it becomes a cross join. See, I commented the where clause and now if I run it, it will act like a cross join. So it will basically multiply, the Cartesian product will be retrieved. With the where, it is an inner join. See, so this is the employee data, this is the function data. Now the outer apply is similar to a left outer join. The syntax is exactly the same. I say from let's say this is the function and then outer apply select star from employee as e where employee ID is equal to employee ID as y. and when I run this, it basically gives me all the data from the the function, and then only the matching records from the right table, which is the employee. And if you remember clearly, the record 100 isn't existing in the employee table, so it shows up as null. If you want to do a right join, you might ask, what do you do in that case? To do a right join, you just flip your tables. There is no right join in case of functions, so you just flip your tables like this. Bring your function in here and get your table in there, and here if I run it, see, it now gets all the data from the employee table. And if you see here, this one is missing in the function because it's 3. You remember 6 and 3, I deleted it knowingly, and then 5 is also missing because, so this is how you can join your system table valued functions with tables in the database. Okay, so in case you want to see the text inside the function, you have a function called sp help text, which you can use to see the content of the function. So I can say sp help text, and I can specify the name of the function to get to see what is there inside of it. See, I can see the whole structure of the function, is it? But this is not easy to read. So what can you make? How can you make it easier to read? You see here on the top, there are 2 methods in which you can get your output. One is results to grid. The other one is results to text. So here I can choose the results to text, and when I execute it, it'll give me the output in text. See, but by default it is the grid because we are always, most of the times we are retrieving data from tables. But this is one such scenario where text format really makes sense. So once you're done with here, you can see the whole text of the function. But let me switch back to grid. But in case you want to go back and see and you don't want people to see your function definition, you can hide it by using the with encryption that I showed you here. So this will help us in not allowing the function to be scripted out using the sp help text. So let's say I alter it using the with encryption, and it says commands completed successfully. And now if I run the help text again, you will see that it throws me a message saying the text is already encrypted. Okay, that means it doesn't allow us to see the um, text of the function again. So I was talking about the sp help text. Now before you encrypt it, I use the with encryption, right? And now it, when I execute it, it gives me a message saying it is already encrypted and you cannot see it. So one thing that you need to remember is when you encrypt something, before you encrypt it, make sure you take a copy of your function, that is the text, store it somewhere safely in a text file or in a SQL file, store it in a repository somewhere, because once you encrypt it, decrypting is a long process again. Okay, I'm not going to go in detail into that, but you need to be a sysadmin on the server. You need to do a lot of things in order to get back your function again. So make sure you store it somewhere safely before you encrypt it on the server, so that I mean, you don't want everyone else to see, so no one else will be able to see it. That's fair enough. But tomorrow when you want to update your function to something else, let's say you want to make a change, you have to get the function that you have stored in the repository and then change it and deploy it back again, because you will not be able to get the function code from the server anymore. Okay, so make sure you save it safely in a repository somewhere before you encrypt it. So that's about functions. Next up, we're going to talk about the case statement. So what is the case statement? The case statement allows us to write conditional statements during the retrieval of the data. Okay, so for example, if you want to while you're retrieving the data, you want to derive a column based on certain condition, that is when you can use the case statement. So how do you write it? Here you can say, let me just remove this complicated stuff from here. So you can say select star from employee will basically give you all the employee records, isn't it? This gives the whole of the employee data. Now here, if I say to derive a conditional statement, so what I'm going to do here is I'm going to display a message based on the ID. So if the employee ID is less than 5, so I say case when employee ID is less than 5, then display a message saying employee ID is less than 5. when employee ID is greater than 5, so this is a single statement. Okay, so when the employee ID is greater than 5, then employee ID is greater than 5 in text. Else, obviously, if it is not less, if it is not greater, then it is equal to, right? So I say else employee ID is equal to 5, end. So this is where you actually say SQL Server that okay, this is where my case statement ends. This is mandatory again. Okay, as the conditional column, this is just a name that I give to my column, and if I run this, it shows me the output in this form. So this is the employee table content, and here the conditional column, you see here I have the values like this, which is less than 5, equal to is equal to 5, and greater than is here, right? So when you want to generate a conditional output like this in your select, you use the case statement. Now, for example, let's say if you want to print if a text is palindrome or not. Now, what is a palindrome text? A palindrome text is the same when it is reversed. So, mom is a palindrome text, which is basically the same when it is reversed. Wow is a palindrome text, okay, which is wow when reversed. Okay, so these are palindrome texts. Let's say I update the first name to wow. Okay, just for an example, so I say set the first name to wow, and here let's update this one. And now what I do here is I say select star case when employee first name equal to the reverse of employee first name, then print it as palindrome, else display as not palindrome. Okay, and as this is my column name. So when I execute this, you will find that, see, this one is a palindrome name now. So it says palindrome, the rest of them are not palindrome. So it shows as not palindrome. Okay, let me update it back to Dinesh. Okay, let me remove this one and let's update this. Okay, so now there is an alternative for case which you can use only when you have two conditions. With case, as you can see, you can write up to as many conditions as you want. You just have to specify when after for each of the conditions. But when you have only two conditions, that is either a true or a false, you can use the if. So with the if, you can say if employee is less than equal to 5, then print this message, else print this message. So if is basically a function that accepts three input parameters. First one is the condition, next is the truth value, that means if the condition is true, the last one is the false value, that means if the condition is false, what should be done. And when I run it, you will see that it gives me the output as this. So for all the ones which are less than equal to, it says less than equal to. For the ones which are greater, it says greater than. And this one is the if condition. Okay, so you can use if. It's a function that accepts only three input parameters. One is the condition, second is the true value, third is the false value. Right? Now, coming to the if statement. Okay, the if is a conditional flow. Okay, this if and case that you see is usually in the select. Inside the select, when you want to specify your conditional statements, you use if or case. But when you want to execute your queries based on certain conditions, you use the if command. So let's say if I say if 1 equal to 2, then select nice. So if I run this, it doesn't display me anything because 1 is not equal to 2, right? And if I say if 2 equal to 2, select nicer, let's say, and when I run this, it prints nicer because the second condition is true. So let me show you. The second condition is true. Now let's say I make the first condition true as well. So if I run this, you will see that it selects both nice and nicer because both of the conditions are true. Fair enough. But these two are two separate conditions. How do I make this into one condition? I say else if. That means if this is true, then it should select nice. Only when the first one is false, then it will check for this condition. See, the else condition here converts these two conditions into a single condition now, the else part, because now it says check for this else. That means if this one is false, so the else part connects these two statements. Else if 2 equals to 2, then select nicer. And here, if I execute this, you'll see that it only prints nice. Although the second one is true, it doesn't print it because it only selects the first true value. Now, let's say if I make this one false and the second one is true, it prints the second one. Now, let's say the second one is also false. What will it do? It will not print anything at all. This is where the else statement comes in. So the else statement would execute when all the if statements are false. See, it prints nicest. Only when all the statements are false, then the else statement would get executed. So let me remove this. I think I did this one as well for you. Now, the begin and end is necessary in if. If you have two conditions inside your condition, I mean two statements inside your conditions, then you need to use a begin and end. If you don't use begin and end, let me show you. So let's say you just say if 1 equal to 2, then select first and select second. Let's say there are two statements. When you execute these, it prints the second although the condition is false. See, 1 is not equal to 2, but still it prints second, because when you don't have a begin and end, only the first statement qualifies to be in the condition. The other one does not qualify to be in the condition. So let's say I remove the begin and the end and now execute it, you will see that it would print nothing at all. The reason is now both these statements are inside the condition. Okay, so when you want to execute two or more statements in your conditions, then you use the begin and end. Okay, I'm going to start this off by copying two tables, okay, from one of the earlier databases with the name ranking and the population. Just a moment, do we have here? Let's say 10th May. 10th, let's say ranking maybe. So this one and then the population table as well. Okay, so I have both these tables with me. Okay, so in case you have already, you must be already knowing about this select star from employee. When you specify the table name as a single name, it is called as a single name qualifier. If you specify it with the schema, we call it as a double name qualifier, which means you are specifying two things to be able to for SQL to identify the table. In a three name qualifier, you specify the database name, okay, which is this name, dot the DBO, which is a schema name, dot table name to locate the table. So if I execute, it gives us the same table itself, but in case you want to get it. See, I was able to copy it from another database, right? So I specified the database name, schema name, and the table name. You can also have a four name qualifier, which is basically, let me just get the server name. So I can specify the server name dot the database name, which is this, dot schema name dot the table name, and this would give me the same exact data. Okay, so this is how you can use or fetch data using a single name, double name, three name, and a four name qualifier, right? And as part of this module, what we're going to talk about is the order by clause, the group by and the having, except and intersect, union, and union all. Okay, so let's start by the order by. The order by is pretty simple operation wherein which we use to sort the data that we retrieve from the table. So in case I want to sort the data that I am retrieving from my table, then I use the order by. Okay, so how do we specify it here? Let's say I say select star from employee, it would give me all the employee data as is. Now let's say I want to sort it by salary, so I say order by salary. Now when I only say order by salary, it sorts the data. As you can see the data is sorted based on the salary, but in an ascending order. That means the default sorting mechanism in SQL is ascending. So if you don't specify in what order it should sort, it will sort it in ascending order. See, here I just said order by salary, right? I did not specify the sorting method. So here, when I said salary, only order by salary, it sorted all the data based on the salary in ascending order. If I want to sort it in descending, I need to explicitly specify the DESC keyword, and it would sort the data in the descending order, you can see. So it also flips the rows as well. Okay, it does not only sort this column but the whole table itself. Now if I want, I can apply two column sorting as well. That means I can sort my data based on two columns, but the second column sorting is only used, okay, is only used when the first column has duplicate values. That means, let's say for these two employees, which has the same salary, for these two the employee ID sorting would be used. Okay, whatever second column you specify. So the second column sorting is only applicable when this first column has duplicate values or the same values. So here it shows 3000 and 3000. That means here it will apply the employee ID sorting in descending order for only these two. For the rest of them, it will still be on the salary because they are distinct values. I mean, they are one value each. So if I run this, you would see that everything is still the same, but only for 3000. If you see internally, the employee ID is first 5 and then 3. 5 is basically higher than 3, right? So it's in descending order. Let's say I make this ascending. Let's say make it ascending. So when I make it ascending, you'll find that for these two, the employee ID is now 3 and 5. So you see the difference? So the second column is only applicable when the first column has the same value. Now let's read what I have mentioned here. So I mentioned in the notes, I've said when there is a request from the business to deliver reports or metrics of some analysis, they might need the data to be arranged in a particular order. Okay, sometimes they might need it. So in that case, we use the order by clause, which helps us in ordering the data in either ascending or descending order. And as I showed you, the default ordering mechanism in SQL is ascending order. And if we want to force the sorting to be in descending order, we need to specify it explicitly with the keyword DESC. And we can have the sorting applied on more than one column in the table, as I showed you. But the second column is only used when the first column sorting returns the same value. And you have to specify the sorting mechanism for each column individually. That means, let's say you apply descending, it is only applicable for the salary column. For employee ID, you need to specify it separately. Now, if you don't specify either of these, that means SQL will sort the data in salary in ascending order, employee ID in ascending order. Only if you provide the keyword here, then it'll use these. So let's say I have a third column here. Let's say I have a column X here. This column would be used for sorting only when these two have the same data for 2 or more rows. Only then the X column would be used for sorting. We can also order data or sort data using the column position or the index of the column. Like for example, here if I say, let's say select star from employee. So what do I get here? I get all the data from the employee table, isn't it? Now, if you see here, the salary is the fourth column, employee ID is the first column. So I can say here order by 4 descending. 4 is basically salary in descending order, and 1 also in descending, like I had in the above query. So you can also use the column position and it should work well. But the problem starts when someone messes with the column list here. You see the star here? If someone replaces it with the columns, now the position goes for a toss. See, the fourth position is address now, and the first position is first name now. This is where it goes for a toss. So we don't prefer using. So now, although I still have the order by same, but only because the selected columns changed, now it is based on the address and on the first name, which is not something that we want. So that's the reason we always keep it with the same column names. We sort it based on the column names and not on the index or the position of the column. This is not the ideal way. As I said, cases when the select statement is altered might be bad for this kind of sorting method. Right. Now, the sorting is different for integer values and for the string values. So for integer values, it can store only numbers, correct? So when we sort it, it will sort it as a whole number. That means it'll be in, if I put this in ascending order, it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then so on. And it'll keep increasing like this 1, 1, 1, sorry, 1, 1, 1, 2, 2, 2, 3, 3, 3, and so on. So it'll keep increasing like this. But for a string data type, what it does is it does not consider for string sorting. Let's say for this one, DINESH and DIANESH. So how does SQL know which one should be put first, which one should be put next? It cannot compare the string as a whole. So how SQL compares it is, it will compare character by character. So D is the same, I is the same, and then it has N when compared to a. So if I sort this in ascending order, this will go on the top and then Dinesh will be stored only because the third character is A here and N below. Okay, so string characters are not compared as a whole. It is compared one after the other. So the integer values in the string columns are also compared that same way. So it first compares the first value in each of the rows and then moves on to the next one. So that is the reason 2 is considered greater than 1111 because it only compares the first value while sorting it. And if the first value is the same, then it compares the second value. Okay, let me show you with an example so that you're clear about it. So here I'm going to create a table. Let's say the table name is integer sort, and I create two columns. I create one column here, ID, which is of type integer. Okay, and here what I do is, okay, so here let's create a table which is int sort, and it has one column which is ID of type integer. And when I execute it, let me create this table first of all, and then let me try to, now that the table is created, let me insert these values into the table. It's basically 1, 2, 3, and there are a few numbers here. Okay, I'm inserting into the integer sort table. So let me execute. It says 9 rows affected. And now if I try to select from int sort, let me show you. It has the values in it. Let me try to sort them in ID ascending. And if I run it, you will see that it gives the highest value first and then 111, 44, 22, 12, 11, which is perfect. Let me sort in ascending and you will see that it is perfectly sorted. See 1, 2, 3, 11, 12, 22, 44, 111, 222, which is fairly good enough because these are numbers and it should be sorted in this way. Now let me show you a different thing. Let me create another table called the text sort, and in here I put the column as ID. The column name is ID, and this time the data type I'm putting it as varchar 10 characters. Okay, and let me create this table, created, and I insert the same set of values into the text sort ID column. The ID column is a varchar column, mind it, and let me insert these values. Okay, perfect. 9 rows. Let's see the text sort table. Select, and you have all the values, right? Now let me try to order it based on ascending and see what happens. So let's try to do it ascending and run it. See this. We get 1, 11, 111, then we get 12, 2, 22, 222, and so on. Then we get 3 and 44. So it basically compares character after character instead of the whole number. Okay, so similarly, if I do a descending, you will notice that it has 44 first, then 3, then 222, then 22, and so on. Okay, so the top clause helps us in fetching the top n records during the select statement. So if I just say select star from employee, it would get me only, I mean, the whole employee table. Now if I want to see only the 2 records from the top, I just do this. Now if you, let's say you want to see the top one salary, highest salary, you can say top one star, order by salary descending. So it'll give you the employee who is earning the highest salary, because see, I'm sorting it and then I'm picking the top one. So the order by executes first and then the top. Okay.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following SQL clause is used to delete tuples from a database table? A. Delete. B. Remove. C. Drop. D. Clear. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So next is the distinct clause. The distinct helps us in fetching the distinct records from a table. So let's say I select only the salary column. Let's say I select only the salary column from the employee table. So I get only the salaries, right? But as you can see, there are 3,000. Okay, let's say I want to get the distinct salary, or let's say the address maybe. Okay, this is more meaningful. Let's say I want to select the address. So I get 4 India and 1 Australia and 2 US. Now let's say someone says me, hey, can you get me all the addresses from where our employees belong to? I cannot give them this list, right? Because it has duplicate values. So in that case, I can use the distinct to be able to get only the distinct addresses. Here now I only get 3 values, right? But now let's say I added with the employee first name and execute it. See, I again get 4 India and 1 US and 1 Australia. Now why did I get 4 India again? Because now the distinct works on all the columns that you have put on select. So here I have put 2 columns on select, right? So it fetches me all the records from the distinct of all these, both these columns now. So India and Dinesh is only one record. So it just shows it is not duplicated, as you can see. So the distinct gets us the distinct across both these columns now. Now let me remove the distinct here and you will notice something different. See, for the US record, we have both the employees as US and John. I mean, the address is US, then the first name is John. So when I put the distinct, you will see that I get only 1 US and John, because the other one is also the same. So it got duplicated. Now let me put the employee last name here as well. And if I execute, now I get two records for US as well, because the last name combination is not unique anymore. So the distinct helps us in fetching the unique records from a table, or in fact of the selected columns. And when the distinct is applied on more than one column, then it removes the record if it is duplicated across all the columns. You see here, it gets removed only it is duplicated across all the columns. So if you want to get the top 2 highest salary from the employee, you can say select distinct top 2 salary from employee order by salary descending, and here if I run this, I get 5,000 and 4,000. Okay, so next up, let's talk about group by clause. Okay, so how does the group by help us? The group by, so you've known about aggregations, right? So if you want to get the maximum salary, you get it by saying max of salary from the table. If you want the minimum of salary, you say select minimum of salary from the table. Now if you want to let's say get the maximum of salary per address, minimum of salary per address, or minimum of salary per department, that is when we use the group by. So the group by helps us in grouping the data based on certain values like the address, the departments, or anything. Okay, so let me show you with an example. So I have the population table here, which is a very simple table with 4 columns: country, city, town, and population. So each country, as you can see, there are 2 countries here. Each country has 2 cities, city 1 and city 2. And then city 1 has 2 townships, T1 and T2. City 2 has 2 townships, T3 and T4. And then city 3 has 2 townships, T5 and T6. City 4 has 2 townships, T7 and T8. Clear enough? So it's a very simple table, and at the end we have the population for each of the townships. So T1 has 100 population, T2 has 23, T3 has 87, T4 is 98, and so on. Now, if I want to get the sum of population from the population, so there is a column called population, the table name is also population, okay? So if I say select sum of population as sum of population, this is just a alias name. And if I run this gives me the total population in the whole table. If I want to get the population country wise, I use the group by. I say select country, comma, the sum of population from population. This is where I say group by the country. And now it gives me per country what is the sum of the population, right? Similarly, if I want to get the population based on a city, I say select city, comma, the sum of population group by the city. So now I get per city how much is the population. If I want to get it based on the country and the city, I say country, city, sum of population from population group by country and city. Perfect. Grouping the data based on the aggregated, based on the columns that you have chosen for aggregation. I say select city, sum of population as sum of population from population, and here before the group by I say where city in city 1 or city 2. Okay, so when I run this, it'll only group the data. It'll first filter it and then group it. So if I run it, it'll filter the data for me saying, okay, get only for city 1 and city 2, and then group the city to get the sum of population. So see, I get only city 1 and city 2 because I specify I need the data only for city 1 and city 2. This is normal filtering. Now, what if I want to filter my aggregated data? If I want to filter my aggregated data, we need to use the having clause. And the having is usually accompanied by the group by. You cannot use the having without a group by. So here, let's say I want to get only those cities. Let me comment this one. I want to get the first, I want to group it based on the city, and I only want to see the cities which have population less than 150, the total population. So I can execute this query and I get these 3 cities. The other one I didn't get it because let me show you. I didn't get city 2, correct? So if I execute this, I get only 185. I mean, I don't get city 2 because it is 185. The population is 1, which is greater than 150. Okay, so the having clause helps us in filtering aggregated data, which cannot be done by the where clause. If I put this where sum of population is less than 50, it won't work because the where clause, let me run this and show it to you. See, an aggregate may not appear in the where clause. So you can only use it in the having here. Me execute and I get only city 1 because I've said in city 1 and city 2 and then I'm using the having. But if I remove this where clause and execute it, so the where clause is applicable before the grouping, the having is applicable after the grouping. Okay, now I remember someone had a question as to in what sequence does the query executes, and this is what it is. So we start from a from, right, from where the table has been, what table has been specified. Then we go into the join, which is the inner, outer, or cross, whichever it is, and then the on clause, that means on what columns it needs to be joined. Then obviously the filtering happens. Then if you have a group by, that gets executed. Then the having executes, then the distinct executes, and then the order by the top, and then the select at the end. The select and the column list, it executes at the end. Okay, so obviously the select is on the top, but it executes at the end of it. So this is the sequence in which your queries execute. Okay, so we have already discussed about union and union all, so I'm not going to talk about it much. But one thing that I want to add is, if you see here, I showed you this example, correct? I mean, I showed you how the hard-coded data sets only retrieve or get us the unique records. The union gets us the unique, whereas the union all gets us everything without checking for duplicates. But with union and union all, you can also select from the tables. Like See, you can here I'm selecting employee ID first name from employee, and here I get what, 1 Dinesh, 2 John, and 3 Santosh, and a lot of other employees, right? I can use a union and select from primary key test. So let's see what the primary key test has. The primary key test has 1 Dinesh and 2 John, which is the exact same as the first two records in the employee. Let me just show you. See, the employee has 1 Dinesh and 2 John, and then the rest of the employees. But in the primary key test, we have 1 Dinesh and 2 John. So I can put a union here in between both the selects to combine them and get one result set wherein 1 Dinesh and 2 John is retrieved only once. If it was union all, okay, which is right below, you should have ideally got 2 Dinesh and 2 John. See here. So this is how the union and union all works with multiple tables. Okay, earlier I showed you only on one record, only on hard-coded values, but now I just showed you with tables as well. Okay, so you can add more tables as well if you want to do it. I mean, let's say I execute this. See, I get two more records. Sorry, 3 more. Okay, so the union all, but one thing that you need to remember is the columns that you're selecting here should be the same. Now let's say from the employee table I get what, 5 columns. Now I cannot say start from employee union all start from primary key test, because the primary key test has 2 columns and the employee table has 5 columns. I cannot do this. See, it throws me an error saying all queries combined using union, intersect, and except must have equal number of expressions in their target list. That means whatever number of columns you have in here, it should be the same number of columns in here as well, but it's not the case. So that's the reason we need to make sure that the columns are exactly the same. Okay, now it works. There is a except operator which we can use to retrieve, let's say there are 2 tables, default test and primary key test. Okay, let's say there are 2 tables like this. So if I say this except this, what output do you expect? This except this, what output do you think will be coming out? Except is basically these 2 records except these 2 records. So that means get me all the records which are in this table which are not there here in the other table. So it's like this, ID and name from defaulted except start from primary key. I mean, I can do the same here as well. I mean, it makes no difference because a primary key test has only 2 columns. So if I run this, you will find 2 no name provided, because this is the only record that is present in this table but missing in this table. But one thing that you need to remember, the except works like a union or a union all, wherein the columns should be the exact same. I mean, not the name of the column, but the number of columns that you have selected. Here we have 2 columns, here we should have 2 columns. The first one is integer, second one is varchar. Here also the first one should be integer, second one should be varchar. So when I run this, it gives me the records in this except the records in this, which is 2 and no name provided. Now the other way around, if I say primary key test except default test, I should get 2 and John, isn't it? Because 2 and John is present in this but not in this. So let's say if I flip my tables, I say primary key test except default test. So it'll now give me 2 and John. 2 and John is present in the primary key test but missing in the default test. Okay, next is the intersect operator. The intersect operator fetches the common records across both of them. Now this is different than the joins. Okay, the join helps us in joining the data one next to the other, but this is more of a vertical combination of the records. Okay, this takes into account the whole row instead of taking columns to be joined. Okay, so here I say ID name from default test intersect the primary key test. So it should give us the common record, and the common record is 1 and Dinesh. So if I flip the tables also, it should be the same, right? Because the common record isn't going to change. The except, yes, I agree, it should be different. But when I say intersect, both of them should be both of the queries should return the same output.
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Now coming to another interesting aspect, which is the ranking functions in SQL. So what are ranking functions? Ranking functions helps us rank the data. Now, a very common question could be the third highest salary, the fourth highest salary, the sixth highest salary. How do we find them? We use the ranking function. So what are the different type of ranking functions that are available? First is the row number, rank, and the dense rank. These are the only three ranking functions that are available with SQL Server. Now, how does each of them work? The easiest thing, the good thing about these is that you have the exact same syntax for all of them. Okay, so how do we write them? Let's say select star from I have a ranking table. If you remember in the beginning of I created two tables. One was the population, which I've already shown you. The other is the ranking. The ranking basically has two countries, as you can see, A and B, and then it has cities inside each of the countries. Okay, and then the population against it. Very simple table, three columns: country, corresponding cities, and the population. Now what I'm trying to do here is, if I want to get let me show you how you can apply the ranking functions on top of this data. So here I say, instead of select star from ranking, I just add one more column here saying row number. Okay, this is the syntax: row number, bracket open, bracket close, over, and then order by the population. So if you're ranking it, you need to basically provide a column on which the ranking should be done. Sounds good? Because so the questions that you get, the queries that you might have is get me the ranks in order of salary, get me the third salary, get me the fourth highest salary. So you need to sort it based on the salary, and then you can get the ranks, right? So here I want to sort it based on the population and get the rank for each of the country, each of the city. So what do? I say star comma row number each of the rows over order by the population in descending order. That means the highest population should be given the first rank, and then the subsequent ones will follow. And if I run this, it will give, see, as you can see, it sorts this whole table in the based on the population, and then assigns a rank value each. The rank value is just the alias name that I've given here, as you can see, rn key value. So it sorts them and gives a row number to each of them. But observe this has the same. So the country A has two cities, M and G, which has the exact same population, and it gives them two different rank values. And that's the property of the row number. That is how the row number works. It basically sorts the data based on whatever sorting mechanism, sorting column you have specified, and then assigns a row number to each of the records. Okay, the next is the rank function. The syntax is exactly the same as I told you. I mean, the good thing about these is that the syntax is exactly the same. So I just replace the row number with the rank. Now the rank, let's see what is the difference between the two. The rank function again sorts based on the population, but now if you see, for the same value it gets the same rank, but there's one catch. You see, the next one skips a value. So if there was another city with the same population, it would have got another 3 here, and the next one would have been directly 6. So as many ranks that are used up by the same value, that many row numbers are skipped. So here we had 2 with 3s, so the next one skipped only 1, so it is 5. If we had 3 with the rank 3 records with the rank 3, then it would have been a 6. Okay, now the dense rank works exactly like a rank, but the only difference is that the skipping of the rows is not available here. The ranks are not skipped anymore. You see here, after 3 we get 4 directly. Okay, there is no skipping of the ranks. Similarly, these two values are the same, but this one does not skip any rank. Okay, now you might say, hey Dinesh, so how do I get the highest? So this one I can easily get the third highest or the fourth highest population from the whole table. But what if I want to get the second highest salary per country? How do I get it? So that is where you can use another property of the ranking functions, which is the partition by. So the partition by acts like a group by. Okay, the here what we specify is, I say exact same syntax, but here you can say over partition by country. That means the country A will have its own set of ranks, country B will have its own set of ranks. Let me run this and show it to you. So we have the partition by country and then exactly the same however it was. So if I run this, you will notice that for all the records of A, you get one set of values. Then from B, it is reset again. See, it starts from 1 again. Make sense? But the property of the row number still stands valid. For the same, you get 2 ranks. Coming to the rank, again, let me show you by adding the partition by here. And if I run this, you will see that the same population value gets the same rank, but the next one skips a value. This is the property of the rank function itself. Okay, the reason it skips one row is because there are 2 ones here. Let's say there were 3 ones, the next one would have had 4 directly. Okay, so as many number of rows that have duplicate values, that many number of ranks are skipped in case of rank. Okay, the dense rank exactly works exactly same as the rank, but the only thing is there is no skipping of ranks that happens here. You see here, so we get a set of ranks for A, we get a set of ranks for B. So now if I want to get the second highest salary or second highest population from populated city from A and B, I can say so let's say here, let's say third highest populated state from each country, I say partition by country, sorry, partition by country, and let me run this. So what you will see, you already know how it works. The dense rank, it gives us the same rank, and then the next one doesn't skip anything. So it's as I partitioned it, A has its own set of ranks, B has its own set of ranks, and I put this inside like a subquery. As you can see, this acts like a table. So I say select star from this one as X, where the rank value is the alias name for this one is equal to 3. So if I run this, it gives me 2 records. So for A, city Z has the third highest population. B, for city P, this is the third highest population. For country B, this is third highest population for country A. Now, if you want the third highest population for the whole table, you don't use the partition by, because then it will not rank it based on the country, but based on the whole table. And if I run this, see, I now see that, okay, country A has 2 cities which has the third highest population across the whole table. Let's move on to another interesting topic, which is about indexes. Okay, indexes are pretty much fun to work with. Why do we need indexes in the first place? The importance of indexes has picked up drastically over the last few years, owing to the fact that we are now using SQL Server to store huge amount of data. Okay, earlier it used to manage like small relational databases, but now that Microsoft has been standing up to its expectations, companies are trusting SQL Server for their go-to RDBMS. So they are pumping in a lot of data, and Microsoft is on top of all these expectations, ensuring that whatever data being pumped in, like irrespective of the volume of data that's been pumped in into any SQL Server, the SQL Server performance should not take a hit. Okay, if not be like awesome. I mean, they don't want the performance to be like great, but it should not at least deteriorate over a period of time. That is what Microsoft's whole motive is behind building indexes. Now, what exactly happens when we write a query? Let's say I write an update, let's say I write a select, let's say I write a delete. Okay, now when I'm trying to fetch data, it could be a plain select. Now, what do you think takes the maximum amount of time? Let's say I say select start from employee where employee name equal to Dinesh. Now, what do you think takes time in the query? Let's say the query takes 5 seconds. 80 to 90% of the time, or I would say to generalize it, maximum amount of the time is taken by SQL Server to locate the employee with the name Dinesh. Displaying it doesn't take time, okay? But locating the row itself takes the maximum amount of time for any query, maybe, okay? And with indexes, SQL Server is, or SQL Server tries to give us a mechanism which we can use to locate the rows faster. And if SQL Server can locate the rows faster for us, obviously our query will start executing faster. You get the link? The whole motive, okay, this is what the base target of an index is. The base target of an index is to be able to locate the rows faster. And if you can look, if it the earlier the records can be located, either selecting it, updating it, or deleting it isn't going to take any time at all. Okay, so let me walk you through in detail about indexes and see how they are helpful. So indexes are routes to high performances in SQL Server. And as I explained you, indexes help in faster access by providing swift access to rows in the data tables. Now, how does it do that? I'm going to explain you in a phased manner. This is very similar to an index page in a book. Now, let's say you are given the exact same book to you and your friend. Okay, you guys have the same exact book. Now, you know what an index page is, right? The table of contents that we have in the beginning of the book, wherein it says this topic is located at this page number. This topic can be found in this page number. This topic can be found in this page number, right? So what we do is, now let's say I ask to both of them to locate the topic on joins. Let's say, obviously, I mean, it's a book on SQL, so there will be a chapter on joins. So I just wanted to check where exactly is the, I want both of them to locate the page where the chapter about joins is there. Now, in which case do you think the individual will be able to locate the page faster? Obviously, the individual with the book which has the index page in it, because he can directly read through the index page and see which topic, which exact topic has the topic on joins, and can directly seek to that part of the book instead of checking one each page. But the other guy, he has to scan through the whole book from the beginning till he locates the topic or the chapter on joins, right? And that is exactly how SQL Server indexes work. If you have an index, it is like a book, it's like a table of contents for the whole table. Whereas if you do not have an index, SQL Server will have to search through all of your records to be able to locate that record for you. Now, you take a call which one is a faster approach. I'm going to show you, okay? I'm going to explain you in detail, don't worry about it. And as I told, Microsoft is on top of this, okay? It's like every release of SQL Server that you get, the maximum amount of changes, you will see a lot of changes, in fact, on indexes that's been done by, or that's been released by Microsoft. Okay, with the growing expectations, with the growing base of customers for SQL Server, Microsoft has to stay at the top of its game in order for it to stay long in the market. Now, the one worst thing that could be associated with the RDBMS is its performance aspect. If there is one organization who starts complaining about RDBMS on its performance aspect, that's the bad that that's the worst that can happen with the RDBMS. Okay, when we store data in RDBMS, I mean, data is very important in today's context. And if you are able to store the data efficiently, but when you're extracting it, you have performance issues, you have data issues, I mean, that's the worst that can happen to any RDBMS. So Microsoft has to ensure that the performance or the experience of the users are always top notch, right? So it does a lot of changes to the way the indexes are structured and organized at in every release that is done for SQL Server. Now let's talk about the structure of the index, basically how the indexes are structured internally. Okay, so indexes are created on tables or views. We are going to talk about views, okay, at a later point in time. They provide, as I told, faster access to the data using the column on which the index is created. Now, let's say we create, so as I said, we create indexes on columns in the tables, right? So indexes are created on tables, but internally they are created on the columns. So we specify on which column should the index be created. Now, let's say I'm trying to fetch the name or the address and my index is on the ID. So it's not always that you need the index to be on the name or on the department to be able to locate them faster.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which SQL keyword is used to retrieve a maximum value? A. Most. B. Top. C. Max. D. Upper. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
It could be on the employee ID as well. And the moment the employee ID is located, the rest of the data for that particular employee will be very easy to locate. Okay, so they provide faster access to the data. And when I say data, I'm referring to the whole data row using the column on which the index is created, or as we call it as the indexed column. Indexes internally are B tree structures, or as we call it as binary tree. I don't know how many of you are aware about data structures, but we have something called as a binary tree, which has parent and child structure. So basically, each parent will have two child nodes. Similarly, that the two childs that we have will have two child respectively, and it keeps going on. So that's the reason it is called a binary tree, because each parent has binary or two children. Okay, so these are binary structures which helps us in flattening our tables and hence providing easy access to the data rows. Okay, now I'm again going to explain this in detail at a later point in time, but imagine this example. Okay, let's say you have a set of 10 t-shirts. Okay, 10 t-shirts which are placed one after the other in a queue, and you are looking for one t-shirt. So what do you do? In order for you to search for it, what you do is you search one by one, starting from the first until you reach your t-shirt. But imagine all of them are in a circular pattern and it's been just shown in one line to you. Searching it becomes a little easier, isn't it? So that is a part of how indexes work. Okay, but there are more technicalities to it that I'll be explaining you. So that is what flattening means. So you don't have to like run through the whole queue to search something, but instead you have a more flattened version so that you don't have to recursively loop through all the levels. Okay, without an index, a table is called as a heap. So any table without an index, we call it a heap. And we can create indexes on most data columns in a tabular view, except for a few, which are the blob data types, image data, text data, and varchar max. Okay, I'm going to explain you, once I explain you how indexes work, you will clearly understand why SQL doesn't allow us, or why it is inefficient, or why it should have been inefficient if SQL would have allowed us to create this, would have allowed us to create indexes on these data types. But indexes are very, very effective and efficient when created on unique integer column. Okay, so again, you're going to understand both these points once I explain you in detail about indexes. Now let's say there is a table. Let me give you an example. Let's say there is a table with let's consider this as an employee table itself. It has ID, name, designation, salary, department. So 5 columns, and here I've just displayed the ID column. Okay, let's say there are 20 employees in the whole table. Now let's say I write a query saying select star from employee where employee ID equal to 10. Okay, this is a very normal table that you see. Okay, imagine this has no indexes at all. Forget about indexes. This is a very normal table, and on top of this, this has 20 records, and on top of this I fire this query wherein I want to fetch the employees where employee ID equal to 10. Now what will be the expected output? It'll give me all the employees which has ID 10 in it. Am I right? So if there are 5 employees with ID 10, it should give me all the 5 employees. So what does it do to figure out all the employees which has ID 10? It first checks the first row to see if the ID is equal to 10 here. So 1 is not equal to 10, so it skips this row. Next, it moves to ID 2. It checks if 2 is equal to 10. No, it is not. So it moves on to the third row. This way it continues this way to make sure, or to it makes sure that it compares all the IDs with 10 and fetches those records which are equal to 10. Like for example, this record would be fetched. Let's say there is another 10 right before 20. That 10 will also be fetched. So whatever number of employees has employee ID equal to 10, all of them will be fetched and displayed. So in a way, SQL will have to, the optimizer will have to check through or compare all the 20 rows in the table to be able to figure out all the employees which has ID 10, right? So in this case, without an index, the SQL optimizer will have to perform 20 reads. Let's assume that this table has 20 records. It has to perform 20 reads to locate all the IDs, all the employees with ID 10. And this approach is referred to as a table scan. That means the whole table is scanned for it to return the result that I'm looking for. Now let's see what happens when we create an index on it. So let's say I create an index. The index, as I told you, it creates a binary tree structure. So let's say I create an index on the ID column. So what happens is when I create the index on the ID column, it tries to create a binary structure internally. So how does it do it? The parent will be 1 to 20. So there are 20 records, right? So there will be two nodes for this. So 1 to 10 can be found on the left hand side. So every node will have an upper range, will have a lower range. So here the lower range is 1, upper range is 10. On the right hand side, I mean on the other node, the upper range is 20, lower range is 11. And then 1 to 20 might have another two child nodes, okay, very similar to how the first level went. And the same thing can be for 11 to 20 as well. And then these are basically the bottommost leaf nodes where you will find the data for those particular rows, right? So let's say here after 1 to 5 it has two children, 1 to 2 and 3 to 5. That means you will find all the details for employee ID 1 and 2 in this leaf node. You'll find all data for employee ID 3, 4 and 5 in this leaf node. Now let's try to run the same query using this approach. So what does SQL do now? In case there is an index present, what it will do is it will know that, okay, I'm looking for ID 10. So all the 10s, I'll find it here because the left hand, the first node, child node, has a lower range of 1 and higher range of 10. So all the IDs will be, all the 10s, I can find it in this part of the node. And from here, I traverse here and then ultimately it'll locate here where all the 10s can be found. So with an index, it takes up to what, 1, 2 and 3 reads to locate the whole data or the whole record for ID 10. So maximum, I would say it would take up to 3 reads, and this approach is called as an index seek, wherein the data is directly seeked. Okay, SQL directly seeks the value that it is looking for. Instead of scanning everything, it just directly seeks through the nodes to be able to locate those particular IDs that you're looking for. Okay, and this is what flattening of a table means. Now, this has up to 20 levels, so it has to scan all the 20 levels, but here it has to scan maximum of 4 levels. Now this the current when I'm talking about the real SQL Server, I mean this is just an hypothetical example, okay, of 20 rows that I'm giving, but SQL Server has a more sophisticated, I mean a hugely sophisticated mechanism to handle this, and I don't think for 20 records it will have at least these 4 levels. It'll be way less than for let's say thousands of records, you might have only one level. It doesn't even go to more than 1 or 2 levels. Okay, so that is how SQL does it internally. But again, this is just an hypothetical example so that you understand this clearly. And this is what the B tree structure looks like. And as you must have noticed, the whole onus of this particular structure being created by SQL Server lies in the fact as to how easy it is to sort your data, how easy it is for SQL Server to arrange your data, right? And integer sorting is very easy and comprehensive. But when it comes to varchar sorting, the limitations that are there. Plus, varchar sorting is lot more memory extensive, lot more time taking than integer sorting. Okay, so greater the varchar value, greater the string value, bad is going to be the index performance. I mean, the impact of the index is going to be negligible, because creating the index and then sorting it like this and arranging it like this is going to be a huge task for SQL Server. So I'm not a big fan of creating indexes on varchar values at all. Okay, SQL forbids creating it on varchar max, which is when you have a column of 8,000 characters long. It only forbids that. So you can create it on columns which has varchar 100, 200, 300, up to 7,999. But I'm not a big fan of creating it on varchar values at all, varchar columns at all. So this is the reason SQL forbids creation of indexes on a few column types. Now the second thing is, I told you why integer is preferred, why integer data type is preferred. But the best thing could be if you can create an index on a unique integer column. Now, why do I focus on unique keyword? Because the uniqueness of your column determines how your index structure is balanced. Now, let's say you have 10 records with ID 10. That means you have duplicate values in there. So now what will happen is, when you have 10 records with ID 10, this particular node will be heavier when compared to this particular node. Am I correct or wrong? Because here, as I said, the upper range is 10, sorry, the lower range is 10, upper range is 10, lower range is 1, upper range is 10. So that means we'll have 1 till 10, all the records in this part on the left hand side of the node. So that means if, let's say, there are 10 records with ID 10, I'll have 19 records on the left hand side and 10 records on the right hand side. So obviously this part of the node will perform slower. The left hand side of the node, the left node will perform slower when compared to the right node, because on the right node there are only 10 records, on the left node there are 19 records. Okay, so this node becomes heavier, ultimately this node becomes heavier, this node becomes heavier. So when the query hits this node, okay, or any of these nodes, it works faster, the data is retrieved faster comparatively when compared to this part of the node, the left hand side of the node. So that's the reason, if you want to keep the index performance consistent, make sure you create your index on a unique integer column. That's the best. Okay, it's not like SQL doesn't allow you to create it on non-unique columns, but it's just that the index might not be efficient enough. Okay, now that you understand the indexes, let's just understand what are the, let's just go read about what are the different types of indexes that are involved. Okay, and then I'll show you the demo on how indexes enhance the performance of queries. So let's talk about the types of indexes that are available. The two important types of indexes that you have are called as clustered indexes and non-clustered indexes. Now the clustered indexes, in the clustered index, the complete data row is actually stored in the leaf node of the index. Now when I say that, what I mean is, you see this is the leaf node, the bottommost leaf node. So here what you will find is, let's suppose this node. So this node will have the whole of all the data or information for employee 8, all the information for employee 9, all the information for employee 10. That means all the 5 columns that I was talking about: employee ID, name, designation, salary, and address, let's say. So you'll find all the data in here itself, and that is what I have mentioned here. The complete data row is actually stored on the leaf node of the index in case of a clustered index. Okay? The index column is either arranged in ascending or descending order. As I told, it requires sorting, and that is where it is more efficient. The better the sorting is available, the better the sorting, the better is the performance. And this sorting is done physically in the data drive itself or in the table itself. That means, let's say you have inserted records in the order 1 5 4 sorry 1 5 4 9 7. Okay, when you create an index, let's say on this column, you will now get the data. I mean, whenever you select the data from the table, you will get it in this format: 1, 4, 5, 7, 9. So that means the data will be sorted like this. So when you create a clustered index, whenever you create a clustered index, the indexed column is physically sorted in the table itself. I would say in the table. Okay, that means when you select the table, you will see that the data will automatically come sorted. You don't have to put the order by, and that is done by the clustered index. Okay, when you create a clustered index, it automatically sorts the data. So whenever you select the data, it will come by default sorted. And that is the reason you can have only one clustered index per table. Remember, because the second column ordering has negligible impact, right? So that's the reason you can have only one clustered index per table. Now, you can include multiple columns in the clustered index, right? As I told, you can have only one cluster index, but you can include two columns. Like let's say the combination of name and ID is unique. You can include two columns in your or name and address is unique. You can create name and address as a clustered index on name and address both together. Okay, there'll be one index, but internally it'll have two columns. Now you can do that, but I don't usually recommend it. Again, imagine this structure being built for two columns. Obviously it will not be efficient when compared to a single column, right? So I usually say create it on one column which you think is a primary key, and that's the reason I always say that whenever you create a table, create a primary key in it, so that you can create a clustered index. In case that table grows to a lot many records, you have the liberty to create the clustered index on the primary key, because the primary key is both unique and not null. So it's easier that way. Table with a clustered index is usually referred to as a clustered table. That means any table with a clustered index is usually referred to as a clustered table. Now coming to the non-clustered index, there's a slight change. There are a few things that are different from the clustered index. Unlike the clustered index, here the leaf nodes does not store the actual data row. Now here what happens is, so as I was saying, in case of a clustered index, the whole row is stored in this leaf node, right, for 8, 9, and 10. But in a non-clustered index, what we'll have is we'll have the indexed column, which is 8, and then there will be an address pointer that will point to the actual row of the table, okay, where exactly in memory that row is present. Similarly, 9 will also have a pointer that points to the memory location of that row. The same applies for 10 as well. This is how the non-cluster index works. So SQL has to perform one extra operation after locating the row, wherein it has to take the pointer, go to that particular address, and fetch the whole row. And that is what makes non-clustered indexes a little slower than clustered indexes, because in clustered index, the optimizer can locate the row in the leaf node itself. So it doesn't have to go anywhere else. But in a non-clustered index, it has to take this pointer, go to the memory, and then fetch the record from there. So locating the row is still fast in case of a non-clustered index, but taking the pointer, finding it in memory, and locating the row takes that extra little bit of time, which makes non-clustered indexes a little slower than the clustered indexes. As I said, instead it stores a pointer or memory address to the row in the memory, so that SQL optimizer can extract that whole row. Now the non-clustered index column, the data is sorted but on the fly. So you will not find the data sorted as I showed you in the non-cluster index. You will not, that is not how the data would be sorted in the disk. It would be sorted but on the fly. Okay, so the structure will be created on the fly only for that particular fragment. It won't do it for the whole thing. It won't sort it on the table itself. And that is the reason, as it does not physically sort the data, you can have more than one non-clustered index on a table. To be specific, till SQL Server 2005 used to Microsoft used to provide 249 non-clustered indexes, but 2008 onwards you can create up to 999 non-clustered indexes. Not that I would recommend you to create that many, but yes, you have the liberty to create up to 999 non-clustered indexes per table. Okay, this is per table I'm talking about. So let's get into an example. Let me explain you with an example as to how this actually how the indexes actually speed up the performance or make the performance better for the queries. Okay, so what I'm going to do is I'm going to use the same table which is on a different database. I'm going to extract it or copy it into two tables in our database, one with the name index test, one with the name index test underscore CI. That means the table names will be different, but the content will be exactly the same because I'm copying from the same table from a different database. So let me execute this. So I get 10,000 records each. Let me comment this back again. And if I show you this table, it has only two columns, ID and name. Okay, ID is 1, 2, 3, 4, 5. It's an auto increment value. And then the name is nothing but Dinesh appended with the ID itself. Okay, and we have this for 10,000 records. Let me show you. See, it is there till 10,000 records. Okay, and the same is for the other table as well. As I told, both of these have the exact same structure and the exact same data. As you can see, this is the one. Now, the reason why I gave this a different name is because I'm going to create a clustered index on this table. This is underscore CI. Now, none of these have indexes in it because these are normal tables, right? I just created them. So how do I create a clustered index? So I say create clustered index, okay? And then you give a name to your index. So here I say ix underscore, and then to make it, as I always say, name your objects so that you can look at it and know or tell a lot about it. Like here I say ix underscore, which from which I can know that okay, this is an index. Then I have the table name here, and then on which column am I going to create the index. So I have ix underscore table name underscore id, and then I say on, that means create the clustered index on index test underscore ci. This is the table on which I'm going to create the index, and the column name is id. So I'm going to create the clustered index on the id column in index test underscore ca. And let's create this. So it says commands completed successfully. Now, how do you know if there is an index or not? You can double click on the name, use Alt F1 again, and if you scroll to the bottom, you will see that there is a clustered index. You see there is an index name, clustered index on the ID column. But for the other table, now we have it for the index test underscore CA, but for the index test, you will see that there are no indexes. See, there are no indexes. So this table has no indexes. This table has an index, which is a clustered index on the ID column. Now, let me open another query window here and get this parallel to this. And what I do is I run two exact same queries on two different parts on the two different windows. Okay, so in one of the window I say select star from index test where id equal to 7748. On another part of the window I say select star from index test underscore ci. Okay, so this is the table with the index, this is the table without the index, right? And I'm trying to run the same query on the same table with the same amount of data, but the only difference is one of them has an index, one of them doesn't have an index. Okay, now before I execute these queries, let me enable the execution plan. Now, what is an execution plan? I'm going to explain this to you in detail when we talk about stored procedures, but just to give you a brief about it, execution plan. So every time we execute a query in SQL Server, the optimizer generates an execution plan before executing the query, or before in fact returning the data to us. Now, what does the execution plan do? The execution plan would, so the optimizer, based on what tables are being joined, what columns are being used to join, what filter conditions are used, so using all of those, it generates a plan as to how that query should be executed efficiently, or what route can SQL Server use to execute that query, okay, and give us the result. So that is known as an execution plan. I'm going to explain that in detail, okay. Now there is a way in which we can see what is the execution plan underlying the query that we are executing. So that can be seen here. You see here there is a include actual execution plan. You can include the execution plan click on here, and whenever I run this query now, it'll show me the results along with the execution plan as well. And let me do it on this query window as well, because this query window does not have the option turned on. You see, it's not highlighted. So let me do it for here as well. Now let's run both these queries. So this one is done, and let's execute this one as well. So I have both these query executed on two sides of my window. Now, if you see here, the output that we get is exactly the same, isn't it? 7748, Dinesh 7748 on both sides of the window. It's a very simple select command. Okay. Now, if you observe, there is one more tab. So earlier we used to see only results and messages. Now you see one more tab here, which is called the execution plan. Now, this is what I was talking about a little while earlier. Okay. Now, what is the first thing that you see as a difference? The first thing that you clearly see is, if you hover on top of this, you see on the top, you see the operation is a table scan. That means this query would have scanned the whole table to locate the records with IDs 7748. And on the other side of the window, you can see that the operation is trusted index seek. That means it has fetched it from the binary tree structure. It has seeked the value instead of scanning the whole table to locate it. So without the index, I have created two blocks here. One is without index, one is with the index. So without the index, the operation is table scan, whereas with the index, the operation is an index seek. Let me just reduce the font a bit, maybe. So this is the first visible difference that you can see. Now let's see some more statistics here. Okay, let's just hover on top of this, and if you see the 1, 2, 3, 4, 5, sixth number metric from the top, look at the sixth metric from the top. It says number of rows red. You see, the number of rows red is 10,000 here in the table scan, because it scanned through the whole table. So it would have basically gone through or checked it would have read all the 10,000 rows to retrieve only this record. Okay, so the number of rows read are 10,000. Now let's check on the table with the index. Here, if you see the same metric, the sixth metric from the top, you will see that the number of rows that are read is only 1, right? So it did not even bother to check the other records, because by using the binary tree, it was able to pinpoint or seek directly to that value or that row instead of scanning the whole table. So you see, clearly there's a difference here, and it is on the number of rows read. On the number of rows read for without an index, in a table scan, it looks through all the records, but here it only fetches one. Now this is only on 10,000 records. Imagine a table with millions of records in it. Is going to be huge, right? It's going to be saving you a huge amount of time and resources. Now obviously, when we are reading more number of rows, when we are performing an operation, these are basically on SQL. Okay, but do you know that whenever we execute a query in SQL Server, it also takes a part of your system resources? That means, let's say MySQL Server is installed, the SQL Server that I'm working on is installed on my laptop. So every time I execute a query, it consumes a small bit of my computer resources as well, of my laptop resources as well, like the input output. Okay, if I again hover on top of this, you will see the estimated input output cost, which is
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description. Now, let's continue with the session.
the 7th, 8th, 9th metric. You see the 9th and the 11th metric, estimated input output cost and estimated CPU cost. It's 0.027, the IO cost, and the CPU cost is at 0.0110. So the input output and CPU in case of in a table without an index with 10,000 rows is this. Okay, which is a very small number, to be honest. But let me show you the numbers when it is running on an indexed table. When the query is run on an index table, you can see that the estimated IO cost is at 0.003125 and the estimated CPU cost is at 0.00015881. Now here I have put all the numbers for you. You see this on the top is are the numbers for the non-indexed table, and this is for the indexed table. Now these are system resources I'm talking about. Okay, this one it took 0.027, this is 0.0031, so it's almost 50, I would say what, 1/10 of what it took here.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following SQL clause is used to delete tuples from a database table? A. Delete. B. Remove. C. Drop. D. Clear. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Again on the CPU, if you see it is 0.011, it is here it is 0.00015. So this is also 100th time of the resources of the CPU that the earlier query took. Imagine this is the improvement that I can get on a table with only 10,000 records and with a very simple select, with complicated selects, with complicated updates, with complicated deletes, and on a much higher or in a much bigger table, the improvement is going to be huge. Okay, and this is how you read it. Basically, whenever I look for optimization, I see my query, the operations I see. So if I see that there is a table scan somewhere, I know that there is a problem. I know that I have to fix it, because table scans are never good in the SQL Server context. I mean, there are a few scenarios, but that is too complicated for you to understand now, so I'm going to skip that part. But yes, most of the times table scan are bad compared to index seek. Okay, so let me close this one, say no. Again, as I say, indexes I always say are a necessary evil. Okay, that's the reason I say, although you have the privilege to create a lot of indexes, a lot of non-clustered indexes, don't blindly go ahead and create them. Okay, indexes are a necessary evil. The fact that the reason behind it is the whole performance of your table now completely depends on this structure. And when you add more rows, when you remove rows, when you update rows, this structure goes for a toss. Let's say you add 10 more records on this table. Those 10 records is not a part of the index unless you refresh the index, right? So until you refresh your index for the new records, it will still run slow. So try to limit your indexes to as less number of columns as possible. Do it only on the columns that you really need, because DML operations are going to get slower with the more number of indexes. Because as I told, sometimes, I mean, when you, let's say, consider inserting, updating, or deleting small number of records, SQL optimizer tries to rearrange your index to fit in those small number of records. For huge number of records, I mean, it cannot do it. But for small number of records, it tries to update your index structure. It tries to adjust your index structure here and there. So that's the reason more the number of indexes, more time SQL takes to perform your updates and deletes, because internally, although your operation is finished, it is trying to rearrange your index, do minor adjustments on your index structure. Okay, so these 2 points are something that you need to keep in mind when you are creating indexes. Okay, create indexes on columns which are very rarely updated. So here, that's the reason I say, for heavily updated table, keep the index columns to as few as possible. Okay, when there are not much updation happening, you can create as many indexes as required, because there is no DML operations happening, there is no insert, update, delete happening, so you can happily create as many indexes as you want. But is it practically possible? There cannot be a scenario wherein you don't insert, update, delete into a table and the data keeps growing. I mean, it's practically not possible, right? So there will be DML operations done on the table. So make sure you limit and create only the required columns as indexes. And as I said, for clustered index, create it on the unique integer column, preferably the primary key, because the primary key has, as you know, only unique values and not null values. So the primary key is an ideal candidate for the clustered index. Okay, and just for your information, whenever you create a primary key on a column in a table, by default SQL Server creates a unique clustered index on that column. As I've been saying, SQL also knows that the ideal column for a clustered index is the primary key. So if you create a primary key, automatically SQL Server creates a unique clustered index on that column. And when you create a unique column, I mean a unique constraint on a column, SQL by default creates a unique it creates a non-clustered index on that column. Okay, so these are the default indexes that are created, but you can obviously choose to override them if you want. Right, so let's start by talking about stored procedures. What are stored procedures and how are these important in the SQL Server context? Stored procedures, let's start with an example maybe. Okay, let's say you are asked to design queries to calculate the salaries of the employees. Okay, that means let's say you are given an assignment or a task saying that, hey, we want you to build queries that would calculate the salaries of our employees in the database. So you need to follow certain number of steps or perform multiple operations to successfully calculate the salary, right? I have tried to list out a few of the steps and let me guide you through each of them. First, you might need the list of active employees from the employee table. This is very, very important. Now, why do I say this? It is important because let's say there are 10,000 employees in your database, and out of that, let's say there are only 1,000 active employees. So there is no point or there is no need for you to calculate the salaries for the rest of the 9,000 employees. Is it? It's not needed, right? So you first need to take the active list of employees from the employee table to start off your calculation. I mean, you can consider each of these as a or put them into a temp table maybe. Okay, you can do it any way that you wish to do it. Next, you would fetch the leaves from the leaves table. Let's say there is a employee leave table, and in there you might want to fetch the leaves of each of the employees, obviously. Now, once you have the leave balance summary for each of the employees, you might have to calculate the LOPs or the loss of pay. Now, loss of pay is something wherein, let's say you are eligible for 5 leaves in a month. Okay, let's say you take 7 leaves in that particular month. So you are qualified to, or the company can deduct, the organization can deduct 2 days worth of leaves from your salary. Okay, 2 days worth of salary from your whole monthly salary because you have taken 2 extra leaves, which is something that you are not eligible for, which is beyond your allotted leaves. Okay, so those are called as loss of pays, okay, or LOPs. Now there can be the other way around also, right? The other way around is also possible, wherein there can be 5 leaves allotted to each employee, and some of them might have taken less than 5 leaves. Let's say there is an employee who has taken only 3 leaves. So you might want to credit the rest of the 2 days worth of leaves in the form of 2 days salary to the employee. So either you do a loss of pay or you can encash their leaves into their salary. So this is something that you need to add to the salary of that particular employee. Next, you would want to get the salary components, the different components of salary from the salary table. Like there can be multiple components like the house rent allowance, there can be the dearness allowance, there can be the basic amount. So all these multiple different components can be used or can be extracted from the salary table so that we can calculate them together. We can sum them together so that we can derive the salary. So first we take the leaves so that we can either choose to either add the extra leaves or deduct add the remaining leaves or deduct the extra leaves that has been taken. Then we take the whole salary components, and also we can add the bonuses or the incentives to the calculated amount. Let's say an employee is eligible for some bonus or for some incentive, that can also be added to the final amount. And end of it, the funny part is you'll also have to deduct the taxes that has been that particular employee is eligible for. So Now that you have everything calculated till here, the final step would be to calculate the tax on top of the salary that they are going to be paid. So this is also a deductible amount. So you see, this is a very constructive and a thought through approach to calculate the salary. Now you cannot bring this active list of employees step to the end of the calculation, can you? Because you would then end up calculating the salaries for all the employees, which is not a good idea. So it should be performed in a sequential approach or in a constructive approach, so that you save on system resources, plus you also make or calculate the data efficiently. Okay, now this is just an example. Okay, this is just an example that I'm trying to give you. Now when you have situations like these, wherein there are multiple steps involved in sequence, okay, you might end up having, let's say, 50 or 30 SQL queries to perform all these steps. Now let's say that query, or let's say there are multiple departments who wants to reuse it. Okay, let's say there is another department which wants to reuse this calculation. So what do? Do you give them the query for them to execute on their department? Let's say there is a third department tomorrow who wants to use this same salary calculation procedure. So let's say end of the day or end of the month, you have 10 departments where the salary calculation should be implemented. So do you pass on this query to all the 10 departments? I agree. I mean, you can still do that. Okay, you can pass the 30 SQL queries that you have written to perform all these operations, and they could plug it on their department. But is it efficient enough? Is it maintainable enough? The answer is a strict no. Tomorrow, let's assume that the company says, okay, when we want to change the policy of the encashment of the leaves. Okay, earlier we were paying 1 day salary per leave, but now we want to only pay like half a day salary of the for each leave. Let's say, I mean, any such change. So in that case, what do you have to do? You have no choice left but to change in all the 10 departments the calculation logic. Am I right? Because you have used the same query across all the departments. So it's very bad on the maintainability aspect. This is where stored procedures comes into picture. So you put all your queries, all the 30 or 40 queries that you have inside a stored procedure, and wherever you need them, whenever you need them, just call that procedure and it would do or perform the internal operations on that particular object. Okay, and also when it comes to the maintainability aspect, let's say tomorrow there is a logic that has been changed, there's a new bonus or a new incentive that has been added to the new bonus or incentive that has been added to the salary component. You just have to change it in the procedure where you're calculating the salary. Automatically everywhere else that the table is being used, or the procedure is being used, will now calculate the salary using the new logic. So what are stored procedures? Stored procedures are blocks or batches of SQL statements. Batches in the sense there can be multiple queries together that are executed together in a specific sequence to serve a definite business purpose. And it can be reused as and when required, and it is accessible to everyone who has access to the database, provided they have execute permission on the stored procedures. I mean, as I've told you earlier, the security privileges is very beautifully defined in SQL Server. So you can control who can execute your stored procedures and who cannot. Okay, you can also restrict people or users. You can give them access to view the data in the tables, but can restrict their access to execute stored procedures. Okay, but yes, I mean, it can be reused at multiple different places and is accessible to everyone who has permissions to view and execute them. Now, what can a stored procedure do? This is where I'm going to give you a few examples, a few differences between the stored procedures and the function. Now, what can a stored procedure do? A stored procedure, unlike a function, can perform all kinds of operations. It can be creating a table, dropping a table, it can be also updating data, deleting data, inserting data, taking backup of the database, restoring the database, any kind of operation that can be written in SQL okay, can be put in a stored procedure. Whereas a function, it can only perform selects. It cannot even perform DML operations as well. Now, where are the stored procedures created? The stored procedure is created and becomes a part of the database. So wherever we create the procedure, it is created on that particular database and it is stored in the schema where it is created. Obviously, the default schema like other database objects is DBO, unless we specify another schema where it should be created. So let's say it's created, if you want to create it on the food schema, you can create it there. If you want to create it on the clothing schema, you can create it there. Any type of schema, but the default is DBO, obviously. Now, why do we have to prefer? The big question is, why do we go with stored procedures instead of the normal queries? Is it just because of the reusability and the maintainability factor? No, there is in fact more to stored procedures than what it looks like. The first main reason as to why we use stored procedures is because of the encapsulation property. Now, what is encapsulation? Okay, encapsulation is a OOPS concept. It's an object-oriented programming concept. Okay, let me give you an example so that you're clear about it. Let's say you go to let's say you're sick. Okay, I mean, you have food poisoning or something. Okay, will not go with flu or fever or anything given the circumstances, but yes, let's go with stomach upset. And you go to a doctor and you tell what your problems are, and he gives you a couple of tablets, maybe a couple of capsules to take. Are you really worried about the chemical formula or the combination or the content of that particular capsule, or are you really bothered about how to consume it, when to consume it? I would obviously worry about when do I eat it and how do I eat it, rather than asking what are the contents of the capsule or what is this capsule made of. This is a classic example of encapsulation, wherein we are just bothered about how to consume something, how to utilize something, instead of understanding the internal complexities that are involved in it. And that is what a stored procedure exactly does. We write all of our business logic inside the stored procedure, and when we share it with someone, we just share the name. So they just execute the name, and automatically the logic that is placed inside of it is calculated or is performed. Okay, uh, that's what encapsulation means. It binds complicated business logic into a single unit without exposing the internal content. So no one even knows what is there inside the stored procedure. They just execute it, and let's say the calculation of salary itself. So I just share the stored procedure name, and every department just executes it so that it calculates the salary for their specific department. Coming to the reusability aspect, I've already shared this with you. The SPs are reusable and can be called multiple number of times based on our need by users having execute permissions on them. As I mentioned earlier, you need to have execute permission on the database to be able, sorry, on the stored procedure to be able to execute them. Maintainability aspect is also something that I've already explained to you about, wherein any change that's been made on the data, on the calculation or on the way the data has been transformed, you can always change it only in the stored procedure once, and automatically when the procedure is called the next time from any of the departments, it would automatically use the new calculation to calculate the salary. As simple as that. Okay, now coming to the most important factor that clearly differentiates or clearly puts stored procedures way ahead of SQL queries. This is called as the execution plan caching. Now, to understand this, let's understand what the optimizer actually does when we try to write and execute a query. So let's say you write a query and execute it. There are three main functions, or there are three main steps that the optimizer follows. First, it parses the query. So what does it parse? It basically checks the query for any syntax errors. If there are any syntax errors, obviously it'll throw you an error message that you are missing something here or here. That's the first step. Second, it compiles that query to generate the execution plan. Okay, that means if everything looks okay, if the syntax is okay, if you have written the query properly, it compiles that query to generate the execution plan. And third step, it uses the execution plan that is generated to fetch the data, perform the actual operation. Okay, now what is an execution plan? Let me give you an example so that you understand this clearly. Let's say that you have let's say that you have got a new job in your city. Okay, you have got a new job, and the distance, there are three main routes. There are three main, yeah, let's say it routes. Okay, there are three routes that you can take to reach your office on a day-to-day basis. So for commute, for daily commute. Now, what do you do in the first week? Let's say you have never gone to that part of the city earlier, so you don't know clearly about the routes that are available. So let's say you found out from Google Maps that you have three routes that you can take. The first route, when you take it, you see that you can reach office faster. It is 10 miles from your home, where you're staying currently, where you're put up, to your office. It is 10 miles, but you reach office a lot faster. Okay, because there is very less traffic in this route. Or let's say it is 12 miles. Okay, let's say the distance between your place of stay and your office is 12 miles, and you reach office faster because there is very less traffic. So what do you compromise on in this route? You burn more fuel because of the extra distance, but what do you save on is your time. Okay, so one pro and one con with the first route. Let's talk about the second route. Let's say the second route, when you take the second route, the distance between your place of stay and your office is 8 miles, but there's a lot of traffic in that route. So you might end up saving a bit on your fuel on the to and fro commute, but you are compromising on the time that you are spending to reach office. Okay, so again, one pro and one con in the second route as well. Let's talk about the third route. Okay, let's say that the distance from here, when you use the third route, the distance from your office, from your place of stay to office, is still 8 miles. There is hardly any traffic, win-win situation, but the condition of the road is not that great. You have a lot of potholes, there are construction work going on. They have let's say there's some patchwork that is going on here and there. And what happens is, end of the day, you save money on fuel, good enough. You save on time because it is closer, so it takes hardly much time, but you're compromising on the condition of your vehicle, right? You know that if you go in that route for, let's say, a month or so, you might get a hefty amount of service charge on your vehicle. Okay, so here also you have a con associated. Now, based on your priority, you choose which route do you want to take. If you are comfortable to shell out more money but don't care about the time, then you take obviously the second route because you want to save money on the fuel, right? But let's say you want to uh, you don't care about the money, but you want to save on time, you take obviously the first route. Now, let's say you don't care about your car. Okay, you want to sell it anyways after a month or two, so you take the third route. It's all depending on your priority that you choose which route you have to take. Now, how do you decide? Only when you take each of the routes for, let's say, 2 days in a week. So in 1 or 2 weeks, you get used to the routes, and then you decide, you take an educated decision as to which route do you take for the commute. This is exactly what execution plan means in SQL Server. To execute a particular query, there can be multiple routes that SQL Server can take. Okay, so this is where the compiling factor comes in. So when the optimizer tries to compile the query, it identifies an ideal route that the query is going to take to be able to fetch the data or perform whatever operation has been asked to perform. Okay, now this is with normal queries. Okay, now what happens with stored procedures? With stored procedures, the advantage that we have is, the first time when we create the stored procedure, it is passed once and for all. Okay, so it is passed, and we know that there are no syntax errors, so it does not parse or check for the syntax every time it is run. So we are saving on parsing the query. Second step is the compiling, right, where the execution plan is generated. Now, what happens in case of a stored procedure is that after 3 or 4 runs, SQL optimizer tries to identify the best plan out of the all and caches it in the memory, in the SQL Server memory. Okay, so for the next times, let's say from the fourth or the fifth time, it doesn't have to compile it anymore, which doesn't happen in case of queries. Every time you execute a query, let's say you execute the same query over and over again, it will every time get parsed, it will every time get compiled to generate the execution plan. But in case of stored procedures, parsing only happens the time when we create the procedure, and the compiling where the execution plan is generated is cached in the first few runs, and this saves a lot of time on the query processing. Okay, so the same query when executed normally versus when executed inside a stored procedure makes a lot of difference on the time and the performance. Okay, so that is what execution plan caching really means. The SP when created is parsed and compiled, so it does not compile every time it is run. It also caches the best execution plan in the first few initial runs, which makes it stand out from normal queries. Now, what is an execution plan? An execution plan is the path used by SQL Optimizer to execute your query and return the result. Now, SQL Server creates the execution plan during the query execution, and obviously the SQL query takes that extra bit of time to compile and create the execution plan, which is avoided or which is not necessary in case of a stored procedure after the few initial runs. Okay, and this is what makes stored procedures stand out from normal queries. Okay, now let me show you how to create a stored procedure. Okay, it's very simple. I say create or alter procedure and then give it a name, like so that you understand or you look at it and know that it's a stored procedure. So I give it a name saying CSP underscore. So CSP stands for custom stored procedure. Okay, so custom stored procedure is basically when we create one for our own need. CSP underscore and then obviously a name that justifies the purpose of the procedure. So I say CSP underscore get data as begin, and then here let's say I'm creating a procedure that would just select me the data from the employee table. Okay, as I told, you can do anything that you want, but I'm just keeping it very simple so that you understand it. Okay, here I'm trying to say select me the data from the employee table. Very simple one, right? So let's execute this. It says commands completed successfully. Now how do you know if the stored procedure is created? Obviously you can do alt F1 on this, alt F1, and you will see that this is the name, this is the type is stored procedure, and it's created on 4th of October at 9:52 in the evening. Now that the procedure is created, let's see how to execute it. Again, executing it is also very easy. You say exec and the procedure name, and when I run this, see it gives me the whole data from the employee table. I'm not executing the query, right? I'm just executing the stored procedure, but internally the stored procedure has that query, so it runs and selects me the data. Okay, now let's say you don't want to see the salary column maybe. Okay, so you can alter the same procedure CSP underscore get data as begin, and instead of star you put the ID, first name, last name, and address from the employee table. And if I run this, it says commands completed successfully, and now when I execute the same stored procedure, it would give me everything except for the salary column. You see, I get the ID, first name, last name, and address. So except for the salary, I get everything else. Now, this is more of a static stored procedure, which means every time you run it, it will give the exact same output, okay, or the result set. Now, can we make it dynamic for the user to input a value and based on that, it returns the output? Yes, we can do that by adding parameters. You remember how we used to add parameters inside functions? We can do the same in procedures as well. So here I say create or alter procedure, CSP underscore get data. I'm using the same procedure, okay? And in here, I put the parameter inside the bracket. So I say employee ID parameter of type integer as begin. And here, as you can see, I'm selecting only those columns from employee where employee ID equal to employee ID. Okay, so this would so the user will be asked to input a value here, and that value will be used to filter the employee ID from the employee table. So whatever ID we give here, that ID will be filtered and the details will be returned for that particular employee. So let me create this procedure, and now if I just say execute procedure name, is going to throw me an error saying that procedure or function expects parameter employee ID which was not supplied. Okay, so here I need to pass the value of the parameter which is employee ID. Now if I run this, you see it gives me only the details for John.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which SQL keyword is used to retrieve a maximum value? A. Most. B. Top. C. Max. D. Upper. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
I mean, the ID is 7. So similarly, if I give, let's say 5 here, it would give me the details for 5. Now, let's say you are said, okay, if I don't pass any value for employee ID, give me all the employees. If I pass any value, send me the specific employee details. That means if I pass a 5, get me the details for 5. If I don't pass any value, just give me all the data. Okay, so in that case, what you can do is you can pass a default value, okay, like this. So when you give a default value, let's say I give a default value of 4. Okay, so what will happen is let's alter this, and now if I just execute this much, okay, just execute the procedure, it would give me the default employee details, which is 4. Remember, I gave 4 here as the default employee ID. Okay, but if I pass the value from here, let's say I pass 5, it will now give me the 5 details. So if I pass a value from here, it will take this, else if I only execute this, it will use the default value. Now let's say when I execute this, I should not get 4 but should get all the employees, and when I pass 5, I should get only the details for 5. How do we achieve that? For that, what I do is I set the default value to 0. Okay, and here I put or employee ID variable is 0. That means fetch me all the employees where employee ID equal to whatever value comes in, which is, it could be 1 2 3 4 5 6 7, or fetch me the record if at the rate employee ID the variable is 0. And you know that the or condition would return the records if at least one of these condition is true. Okay, so let's say employee ID, I pass it as 5. That means it will only evaluate this condition to true for ID 5. So it will return only 5. Now let's say I pass employee ID as 0, then this condition will be evaluated to true for all the records, isn't it? So let me alter this, and if I run this with 5, see I get this particular employee. If I run with 6, I get with 6. If I run with 0, I get everything. Or I can also choose to not run it with the parameter and I should get everything. This is all being handled by this condition. If I pass the variable value to 0, that means it'll return me everything. Okay, so you can make your parameter optional by adding a default value here. So the default value to the parameter makes it optional. I know the or condition is a little complicated for you guys for now, but I mean, when you practice it more, you will get to know it. Okay, you will understand this better. Okay, next let's see how to add multiple parameters. So till now we have been only playing around with what, one parameter only. So how do we add multiple parameters to our procedure? So here I say create or alter procedure, the same one. Here I pass the employee ID integer, I give an optional value which is 4, and I also add the address here. This is a mandatory parameter because this does not have a default value. Okay, if it had a default value, this also would have been an optional parameter, but this does not have a default value, so it's a mandatory parameter. That means the user has to provide a value for the address. And then here what I do is I say as begin. Here if you see, I'm selecting employee ID. Instead of selecting first and last name, I'm selecting the full name. by using the function. This is one other difference between the procedure and the function. In a procedure, you can call a function, but inside a function, you cannot call a stored procedure. Okay, and then obviously I select the address from employee. Let me just give it an alias name because it does not have an alias name. From employee table where employee ID is equal to ID and address equal to address. Okay, so I'm using both the parameters to filter my data now. If I execute, it says commands completed successfully. Now I can execute only this and you not see any data because, let me show you, because when I don't pass any value to the employee ID, it uses the default value, which is 4, and for 4 the address is Australia. So if I pass Australia here, then it will return me the data because I'm not passing any value to the employee ID, so it uses the default value, which is 4. And there is an AND condition here. That means it'll only return me the employee which has ID is 4 and address as Australia. Okay, and if I say, if I pass this as India and I pass employee ID as 1, this will give me only that particular record. So this is how you can control your optional parameters and mandatory parameters. So we can also create a procedure with output parameters. Till now what we have seen is we pass input parameters. That means we pass inputs, we pass parameter values as input to the procedure, and then we can also create stored procedures with output parameters. I'm not a big fan of using the output parameters because this is mostly what a function is supposed to do. Okay, but yes, I just wanted to share with you that this feature is also available. Okay, so here I say create or alter procedure, the same procedure name, and I pass two parameters as input. One is the employee count, which is of type integer, and the output keyword. So that means this is a output parameter. And then I have the employee address, which is varchar 100. So basically what I'm going to do as part of this procedure is I'm going to count the employees that reside in the input address and return this count as an output. So this will basically be returned to the users, okay, the end users. And what I do is I say as begin, and here I say select employee count is the output, okay, the output variable equal to count1 from employee where address equal to employee address. So the count for all the employees residing in this address will be stored in the employee count variable. Okay, and let me create this. Now executing this is slightly different. What we do here is we need to catch the output value, right? First let's create a variable of the same data type, which is integer. Now this is where I'm going to store my output value, the value that I get as an output. So here I say execute the procedure name, and then I put the variable name here, the new variable that I've created, saying output. That means whatever value this output parameter returns from here will be stored in this variable. So the output keyword helps us map this variable to this. So that means whatever value comes as an output will be stored in this variable, and obviously the employee address I'm passing the parameter here. So I'm executing it, right? So I'm saying okay, store the output in this and take this as input, and ultimately what I do here is I select the value as an alias name. So let me run this and show you what the output looks like. So it gives me 2. That means there are 2 number of employees who reside in the US. Similarly, if I change it to, let's say, India, and let's see this now, it gives me 4. That means there are 4 employees from India. So this is how you can use input parameters as you can use output parameters with procedures. But again, as I said, this can be easily used with a function. Okay, so you don't need procedures for that. To be honest, I have never used a parameter, output parameter with a procedure. But yes, we use input parameters a lot. I've spoken to you about the SP help text when we were discussing about functions, right? The same thing is applicable here as well. So if you want to see the content of a procedure, you can always use SP help text, and then you can write the procedure name, and it would give you the whole structure of the procedure, the whole definition of the procedure. And obviously, if you want to hide it, if you don't want people to see it, what you can do is you can say with encryption. And when I execute this, it's altered. And now when I run the sp help text, it would not return me anything. It says the text is encrypted, right? Obviously, you can call your procedures conditionally. That means if the condition is true, then you can execute a procedure. See, 1 is not equal to 2, right? So it won't return us anything, right? It just says commands completed successfully because there's nothing to execute because the condition is false. But let's say I make it 1, which means it's true. Now the procedure will get executed and it returns me the output. Okay, so this is how you can execute your procedures conditionally, right? Views. Okay, all right. So what are views, and how are these important in the context of SQL Server? So let's say with the growing amount of data, okay, when the data grows exponentially in our database, obviously we store a lot of, in fact, all of the relevant data, which can be game changers at time. The importance of data can be realized when you hear the terms like when they say the data is the new oil. That means data is so important in the context of the business, the domain, and the application. There's nothing matching that level. I mean, if your UI goes for a toss, you can always fix it, but your data is something that is always dear and close to any company. Now when you have data which is like quite important, you can do a lot of things with it. You can do some analysis, you can do some probably you can use it to predict something. You can do, I don't know, maybe derive metrics out of it, like how did the past go, and how is the current year going. So you can do derive comparisons out of it. You can derive what do you call standard numbers or standard metrics for your company. I mean, there are a lot of things that you can do on data, and I guess with what we are doing these days, I mean, a lot of them revolve around data. I mean, you talk about machine learning, artificial intelligence, a lot of things can be done with data. So coming back, I mean, when I talk about data, there are a lot of important data that we store that might also be relevant for a few other applications or a few other projects in our organization. Okay, but end of the day, they might be internal consumers, they might be external consumers. Okay, so you can also I mean, if companies are tied up, they could also share data between themselves, right? If they are a parent or a child company or a sister company or any related companies which have an agreement. Okay, I mean, there cannot be direct sharing of the data without any agreement or such. That would be clearly a theft. But again, if there is an agreement, is a pre-decided agreement, then yes, data can be shared between companies, organizations, between projects, and between teams as well. Now, whenever you get such requests, okay, I always say this to people that I train. Whenever you are given a database, make sure you need to work as if you own it, because any change that you make on it, any additional objects that you create in it, you are responsible to manage it. So the more objects you have, the more effort it is going to take from your end to maintain and manage it. So that's the reason I say, whenever you are given a database or whenever you own a database, make sure you act like a miser. Okay, that is, I mean, whatever I am outside of office, but inside, when I am on my database, I need to, talking about myself, I'm a big time miser.
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Anyone comes back to me saying, hey Dinesh, we wanted to create a table, we wanted to add 2 columns, we wanted to modify this on the database, we wanted to modify that on the database, ask them questions until that is the only option left. Okay, ask them if there is an alternate, ask them what if we don't do it, what happens if we don't do it. If you do not have any other option than doing that, find out an efficient way to do it, because if you just keep making changes as per the suggestion that you get from your team members, you will end up with a very bad database. It could be on the design, it could be on the storage, it could be on the maintainability aspect. Okay, so always make sure that whenever you do something, okay, make sure that you know what you're doing. Okay, take your own time, analyze it, and then implement it. But before implementing, see if there is any other better way that you can do it. Only if it is the last option, update your database. It could be your table, it could be your column, it could be adding new tables or anything of that sort. Okay, I mean, this is a fact. Okay, trust me. I mean, if you go that line, if you walk that lane, you will understand how hard it is. If you have like 10 developers working on the UI, and let's say you are the one taking care of the database, imagine 10 people telling you how to design a database, or 10 people asking you to modify the database. It's going to be really bad. Okay, so that is one aspect to it. The same thing applies when someone asks you access to the data. Okay, you will, when you have, and this happens mostly when you are in high visible project, okay, or project which has the core data of the organization. When you have the core data of the organization, okay, you are very frequently contacted by teams and projects. It could be inside your company, outside of company, that comes back saying they might need access to your data. Could be because of any reason, could be to run some analysis, could be to take something and use it in their system, could be to integrate into could be they could be building an integration tool between the two applications. You never know. So there could be multiple reasons why they might be asking you for the access to your data. Now again, the being a miser still continues. Okay, when they ask you for access to the data, make sure you get all the details or understand why they would need access to your database. Why would they need access to your data? Is it clearly justified? Now again, only grant them access when you are completely satisfied with their response, or if you have your management's approval. Okay, I would say both of them are necessary. That is what I do, because tomorrow you never know. I mean, you could feel that the answer that they've given is justified, but the management might not agree to it. Okay, so it's always better to make sure that you understand their point of view as to why they need the data, and also at the same time have proper approvals before you actually expose your data to the outside users. Okay, now they need data. I mean, okay, everything is decided, they need data from your database, but then you know that there are some very critical information, let's say user information, that at no cost you can share with them. It can be phone numbers, it could be social security numbers, it could be Aadhaar numbers in case of Indian users, it could be salaries of the employees. Okay, there are a lot many things that are quite sensitive and quite critical that can that you might not want them to have access to. Okay, you need to grant them access, they need to view the data. At the same time, you want to have control on your data so that you can hide or show whatever columns you want to expose. Okay, this is where views comes into picture. Okay, views we looked at, in fact they are an additional layer on top of a table which helps us protect sensitive information based on our need. Now they need data, I mean, we completely understand it, but sensitive information is something that is very, as they say, I mean, sensitive, right? So you cannot just go ahead and share them. You need permissions from the users, you need a lot of things before you could actually share those details. Okay, and to do that, to accomplish both these things, there's a concept that we use the views. Okay, view is nothing but an additional layer on top of a table which enables us to protect sensitive information based on our need and only expose the columns that we want to expose for the outside users. Now a view is just a query on the top of a table. So like as we write a select, right? So we can name that query, as simple as that. A view is basically we write a select statement and name it. So whenever you call that view, the query that is written inside, the select statement that is written inside is executed and it gives you the data back. Okay, and the view, as I said, is just a query on top of the table. That is all that it has. It does not store any data of its own. Okay, and that is the reason they are very, very lightweight on the server. It is just a physical object created on the database, but internally it just has a query plugged on top of one table or multiple tables. As this is just a layer on top of a table, views do not store any data physically in the server. That means it does not have to store. It, in fact, is very lightweight on the server and does not store the data. Again, the one good thing that I like very much about the views is this. Okay, it is so lightweight on the server that it doesn't take any physical memory on the disk. Okay, and it makes absolute sense as well, because as I said, views are connected to tables and the data is already there in the tables. We don't have to maintain the same data in the table as well as in the view. The query is always there inside the view. Every time you call the view, the query is executed and it gets the data directly from the table itself. So it's a win-win situation. I mean, you don't have to store duplicate data, plus you get whatever data you want to get. But again, you can control what data goes from the table to the view. Okay. Instead, so the data is not stored in the view. Instead, the data when requested. So let's say I want to view the data from the view. I want to see the data that is inside the view or consume the data that is inside the view. I just when I execute it, the data when requested, that means when someone requests from the data from inside the view, the query that is running and that is defined in the background is executed and the data is returned. Okay, so let's say someone executes the view 5 times, the query that is written inside will be executed all the 5 times. Okay, there is no concept of caching or anything like it happens in procedures. Okay, this is a completely different object altogether, which is just a replacement or an alternate to a table. Okay, so moving on, let's see how to create a view. Okay, so I've already explained you what views are basically. Okay, let's see how to create a view. Let's start by talking about how we create a view. And to begin with, I'm going to create a very simple view which replicates exactly the table. Okay, like how the like all the data that the table has is just going to be exactly the same. Okay, so here I say create or alter view. Okay, this is a syntax that we usually use for procedures, functions, indexes, and everything. And then here I say vw underscore. Vw is the prefix that I give to all of my views. Okay, so that I see it and know that okay, it's a view. Vw underscore get employee data. Okay, so I just name my view as get employee data, and then I say as, and as you can see here, I have just put a select star from employee. So no manipulations, no filtering, no column exclusion. Okay, just a very simple select, and I'm selecting all rows and all columns from the employee table. Okay, so if I execute this now, oh sorry, I'm in the master database. Just connect to 20th September and let's execute this. And now this view is created. So where are the views created? Let me show you. You expand the databases, go to the database that you use, and then if you see here, there is a option called views. When there's a subfolder called views, expanding that, you will find the view that has been created. Now, how do we consume a view? Like how do we extract the data from a view? It's exactly how tables work, because as I told you earlier, it is just a replacement of the table and also helps you in filtering what data do you want to push to the view. But in this case, no filtering, no exclusion of the columns, no exclusion of the rows. It is a very simple select from the employee table. So the view basically should show all the data that the employee table has. Now, so for me to fetch the data from a view, I just use it like I consume data from tables. I say select star from and then the name of the view here. So when I run this, you will see that it gives me all the columns and rows from the employee table. Okay, now as I told you earlier, the view does not store any data. So all the data that you're seeing here right now is a result of the query that was executed that is inside the view. So when I say select star from view name, it executes the query that is there inside, which is the select star from employee. And obviously the select star from employee gives us all these rows and columns back. Okay, so if I execute this, let's say 4 or 5 times, 1, 2, 3, 4, 5, 6, all the 6 times, this query is only executed because the view does not have any data of its own. Now the advantage of this concept is that every time you execute this view, you will always get the latest data in the employee table. So if someone executes this now, it'll that particular user would get all the employee data till this current time. And that's a good thing, right? I mean, with the view, you're always getting the latest data that is there in the table. There is no lag at all. Okay. Now, looking at this, what you see is, I mean, the only thing that I'm concerned about, hey, I don't want to expose my salary column. Okay. So let's say I don't want them to see my table. So what I do now is I give them this view. Okay. The outside users, I give them this view. I'm going to talk about a little bit more. I mean, when I give examples, you will understand how these views are helpful. Okay, so here, let's say I show you this column, and I see that okay, the salary column is not something that I want to share with people from outside of my team or outside of my project or outside of my company. Now, how do we restrict those data, or how do I create a view to exclude a few columns? So in order to do that, okay, what I did is, you see here it had a star, but in this condition, I mean in the same view, I'm going to alter it, the same view name. Here, instead of specifying star, I specify all the columns that I need or that I want to expose to the outside users. So I'm fine exposing the employee ID, first name, last name, and address, but not the salary column. So I can say select employee ID, first name, last name, address from salary. And let me just not filter it yet. And let's say run it. So it says commands completed successfully. And now when I try to view the data from the see the data from the view, you will notice that it still gives me all the records. But now it only gives me the employee ID, first name, last name, and address. It doesn't give the salary column anymore. So anyone who is executing this view, whom I have shared this view, will only be able to see these 4 columns of the employees and not the salary column. Okay. Now, let's say you want to show, or someone has a request saying, hey, can you give me the records of the employees only from India? Okay, so in that case, what you do is you can say where address. So you can create a view as address equals to, sorry, in single quotes, address equals to India. Okay, and let me alter this view, and let's say let me run the select again. And now whoever is using this view, whoever is consuming the data from this view, will only see the employees, or it will see the list of employees who are from India only. Okay, so this is how you can filter rows and columns so that you only expose the required amount of data. Now, if you think about it now, I mean, this is the most feasible solution, isn't it? Let's say you have a sales table. Okay, you have a sales table, and there are 5 or 6 users in different regions requesting for data. Okay, so how do you accomplish it? I mean, you cannot give them the same table name, because everyone should be will be able to see. If you give them access to the table, everyone will be able to see all the data from all the regions, and that is something that we would not want to happen. So in that case, you can create 4 views for 4 different stakeholders and use a filter for that specific region. So let's say you're creating one for Europe. Maybe you can say where location is Europe, or any other column that you can check to filter out only the European data. Similarly, if you are requested for the UK data, you can create a view which will only expose the UK data. So there are multiple advantages associated with the view. The one more advantage that I love about views is that in views you can also join two or more tables. Let's say someone requests saying, hey, can you share me the employee data and the employee date of birth data as well? So instead of sharing both the tables, what you can do is you can create a view. Okay, I'm using the same view itself, wherein you can join the employee and the employee date of birth together, obviously on the employee ID like I showed you earlier. And here I can select the employee ID, first name, last name, address, and date of birth as well. So instead of sharing two tables with them, or in fact all the data from employee and all the data from employee date of birth with them, I can easily expose only the columns that I wish for them to see. Plus I can also filter this query. Let's say I only want to show India's data. I can always put a where clause after this saying where address equals to India, and it should work absolutely fine. They will just have to call this view to see the employee data and the date of birth corresponding to each of the employees. So let me just run this, and if I try to run a select from the view, you will notice that it shows the employee ID. I mean, the users can see employee ID, first name, last name, address, and date of birth as well. Although these two are not, I mean, this column and these columns are not in the same table, but inside the view, I have managed to join it. So this is like another layer that we apply on top of the existing tables to I don't know, facilitate sharing of data from tables.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following SQL clause is used to delete tuples from a database table? A. Delete. B. Remove. C. Drop. D. Clear. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So let's move ahead then. Now, by now you must have realized that views are very tightly coupled with the column names and the table names. Okay, now let's suppose that I change one of these column names. Let's say I change it to employee ID of employee. Let's say in the employee table, I change this column name to ID of employee. Now, do you think this view would still work? As I told you, the view, every time we call it, it just executes this query to get the data. Now, let's say you modify the column name to ID of employee, right? Do you think this view would still work? It wouldn't, because it's going to throw an error saying that the employee ID column doesn't exist. And why it doesn't exist? Because it has been renamed. It has been renamed to ID of employee. So this situation wherein the underlying columns or tables of a view has been modified, okay, and I'm only talking about renaming. Okay, so renaming of any of these columns or renaming of any of these tables is going to cause the view to become orphan. Okay, those will be called as orphan views because the parent table or the columns are no more to be found. So views for which the base table or column has changed or has been altered is known as a orphan view. Now, can we do something in order for us to preserve a view, in order to ensure that the view works at all times? Yes, to prevent such scenarios, we can choose to schema bind our view. Okay, now what happens when we schema bind our view? When we schema bind, SQL ensures that none of these columns, okay, only the dependent columns, that is employee ID, first name, last name, okay, address, employee date of birth are not modified. SQL ensures that. Also, the employee and the employee date of birth table are neither allowed to be dropped nor renamed. Okay, so that will ensure that the view will work at all time. Okay, so schema binding binds our views to the dependent physical columns in the table, columns and table as well. columns, column and table, columns, sorry, columns and tables. Okay. Now, for example, here, if you see the salary column isn't used, correct? So the columns that aren't used in the view, they can be altered, they can be modified. Okay. So schema binding is only applicable to the columns which are binded in the view. For the columns which are not binded in the view, although they are in the same base table, you can still alter them, you can still remove them, you can rename them, whatever you want to do, you can do with them. But only the columns that are intact or that are referenced inside the view, that are there inside the query, those cannot be touched. Okay, so let me show you with an example how it actually works. Okay, so I'm going to create a view, create or alter view. Okay, I'm going to use the employee backup table. You remember this employee backup table that we created some time back? Let me just show you what it has. It has all the data from the employee table. Okay, now what I'm going to do is I'm going to create my view on top of this now, because I'm using the backup table for my demonstration now, because I'm going to do a lot of changes on this table, like removing columns, altering columns and stuff like those, which I don't want to do with the employee table. Okay, so I'm just demonstrating it with the backup table. So let me create a very simple function view which says create or alter view, and here I name the view as vw underscore get employee backup data. And let's say I don't enable the schema binding. Okay, I just say as, and then select all the columns from the employee backup table. Okay, let's just go ahead and create this without the schema binding, mind it. Okay, it's a very normal view like we have been creating till now. Forget about the schema binding for now. So right, this view is created. Now if I want to select from this view, let me run a select from this view, and you see that it works perfectly all right. Now let me try to drop the first name column. The first name column is used right in the view. Let me say alter table employee backup, drop the column employee first name. Now remember one thing, the first name column has been inside the view. Let's see what happens when I run this. So I say alter table this, drop the column first name. It works, and it allows us to drop the column although that column is referenced in the view, which is this one. So now this view has become orphan. Let me show you what happens. If I try to execute this view now, see, it throws me an error saying invalid column name employee first name, because that column has been removed by us just now, a little while earlier. Okay, and this is an ideal example of an orphan view. Orphan view is a view for which the base table or base column is missing. Okay, now let's try to do the same thing. Okay, let me try to drop the employee backup table. Okay, I'm trying to drop the employee backup. Now this is the parent table, mind it, of the view. Okay, and if you see now, let me execute this. It works. It allows us to drop the table as well. And if I run this again, obviously the backup table is not there, so it says invalid object name dbo underscore dbo.employee backup. So the view was orphan earlier, now also it is orphan, but the base table is also missing. Now how does schema binding help in this case? So let me recreate the backup table again. Control KU, recreate the backup table because I just dropped it right. Now if I execute the view, it should work because the backup table is back again with all the columns. So the view works fine now. Now let me alter the view to include the schema binding. Okay, so you use the schema binding option here. Okay, right after you define the name, you say with schema binding and execute. It says commands completed successfully. So now our view has the schema binding option turned on. And now let's try to drop the column employee first name. Let's try to repeat whatever we did earlier. So let me try to alter the table to drop the first name column. Wonderful. See, what does it say? It says the object is dependent on the column employee first name. So the drop column does not work. This is SQL checking for us. Okay, only because we have enabled the with schema binding option, SQL is checking if this column is used in any of the views, and it finds that okay, it is used in the view underscore get employee backup data. Now, perfect. It doesn't allow us to drop the column. Does it allow us to make some other modification? Let's say you want to change the size, maybe. Okay, so let's say from 100, I want to make it 120 on the first name column itself. This also is not allowed. The object is dependent on column employee first name, so you're not allowed to make any alteration on this column. Now I'm only talking about the design changes, guys. Okay, the data is allowed. I mean, it absolutely makes no sense for SQL to stop or prevent the data from getting updated, inserted, or deleted. I'm only talking about the alteration on the column itself, which is not allowed. So it doesn't allow us to drop it. It neither allows us to modify it or alter it to add or increase or reduce the column length also. Okay, now let's try dropping the salary column. Okay, you know we had a salary column in the backup table. Let's try to drop the salary column and see what happens. It works. It allows us to drop the salary column because the salary column is not being referenced in the view itself. So it is free to be dropped off, and it allowed it to be dropped. So the with schema binding is only applicable for the columns that has been specified in the select, and also on the base tables, obviously. Okay, and now if I also try to drop the main table, the base table, it doesn't work. It says it is being referenced by the object view get employee backup data. As simple as that, right? Now, if you want to view the definition, if you want to see the definition of a view, you can use the SP help text. This is something that I've explained to you while working with functions and stored procedures. So I'm not going to spend much time on this here. If you run this, obviously you will get, get employee backup data. Copy this one and paste it here. And this one, if I want to see the content, I can easily use the SP help text in front of the name of the view to see the definition of the view. That means what query has been specified inside the view. But as I said, this is for outside users, so it's always good that you encrypt it. But again, we don't usually encrypt it because the SP help text can be run by people who have higher privilege than a read permission. Okay, and for people who are going to use the views, we usually give them read permissions only. And for SP help text, you need a higher privilege than the read permission. So there's no harm or there's no fear of the query getting exposed as well. So here, if you want to, if you don't want your views to be scripted out, obviously you can use the with encryption option. And if let's say I create a function with a view with the with encryption, and let me just copy this and paste it here, and you will notice that it says the object is encrypted. Okay, so it doesn't allow this to get inserted. I mean, it doesn't allow us to see the content of the view. Okay, all right, so let's continue. Now you already are aware of the null and the not null concept, don't you? So let's say I have an employee table and I have three columns in it, A, B, and C. Let's say the column A is nullable, B is nullable, C is not nullable. Okay, this is nullable, this is nullable, this is not nullable. That means A can hold nulls, B can hold nulls, C cannot hold null values. Now let's say I say insert into employee A and B and then select the values here. Do you think this is going to work? This won't work. The reason is, if you remember, I explained you how the nullable columns are optional during insert. That means if you don't provide a value for them explicitly, it will store null in them. Okay, it will store nulls in them. Whereas if you don't provide a value for the not nullable columns, SQL Server wouldn't know as to what value should be inserted into that column, right? So that's the reason you need to specify, or that's the reason the columns which are not nullable are mandatory. So at any point in time during the insert into the employee table, you need to provide for sure the column C. Without C, you cannot insert a row in the table. If I exclude A and B, that's perfectly okay. SQL can store nulls in them because these are nullable columns. But for C, I cannot exclude it during the insert, right? Now I'll tell you why I was trying to explain this to you. Okay, talking about the DML operations on a view. Just increase the font. I think it's a bit too small for your liking. Yeah. Okay. So let's talk about the DML operations on a view. Do you think we can perform DML operations, that is insert, update and delete using a view? Yes, we can. Okay. Views are not only meant to read data, okay, but we can also perform DML operations on them. That means we can also write into them. Okay. Now here, as you already know, views do not have any physical data stored explicitly. So any DML operation that we perform on it is directly executed on the base table. So any insert, update or delete that we do on the view, it directly impacts the base table. Okay. So here we can perform insert, update, delete on the table using the views, but there are two main assumptions that we need to go with. Okay, we can perform DML operations only if these two conditions are satisfied. First is the view should always have a single select. That means it should have only one table from where it is selecting the data from. It cannot have multiple tables joined together. In such cases, we cannot perform DML operations. Next up, all the not null columns are to be selected in the view. The reason is what I just explained you earlier. If the column C, let's say I create a view on the employee table, I don't select the column C in the view, there is no way I can insert a value into the column C. So all the not null columns should be selected in the view. If you don't, then it will not work. The DML operations won't work, especially the insert. Okay, so these two are the criteria for which only then we will be able to insert, update or delete on the table using the views. Now if you remember, we had a view called view get employee backup data. Sorry, you remember this view? I just created it above. And then the base table for this is this one, the the employee backup table. Okay, and if you see, both of them are exactly the same. The only difference is that I have not selected the last name column in the view. As you can see, in the view I only have ID, first name and address. The last name column is in the table, but I haven't selected it in the view. Very it's fairly understood. Now let me try to insert something into the view. So the two conditions that I was talking about, first one, the view should only have a single table. That is true because my view, the get employee backup data, if I show it to you, let me just show it to you so that you remember. This is the view. Okay, and it has only one table. It has only one base table, right? So the first condition is true, and the next condition, talking about the next condition, there are no not nullable columns here. All of these columns, if you see, are nullable columns. So there is no problem with the second one as well. Okay, the second criteria said only all the not null columns are to be selected in the view. Okay, I mean you can have the rest of them, but all the not null columns should be mandatorily there in the view. But here, as the base table has no not null columns, so we are good on that aspect as well. Okay, so that angle is covered too. Now let's try to perform a insert on the view. Okay, so carefully observe, okay, what I'm trying to do here. I'm trying to insert into the view. If you can notice, I'm trying to insert into the view get employee backup data, and I can only insert into ID, first name and address. I cannot insert into the last name column because the last name column, although is there in the base table, but it is not there in the view. Okay, and that is the reason why we said that all the not null columns should be selected in the view, because if it is not, then you cannot insert into that column. And obviously, if you cannot insert it from here, SQL will try to insert null into that column and it would fail. So here I say insert into the view and I specify all my columns. I select or I specify three values, 9, Tom and US. So 9 is the ID, name is Tom and address is US. And let's execute this. So it says one row affected. And if I show you the view, obviously the view gets the data from the table, right? So let's check the table first. Okay, so if you see here, this record has been newly inserted. I mean, only because of our insert that we did. So I did the insert on the view, but I selected the data from the backup table. That means the base table of the view. And as you can see, the record is already here. Okay, and here, if you see, the last name is stored as null because the last name is not a column in the view. So I can no ways insert value into this column using the view because this column does not exist on the view at all, right? So the inserted directly into the table. And also, as you know, the view gets the data from the table, right? So you will see the data also shown up in the view. Now let me update the view. So I say update the view, set address equals to India where the employee ID is 9. So for the new record that I just inserted, I want to update the address to India. And again, as you can see, I'm updating the view, okay, not the table, the base table. Okay, I'm not updating the base table, but this update will subsequently update the table itself. See, it shows one row affected. And let me show you the base table. See, for this one, the address has been updated to India. Earlier it was US when I inserted it, but now it has been updated to India. Right? So any insert or update that we do, it directly impacts the base table. And obviously now when I run the view, as the view fetches the data from the um, table itself, so you will find the address of this record as India. Now let's see the delete as well, the last of the DML statements. And let's say I delete this and I delete from the view again where employee ID is equal to 9. So the new employee that I created, I'm trying to delete it. So let's delete. It shows one row affected. And now if I select from the backup table, you will notice that there is no record for ID 9 because I just deleted it. But I deleted it for your information from the view, but it automatically deleted it from the table because, as I said, the view does not have any data of its own. All that it has is the data from the base table. And if I run this view also, you will not find the ID 9 anymore. Now you might ask, the views are meant to be shared with outside users. Can they update the data on our tables? No, because whenever you create a view, we mostly grant read access to the outside users. Okay, so they cannot make any modifications through the view because if they have read permission on the view, they can never be they will never be allowed to run insert, update, or delete on the view. So they can only run selects on this view. That is all about views. Okay, all right. So let's talk about transactions now. So what is the first thing that comes to your mind when we talk about a transaction? The first thing that at least comes to my mind is a bank transaction. Okay, that's a very common term in the banking domain and in the masses as well, right? So an ideal transaction would look like, let's take an example of transferring an amount worth $100, okay, between two parties. So obviously the first step that is involved is the initiation, wherein the request is placed. It could be a check deposit, it could be an online transfer request or anything. And then what happens is $100 is deducted from the payer's account, okay, and it is end of the day or end of the transaction is when the $100 is credited to the receiver's account. Only when all these steps are completed, that is when it is said that the transaction is complete, okay, and in fact completed successfully. Okay, now let's suppose that the initiation went well. I mean, the request was well placed, $100 was deducted from the payer's account, but then the $100 never got credited to the receiver's account. Okay, so let's say it was not credited due to an internet issue or a link failure or anything. As a matter of fact, I mean, there was some downtime on the bank data, on bank application, bank website, or anything, as a matter of fact. Now, what happens in that case? So the $100 is already deducted from the payer's account, and it did not get credit. It did not get credited to the receiver's account. So what happens in this case is the bank would revert back the $100 that was deducted from the payer's account. All right. Now the transaction began, but it failed at a certain point. So it was reverted back to the previous state it was in. Now, one very important property of a transaction is that the transaction should leave the database or the application in a consistent state as it was before the transaction started. Okay, so now if it would have left the $100 deducted from the payer's account, but it would have it never got credited to the receiver's account, and the bank never bothered to return back the $100 to the payer's account, obviously there is inconsistencies in the data. There is $100 worth of amount that is nowhere to be found. It got deducted from the payer's account but never got credited to the receiver's account, and it never got reverted back into the payer's account at all. So clearly the transaction that happened or that got initiated left the database in an inconsistent state, and which is never the case, right? Ideally. So a transaction is either all or none. Okay, so in a transaction, either everything goes through fine, or if there is a problem with any of the steps, the rest of the steps are reverted back. And this is exactly what transactions mean in SQL Server as well. Transaction are a set of operations when performed in a sequence such that all operations are guaranteed to succeed or fail as a single unit. So either everything goes well without any issues, or if one of them fails, everything else, all the other changes that has been done are reverted back or are rolled back. Okay, so that's the reason it is said that the transactions is either all or none. That means either it works for all the steps or everything goes well, else nothing is executed. Okay, now you might be curious as to, okay, where do we exactly use these transactions? So a transaction, so in here, now when I talk about SQL, in here in a bank transaction, we have different banking activities, right? But in a SQL transaction, we have multiple SQL queries that needs to be executed. Okay, so a transaction might have 50 queries, might have 100 queries, might have 3 queries, but end of the day, they are all told to be in a single transaction. So either all the 50 queries go through fine, or let's say if the 49 queries work fine, but the last one fails, every other change that was made before the 50th query needs to be rolled back, because as I said, a transaction will never leave a database in an inconsistent state. Now you might be curious as to when exactly do we use a transaction. These are a few examples that I'm sharing from my own experience. So when multiple number of rows are inserted, updated, or deleted in a sequence. Okay, so let's say that there are a set of 5 employees that are joining the organization today. So in the first place, what you would need to do is add those employees to each of the departments, like the transportation, the food department, the IT department, the admin department. So all the employees should be added to each of the departments. Now, only when they are successfully added or onboarded to all the departments in the database, then we can see that, okay, the employee is onboarded now. So let's say he gets an identification number from each of the departments. I think that is where we say, okay, the employee is onboarded now. Now let's say the employees were added to 3 departments, and the 4th department, while adding them to the 4th department, there was some technical issues, okay, or SQL issues. Now in that case, we cannot leave the onboarding midway, right? We cannot say, okay, let's start all over again. That might not be a feasible option. or let's leave it as it is cannot also be a feasible option, because you don't want the employees to be onboarded to only 3 departments and the rest of the departments are not onboarded. I mean, the employee is not onboarded to the rest of the department. This makes no sense at all. There is no partial thing in a transaction. Okay, this is where a transaction is used. So when we want to insert something which is pretty much related into a set of relational tables, that is when we use a transaction.
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
So either that related data gets inserted into all the tables or nothing at all. Everything else is rolled back if there is any issues. If there are any issues, the changes that has been done are rolled back. The other instance where we use transaction is when the changes to one table require the other table data to be kept consistent. Okay, now let's say for some reason, okay, for some given reason, your employee ID needs to be changed. Okay, let's say I mean, due to some reason the company decides, no, this employee's ID needs to be changed. So in that case, your employee ID column is a very critical column, right? It could be used as a foreign key in multiple different tables. So in that case, what you do is you need to modify all of the tables in a sequence so that you can remove off the old employee ID and update with the new one. Okay, and how, when can you do it? When all the child tables are updated with the new ID. Because if you don't do that, then there are high chances that some related data might get missed. Let's say for my employee, let's say my employee ID is 10 and the new employee ID that is given to me is 15, and there is a date of birth table where for ID 10 it has my date of birth now, and tomorrow my ID is changed to 15 but that table is still pointing to ID 10. First of all, that record is orphaned. Okay, if it is a foreign key reference, I mean, SQL wouldn't allow you to do that, but I'm just saying. Okay, let's say there is no foreign key, so that record is left orphan. Plus Dinesh now doesn't have a date of birth because Dinesh's ID is 15 and that employee date of birth record has ID as 10, so there is no relationship left now between the tables. So in such cases where you are needed to change the data in a sequence of tables, okay, but this time,
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which SQL keyword is used to retrieve a maximum value? A. Most. B. Top. C. Max. D. Upper. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
the major changes on one, but you're changing only the related tables, that is when you also use a transaction. So either you update all the related tables with the new ID, or you just don't update anything. The next instance, the next example is when we are working on modifying data across 2 or more concurrent databases. So let's say there are 2 databases which are pretty similar to each other and we want to keep them in sync. So what we do, any change, any update, any delete, any insert that we perform on the first database, we also perform the exact same operation on the second database as well. Now imagine that one of the database got updated. I mean, I ran an update query. One of the database got updated, but the second one did not get updated, and the query failed due to some reason. Now the data is no more in sync between both the databases, right? So that's a big problem. So in such cases where we have concurrent databases which should be kept in sync, so for those kind of operations, we put them in a transaction. So either the update works in both the databases and it is perfectly all right in that case. But if say the update was done on the first database but is failed on the second, then we revert back the update that was done on the first as well. Okay. Now, talking about a very important aspect, which is about transactions, I've already given a hint about this to you earlier. So it is categorized by 4 properties. Each transaction in SQL Server is categorized by 4 properties, often referred to as the ACID property. Okay, ACID is an abbreviation of atomicity, consistency, isolation, and durability. So the transactions are identified by these 4 properties, each transaction in SQL Server. Now, what does atomicity mean? Atomicity property states that the transactions should be regarded as a single unit irrespective of the number of steps that are involved. So the transaction might have two queries, two SQL queries or 50 SQL queries. But end of the day, all of them should be considered as a single unit which would either succeed together or fail together. The next one is consistency. The example I've already given regarding the amount that was not credited into the receiver's account, but it was never reverted back to the payer's account. So in that case, the data was left in the bank database was left in an inconsistent state where there is no account for the $10, so the $100, right? So the consistency property in a transaction states that the transaction should always leave the database or the table in a consistent state after commit or rollback of the changes. So right after the transaction is committed or rolled back, then the database should be in a consistent state. There should not be any loss of data or there should not be any data discrepancy whatsoever. The next property is called as the isolation, which says that each transaction has its own boundary and do not interfere with each other with other transactions. Okay, like let's suppose that there are two transactions, bank transactions, that are supposed to add $100 and $100 to my account on the same day. So let's say the transaction one finished first and the $100 was credited to my account, and then the second transaction, which is also running parallelly, comes to my account and checks that okay, the $100 is already added, so it could be because of me, and it doesn't credit the other $100. So ideally, end of the day, I should have had $200 credited for the day, but I ended up having only $100 credited, which is a bad thing. And that is what the isolation property states, that each transaction has its own boundary and it should not interfere with other transactions. If it does that, it's going to be a big problem. Okay, durability, this states that any data modifications that are done after the transaction is finished should be kept permanently in the database or in the system. It should stay permanently on the system. That it should not vanish after a few minutes or a few hours or a few days. Okay, the data is there to stay and it should stay. Okay, so these are all called as the ACID property, which is ACID. So let's move on to the different types of transactions that we have. So the first one is called as the auto commit transaction, which is a pretty normal query window where I write my insert, update, and delete, and it automatically gets saved in the tables, right? I mean, I just write an insert or a select or insert or a update or a delete, and the moment I run it in front of you, it directly gets written to the table permanently, right? So these statements are written as part of this are automatically treated as a transaction and is committed or rolled back once the statement is executed. Okay, so it's a very normal form of query writing. Okay, next type is called as explicit transaction, where we specify the boundary of the transaction. Okay, saying these is where the transaction is going to start in the SQL query, and these are the queries that needs to be inside, and this is where the transaction should end. So I specify the begin of the transaction, I specify all the queries inside of it. So if I place, let's say 500 queries after the begin transaction, and then I say end the transaction, so all these 500 queries will be a part of this particular transaction, as simple as that. And this is known as an explicit transaction, where we define the boundary of the transaction. Okay, so we manually specify the begin and the end of the transaction. And the third type is called as the implicit transaction, which I have never used. Okay, but there's a setting where you can enable it for all the statements that you have in your query window. So this is a query window, right? So all the statements that are there in this query window are treated as a single transaction, and I don't see a reason why would someone use that. Okay, but yeah, I mean, it's just there. All right, so now let's talk about, let me show you how a transaction actually works. So here in an example of an explicit transaction, here I say begin transaction, and then I put all my queries below this. Okay, so what do I do here? I'm trying to update the employee table, where for employee ID 1, I'm trying to update the last name to Yadav. Okay, so if I run this select, you will notice that the last name is set to Kumar, right? Now, let's say I want to set it to Yadav, okay, and I want to do it inside a transaction. Now, this is only one SQL statement, but ideally we have more than one SQL statements, but let's try to just do this. Okay, let's say employee, I want to update the last name to Yadav, where employee ID equals to 1. And if I execute this, now I need to execute with the begin transaction so that SQL knows that this query is inside a transaction. Okay, so let me execute this. It shows one row affected, right? And if I run the select, now I haven't ended my transaction, mind it. Okay, I just begun the transaction and run my update. Now if I run my select from the employee table, you will notice that the first record has the last name as Yadav. Okay, so the earlier it was Kumar, but now it is Yadav. But we haven't finished the execution yet. How come is it visible? This is called as dirty read. Okay, dirty read is when, oops, sorry, why does OneDrive want to sync? Okay, anyways, so this is called as a dirty read, and dirty read is when we read data that is not yet committed to the database. This one is not yet committed, neither rollback, but we are still reading the new data. This is dirty data because this is still inside a transaction and SQL is allowing me to read it, right? So now, what exactly happens when a transaction begins? So when a transaction begins, right, all the changes that you make here stays on the log file. Okay, you remember when we created a database, I told you that there are two types of files that gets created. One is MDF, one is LDF. The data is stored in the MDF, master data file. But in the LDF, we only have the logs, okay, the transaction logs. So when I put the queries, all the queries that are there under the begin transaction, all these changes reside in the log file. Okay, only when I commit it, okay, then this data is permanently written to the MDF, the master data file. If I roll it back, it is wiped off from the log file as well. So there is no trace of it anymore because I mean we didn't do anything. We just began the transaction, made some modifications, rolled it back. So that's all right. I mean, it gets wiped off from the log file altogether. But let's say I put this in a transaction, all the changes are there in the log file right now. And if I say commit, it'll move those changes permanently to the MDF file and ultimately to the table. So that data is proper committed data. But when I try to read something which is in a transaction, it is called as dirty data. Now let's say I roll it back. So as I told, if I roll it back, it would get wiped off from the log file altogether. So let me run this. It says commands completed successfully. And now if I see the employee table, you will notice that the last name is set to Kumar back again because I choose to roll back my change. The query, the data that I updated or the operation that I performed as part of the update has been rolled back now. Okay, if I would have said committed, then I would have seen Yadav here. Okay, but that time Yadav must not have been a dirty data. Right, now is there a way in which I can choose or set saying that I don't want to read dirty data? Yes, those can be controlled by using isolation levels in the transaction. Okay, or as we call it as the transaction isolation levels. Okay, and this we can use to control if we want to see dirty data from the tables or not when we are running the selects. Okay, so what are the different transaction isolation levels? Now there are multiple types, but I'm going to talk about the two important ones and I'll leave it up to you to explore the rest once you feel confident on these. Okay, don't just go in and read about the rest of them because those are a little too complicated. I'm just going to talk to you about the two very basic regularly used isolation levels, and the rest of them you can explore once you have a good hands-on experience on these. The first one is called as the read committed isolation level. Now the read committed isolation level will only read committed data in the table. That means all the data that is committed in the table will be read as part of the read committed. Now, how does it ensure that it reads only committed data? So in order for SQL to obey the read committed isolation level, if there is a transaction running on the table, the query will wait till the transaction is complete. So automatically, if there are no dangling transactions, if there are no transactions active on that table, obviously it will not, I mean, we can be sure enough that all the data that is there on the table are proper data, are actual data. There is no dirty data in it because there are no transactions. So obviously all the data that we have are permanently written data on the table. There are very less chances that they might be rolled back because there are no transactions to be rolled back. That is how it ensures and works at the read committed isolation level. Okay. Now coming to the read uncommitted isolation level, in this case, in this level, the uncommitted data from the table is also read. So it brings dirty data as well. Now we did not specify, right? We did not specify the read uncommitted isolation level, but the select still gave us the read uncommitted data, that is the dirty data. So this is because the default isolation level in SQL Server is read uncommitted if you are running the select on the same query window where the transaction has been run. So let's say, so I ran the transaction on this query window and I ran the select also on this same query window, right? So in that case, the transaction isolation level at default one is read uncommitted. But how can I specify it explicitly? Let me show you with an example. Okay, so here let's see what does the employee table have for employee ID 4. So for employee ID 4, the first name is Steve. Let me try to update it to David, but this I want to put it in the transaction. Now for your information, I'm going to paste the original name here, which is Steve. Okay, this is the original name. I'm going to say original. Okay, so this is Steve is the original name. I'm trying to update it to David. Okay, now let's run this inside a transaction minded. It says one row is affected, and if I say select star from employee, look what it gives me. For 4 it gives me David. David is the one that I just updated, but this table already has a transaction, right? I just begun the transaction and run the update. I've neither committed it nor rolled it back. That means there is a dangling transaction, that is an active transaction on this table right now, but I'm reading dirty data. That's the reason I said when it is in the same query window, then the default transaction isolation level is read uncommitted. Now let's see how to explicitly specify the isolation levels. So let me copy these two queries. The transaction is still active minded. Okay, I've not committed or rolled it back yet. So let me put a vertical diagonal and paste it. So this is how I specify it. I say set transaction isolation level read uncommitted and then select query. So this one will read dirty data, right? Because this is uncommitted isolation level. So it'll read the data, ignoring the fact that there is a transaction running on the table. Let me run this and show it to you. See, it reads the data and it reads David. And David is the one that David is the one that I updated just now. Make sense? So it updated it to David, although, I mean, it reads me as David, although this is not permanently written to the table yet. So this is how the uncommitted works. But let me show you the read committed one. Okay, and I just run this. See, it keeps executing it. It does not return the result, which proves the point that I told earlier. I said that it will wait. The only way it can ensure that it is reading committed to ensure that there are no dangling transaction or active transaction on the table. Now, when I ran this query, it found out that there is an active transaction on the table. So it is waiting for that transaction to be ended so that it can read the data. Now, let's say I roll it back. So ideally, what should it read? It should read Steve, right? Because this was the original value. I updated it to David inside the transaction, but then I'm rolling it back. So it should ideally read Steve. So let me try to roll it back, but let me do it with a countdown so that you see the moment this transaction is rolled back, you will see the data right at that moment itself on this part of the query window. So keep an eye on this part of the query window, okay, on the right hand side of your query window, and I'm going to roll back this transaction. So in 3, 2, 1, and here we go. See, the moment this was successful, this returned me the data, and now it returns me Steve, which is the original name prior to the transaction. So this is how SQL reads the committed data. But this has a lag because every time there is a transaction, it will keep executing the query. Okay, which might not be a good thing. But again, if you are very concerned about your data that you are reading, you can use the read committed isolation level. Okay, in banking industry, it is very relevant. Okay, you don't want to use any uncommitted data in a banking database. Okay, because it involves a lot of money again. I mean, that's a big factor. Let's talk about error or exception handling. So what happens when we get an error in SQL Server? We get a red color message and the query ends there itself, right? But is there a way in which we could handle the errors, like store it in a variable or store it back into a table or something of that sort? Can we efficiently manage our queries to not fail when there is an error, but at the same time catch that error? So the try catch block helps us do that. It helps us in handling the errors. Now, the try block is where all the SQL statements are placed, okay, that we want to execute. We place all of them in the try block. And if there is any error from any of the SQL queries in the try block, the catch block is automatically hit. Okay, let me show you a quick example so you can relate to it. Okay, so you can understand it better. So here, what I'm going to do is I'm going to say begin try, and then all our SQL statements goes in here. If you want to write updates, deletes, inserts, anything that you want to write, you can write everything inside the try. And then once all your statements are done, you just end the try block. Okay, so all your SQL statements that you want to run goes here. Now let's say the first one runs fine, second one runs fine, third one runs fine, the fourth one has an error. That very moment the catch block is hit. You see the begin catch? The cursor moves to the catch block and it executes whatever is there in this catch block, right? So let me show you an example. Okay, let me comment these. And what I'm going to do here is I'm going to say, let's say select Dinesh. Very simple one as name. That's it. So I begin my try, I select something and then end my try. And then in the catch, I just print catch block is hit and then end the catch. Very simple stuff. Okay, let me run this. So what should be executed? So you need to remember one thing, that only when there is an error here, then the catch block is executed. If there is no error here, then only the SQL queries are executed. Okay, so let me run this and show it to you. Let me run this, and you see it just selects my name as it selects Dinesh as the name. Okay, so there is no error whatsoever. But let me try to divide 1 by 0. Now 1 by 0 is a fatal exception in any programming language. You talk about SQL, Java, .NET. Okay, you cannot divide a number by 0. Okay, it's a fatal exception. So let me run this independently and show you. See, it throws an error saying divide by 0 error encountered. So now let me run this whole thing and let me show you what happens. So if I run this whole thing, see, now it doesn't throw me any error. It doesn't give me any error because it went into the catch block and printed this message. So it proves the theory, right? That if there is any error here, the catch block is hit. And see, I've printed the message saying catch block is hit. So the catch block is now hit because of this query, because it has a error in it. Now, let's say that I want to do and I want to catch the error that was thrown from here. So there was an error, right? Obviously, it was throwing divide by 0. Now, can I store it in a variable somewhere? Yes, I definitely can. So in here, what I'm going to do is I'm going to create a variable. I told you what variables are earlier, right? Variables are just memory, are just containers which reserves a space in memory to hold a value. So I'm creating a variable. The variables are usually prefixed by @ symbol, and we declare them. Okay, so the variables we declare. So I create a variable with the name error message of type varchar, and it can hold up to 1,000 characters. Okay, and here I say set error message. You see this variable, I say set the error message equal to the error message function. Now what does the error message function gives me? It will give me the error that's been thrown from the try block. Okay, that is how this function works. So it'll give you the error message that's been thrown from the try block. So we store that message in the error message variable, and then end of it I just select the message, the error. Okay, so let's run it now and see what happens. See, it now shows me the message saying divide by 0 error encountered, and it is coming from where exactly? It is coming from this part of the catch block. So when the when SQL started executing the query, it started from the begin try perfectly okay. It came here. Now that it is, now this throws an error only because it is inside a try block. It directly goes to the catch block, prints this statement. Let me show you where it is printed. If you go to messages, see it says catch block is hit, and then it runs these queries as well. And in this, I declare a variable, I store the error message in here, and then display the error message. Okay, simple. And now, although the query has an error, but it does not throw an error. You see, it says query executed successfully. So now if you want, you can either use this message to send it to the UI, because the application will not know, right, if there is an error. So you can either store it in a table for logging purposes. It's up to you. You can store this with the date and time, saying so you know that at this date and time this error was encountered. Okay, so you can do a lot of things with this, but the main purpose of the try catch is to handle the errors well, handle our queries to run in a better way. Okay, because when it throws an error, there is no control on what SQL does. It just throws the error and then it gets lost. I mean, there's nothing that we can do. We have no trace of it. We cannot store the value of the error or anything at all. But this gives you a more controlled approach to it. Now let's say you have more than one queries. Okay, let's say I have another query, and this one also throws an error. Let's suppose this one also throws an error. You already know it will not be able to add a string and an integer. We need to use the cast, right? So it throws an error saying conversion failed when converting varchar value Dinesh to int. Okay, so now if I execute this, what will happen? Okay, so now I have two statements with two different errors. So if I execute this, it still throws me the same error, and the catch block is hit only once. Why? Because you need to understand this thing. So it goes query after query. So the moment the first query fails, it has an error, it goes to the catch block already. So it doesn't execute any other queries after the error is encountered. So if the error is encountered here, it will not execute any other queries below it, because it already goes to the catch statement or the catch block in the first query itself. Okay, so obviously it would only display me the error message from this query. Okay, so this is how a try catch block helps us have more control and more authority on the errors that are being encountered on our queries. Perfect. Now let's try to see how this can help us with the transactions. So as I told you, the transaction, so we begin the transaction and we commit or roll back based on what so let's say if the transaction has 10 queries, okay, and if 5 of them ran fine and one of them throws an error, then we roll it back. If all the queries run fine, we commit it. Now this is all manual, right? I mean, we run this query, and then if there is no errors, we commit it. If there are some errors, we roll it back. Okay, but how can we automate the commit if everything is well and roll back if there is an error? This is where the try catch block is going to come in handy. So with the try catch block, okay, I can combine this with the transactions to make it even more effective. How? You know about the begin try and the end try, right? and inside this we specify all our queries. Now what I do is I also begin my transaction inside the try block and then place all the queries in here. Let's say there are 3 queries that I want to run, and then end of it I say commit transaction. This is all happening in the try block, mind it. So I begin my transaction here, I commit it right after all the queries are done, and then in the catch I roll it back. I roll back the transaction and then end catch. Now let's see what happens. Okay, there can be 2 situations. One, everything runs fine. So the try begins, transaction begins, everything runs fine. The transaction is committed because everything ran fine. So there's no harm in committing it. And then the try is ended. The catch isn't executed because there was no error at all. Now let's say the other situation wherein we begin the try, transaction is begin, the first 2 queries ran perfectly okay, but by the time the third query was running, there was some error. So what happens? Right when the error is encountered, the control goes to the catch block now. Okay, it does not execute the commit anymore. It goes to the catch block and it rolls back the transaction. That means it rolls back whatever changes was done for queries 1 and 2, although they did not have any errors. But if you remember, transaction is either all or none. So either all of these 3 queries get executed successfully or none of them execute. There is no partial execution in a transaction.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following SQL clause is used to delete tuples from a database table? A. Delete. B. Remove. C. Drop. D. Clear. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So this is how we can leverage the error handling with the transactions to make it automatic now. So when I execute this query, it will automatically check if there are no errors, it will commit it. If there is an error, it will roll it back. You see, it looks very complicated, but when you understand the concepts, this is the beauty of SQL Server. Okay, this is the beauty of the language SQL. It is, I mean, there are no complex statements at all. It is just that the placing of the queries makes it look a little bulkier. Okay, but if you understand the concept, it is as easy as learning, I don't know what is the easiest thing to learn, but yeah, I mean, I just wanted to compare it with that. Right, any ABCD? I mean, if you ask, ABCD is difficult for a kid, so there's nothing that is easy in this world, but I'm just trying to say. All right, so let's see how do we leverage this in a procedure. Okay, so here, I mean, it might look a bit long, but bear with me. Okay, I don't want to use these. Okay, so here what I do, you already know, create or alter procedure. Let me just reduce the font a little bit. So here I begin my procedure as begin, right? So this you already know. You know what this one does, right? The set transaction isolation level read committed. Okay, this helps us in reading only the committed data from the tables. Now here, if you see, this is where the try block starts. I begin my transaction, and if you see, observe carefully here, I have all my statements here, all the update statements that I want to run together as part of the transaction, right? So begin transaction, all the queries in here, then I commit my transaction and print a message saying transaction is committed, and then here, sorry, so I commit my transaction, print a message, and try. And then in the catch, I just have a rollback, as I showed you earlier, and then just print a message saying that the transaction was rolled back. And I end the catch, and this end is for the procedure that I begin here. This is for the procedure. Okay, I had a procedure begin, right? Now, what do we have in the update statements? Let's check it here. So what does the first update do? It sets the last name to Yadav for employee ID 1. Good enough. It inserts a new record into the employee table with ID 10. Perfectly all right. Now the third query is I'm trying to update again the employee table, setting the employee ID to 1 by 0. You know this is going to throw an error, right? Because it's, you already know, it throws a divide by 0 exception where employee ID equals to 1. So this query is going to throw an error now. Okay, that means obviously none of these changes should happen when I run this procedure. because all of these are in a transaction. So the first query will run fine, the second query will run fine, the third query will throw an error, and hence the the cursor will go to the catch block and it will roll back the transaction. If everything would have run fine, then the commit would have run. Simple. Now let's create this procedure. Okay, let's create this procedure. Okay, fantastic. Let's execute this procedure now. Okay, see, it says transaction is rolled back. Why? Because as I told you earlier, the queries had a problem, right? The third query had a problem. Now, if I show you the employee table, you will notice that the last name will not be Yadav for employee ID1, and this record will not be there in the table. Let me just show you by selecting. So you see, for ID1, the last name is Kumar, and there is no ID10 here. That means none of the changes are performed on the table. Although the first two queries are okay, but only because all of these are in a transaction, that's the reason it rolled back the first two as well. Okay, now let me comment this for you. Okay, let's comment this, and now let's alter this procedure. So now the procedure should run fine, right? So it should commit the data this time. So let me run this, and it says transaction committed. And now when I run from the employee table, see here, the last name has got updated to Yadav, and there is a new record with ID 10. Okay, so what are CTs? CTs are commonly called, are known as common table expressions. So you remember when we spoke about global temp tables, local temp tables, table variables? CTs are also like that, exactly like that. They are temporary storage that helps us store data in them. Okay, so the scope of a CT is different when compared to temp tables, table variables, and stuff. Okay, so let me show you first how to create a CT, and then I'll explain you the scope of it. That means till when can we access a CT. So to create it, we start with a semicolon and then say with the name of the CT. And then here I specify the columns only, not the data types, only the columns. So this CT is going to have 4 columns: first name, last name, address, and date of birth. And then as inside my bracket, I specify what data should be stored in the CT. So here I select the first name, last name, address, date of birth from the employee, inner joined with the date of birth, and I'm only storing the Indian employees in the CT. You see, I use a where clause here. Now let me create this CT. Whoops, it throws an error. The reason is, with the CT, you will have to select from the CT right after it is created. Okay, you cannot just create a CT without selecting from it. The first query should be select from the CT, and now if I run this, it should work. See, it now gives me these details. Now, one thing that you need to understand here is that the scope of a CT. Okay, the scope of a CT is only till the first select inside the same batch. Now, see, let's say I create and select the CT. Okay, I see the data. I run the select also with it, right? Now, if I run the CT separately, I cannot find it. So it's same as that of the table variable. But the table variable, we can use it multiple times, whereas a CT can be only used once. Let me show you. See, I have a select from the CT here. I have another select from the CT here. Okay. Now, if I run this, you will notice that only the first select will give me data, but the second select that I have, it says invalid object name CT employee. Okay. So this one throws an error, but this one works. Is because the CT, the scope of a CT is only till the first select inside the same batch. So you cannot use a CT more than once after you create it. I mean, in more than one statements. You can join them like this. See, you can let's say cross join. Okay, if you want, you can use the CT multiple times in the same query, but only in the first query. You cannot use it again in the second query. So it is only available in the first select right after it is created. Okay, now where exactly is this CTE created? The CTE is created in the memory, like the table variables. Okay, these are not created on the temp database. So these are faster, but as it is stored in the memory, we usually store only a very small amount of data like table variables. But these, we just can use them once. So for any type of data that we want to use only once, we create them as CTEs. Okay, so it's like a temp storage itself, but it is meant for very small amount of data that we want to use only once. That's it. Okay, that's about CTE.
So the meaning is pretty simple, guys. As I told you, SQL stands for Structured Query Language, and it is one of the most amazing language which is basically used to manage a relational database system. And what is MySQL? MySQL is the relational database system which is basically used alongside SQL to perform operations, guys. So any operations such as storing data, retrieval of data, or modification of data in the database. And this brings us to the second point, which is basically complexity. When we have to talk about complexity, SQL as a language, it has to be learnt on, it has to be worked on and practiced to ensure that you can make the most efficient use of your queries to work with your database. Then coming to MySQL, MySQL is basically a readily available software, which is, you can download it, install it, and begin working with it without much of a prerequisite. And then coming to point number 3, it is the type of usage that we have to talk about, because SQL is a very fine language. It is a very well tuned language which is put together to work with a database. But MySQL is an entire database software, an entire platform which is basically making use of SQL to query the database, guys. Again, when you have to think about what to learn with, again, if you're using MySQL, then obviously learning SQL is a prerequisite. But then if you're just learning SQL, then you might not have to work with a MySQL database, because there are many other forms of relational database management systems where you can go on to use SQL as well. Coming to point number 4. Point number 4 is the purpose. When you have to talk about purpose, again, SQL is the language which is used to operate on the database, while MySQL is the tool which allows SQL to perform operations such as data handling, data storage, data modification, deletion operations, and much more. So I hope you guys are getting the general picture here. SQL is the language, while MySQL is the database on which SQL works with, guys. Coming to point number 5. Point number 5 is the usage. When we have to talk about usage, again, there are various techniques which SQL uses. There are multiple code segments, code snippets, multiple commands, and pretty much everything else which is used to talk to various RDBMS systems. And in fact, MySQL is one of them. But then we have to talk about MySQL. MySQL is the RDBMS database pretty much, which ensures languages such as SQL can run on top of it. But then if you're thinking how well does SQL run on MySQL, guys, it is extremely efficient. And even today, SQL is a very old language, and MySQL is a pretty old open source software too. From its day of the release, pretty much all those years ago, it's still there. And I would not consider calling SQL or any of the MySQL RDBMSs as legacy, because as I told you, there are companies around the world, Fortune 500 companies, who make use of these every single day, guys. And then coming to point number 6, it's updates, because SQL is a fixed language, right? So no matter what, there are multiple flavors of SQL. Of course, there's Oracle SQL, there's some Microsoft SQL, there's multiple types of SQL, which is basically like a flavor of it. You can run pretty much, if you learn SQL, right? So SQL is a fixed language. If you learn it, then pretty much you can all the code, all the commands, 99% of the code segments of the syntax pretty much remains the same. But then when you have to talk about MySQL, the updates are more frequent here, because at the end of the day, it's a software and it has to cater to various customer bases. But then even at the end of the day, solving bugs, making your software more efficient, or helping you work with your database management system in a more efficient way, if that requires frequent updates, then yes, MySQL provides that, guys. Then coming to the quick summarization of this particular difference, SQL, as I told you, it has been a big player, it has been a huge player in the world of IT, and it is very, very vital when we have to talk about the applications and its usage in applications, guys. And coming to MySQL, MySQL brings about a software which pretty much makes the best possible way to store structured data into it on the database, and eventually to work with it later on by making the developers or the coders' life a lot easier, guys. And on that note, you have reached the end of this quick comparison between SQL and MySQL.
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Okay, so we've seen that. Next, we'll look into the skills to have as a SQL developer. So we saw what are the requirements and the roles of an SQL developer. Now the skills. First of all, data management, obviously, because database manages, has data in it. So to manage that, you will need to know a very good knowledge of SQL so that you will be able to manipulate it and also manage the data accordingly. Software programming is required. It is not mandatory that you can only become an SQL developer having a very thorough knowledge of a programming language, but having the basics or having the intermediate knowledge of software programming. So let's say your company uses Java, then learning how Java works will obviously help when you build a database for that company. So because that database should be compatible with Java. And yes, so that's what you should also know, software programming. Server development and maintenance. So this again, you can learn on the go. So server development in the sense to run virtual machines and to create databases on it and also maintain it. Problem solving, if there is a problem if there is a problem, so this particular person should be able to create a query which solves that problem or should be able to make the database more compatible. And then TSQL, which is basically related with transactions. So learning this is not compulsory at the beginning for an SQL developer, but learning this will also improve their chances of getting a job. Then process enhancement, this is to make better business decisions. So you can be an SQL developer and also be involved in process enhancement. That is, a company might go with a set of processes which is already organized and they go with that flow. So let's say an SQL developer can go ahead and change that process if that benefits the need. Okay, so these are the basic skills which you need. First of all, learn SQL. So that is the most basic thing. So if you learn SQL, you'll be able to manage data and understand software programming, because without software programming, without knowing how an application works, you will not be able to build an compatible database with it. Development and maintenance, problem solving, SQL, and process enhancement. So make sure to go by the flow. Start off with SQL, software programming, and then move ahead with the other tools. And then the career path. So once you have all these skills, you can obviously start applying for a job. Then as an SQL developer, there are various profiles. It is not just developer. There are so many different profiles within a company. So as I told you, an SQL developer should be able to maintain, should be able to build, should be able to manipulate. So let's say if you want to maintain a database, so you can become a database administrator. So the basic task of a database administrator is to administer the usage of the database in that particular company. So you will be the head of the entire database system. You will be able to administer every single transaction. So it's basically maintaining. And then a database developer is a person who builds and also manipulates databases. So you can also become a database developer by having the skills. So let's say for a database administrator, you should go with more of a view that you'll be able to manage any kinds of problems which are arising. You should be able to solve any kinds of problems which are arising. A database developer should go with, let's say, this person should be able to create SQL queries for any scenarios given in the company. Okay, so next is data scientists. So obviously data scientists need SQL. Without SQL, it will be very hard for them. So SQL is a need for data scientists as well. So learning any SQL, that is any SQL engine, will help the data scientists. And then ETL developer. So this basically involves big data, extract, transform, and load. And again, you can also become an ETL developer by learning databases. Then BI developer and administrator. So BI is business intelligence. So in business intelligence, you obviously need to create visualizations, and to create visualizations, you need to manipulate or query data. And to do that, you should obviously know SQL, and it will help in becoming a BI developer. So to become a BI developer or an administrator, you should not just know these skills which I showed you for an SQL developer. You should also learn BI tools like Tableau or Power BI. So only then you can move ahead with BI. Okay, so now we've seen that. We'll look into the certification path for an SQL developer. First of all, what are certifications and why do you need it? First of all, it's a stamp of excellence. That is, if you have it on your resume, it adds value so that you don't need to even explain that you know database. If they see that you have a certificate from Oracle or let's say a certificate from Microsoft, they will understand that you have prepared and cleared that exam and you know well enough. And then substantial increase in pay. So once you get earning certifications, obviously you are putting in time and effort to make yourself better in your career. So that will obviously give you a good hike. Clear corporate requirements. So as I told you, every single company needs a database developer. So for that, so for clear corporate requirements, that is, few companies might have a requirement of having a particular certification, and that will help if you're going to go for that particular job and helps get you hired. So obviously these everything goes back to that point. So these are certifications. Why do you need a certification? And also while you do certifications, you'll be able to understand a lot and also will be able to experiment with a lot of projects before you enter the corporate career itself. Okay, so these are some SQL developer certifications. First one is the IBM Certified Database Administrator, DB2. So this involves the database called DB2. Then Microsoft SQL Server Database Certification. This involves Microsoft SQL. And then Oracle. Under Oracle, there are two. One is Oracle Certified Professional or MySQL Database Administrator. So MySQL is one of the most popular databases in the world, and you can go ahead with MySQL Database Administrator without any hesitations. But the one more thing you'll have to remember is there are n number of MySQL Database Administrators or Oracle Certified Professionals. Also, Oracle Database 12c Administrator is also one more certification which you take up to go for a particular role. So these are some of the most popular certification courses. So for SQL developer. So if you want to, it is not just, so let's say if you complete the IBM certification, it is not just you can go for IBM. The thing is you can go for any company which uses DB2. Or if you do the Microsoft SQL Server, so any company which uses Microsoft SQL Server needs a database developer or an administrator with an apt certification, and you can be eligible for that, and same goes with Oracle. So these are some of the popular certifications. You can check out more if you want to check out other, so let's say MariaDB, or there is a number of database engines out there. You can go ahead and check them out. So these are some of the popular certifications and highly recommended. Okay, so we've seen that. Now let's look into the most important part, which are the job trends, because obviously at the end of the day, you will need a job, and also salary. So first of all, SQL developer in the USA, they are getting about $72,282 per year as an average. So this is the average amount. There is a low, there is a high to this. And in India, it goes around 6.5 LPA. So these are the two variants in US and India. So this is for an SQL developer role, and this is totally relative because this data is collected from Glassdoor or Payscale, and those data is based on the salaries which other, let's say there are 100 users in Glassdoor who are SQL developers. If they post their salary, it is aggregated and the mean is given to you as the salary which is provided here. So it can vary. It can be lower than this for a beginner, and it can be higher than this for a experienced database professional. So we've seen that. So who's hiring? So every single company which uses the database. So that puts under Uber, Spotify, Netflix, Instagram, Dropbox, Airbnb, Twitter, and any other company. So you can go ahead, learn this, and you will have to pick out. You will have n number of companies to pick out. You can attend a lot of interviews, and if you're talented enough, you will be able to bag a job in a couple of days or maybe weeks.
So what exactly is SQL? So this is a very basic question. So to answer this, SQL stands for the Structured Query Language, and according to ANSI, it is a standard query language for relational database management systems, which is used for maintaining the relational database and also to perform different operations of data manipulation on different types of data. So SQL is widely used language for maintaining relational database, and in the year 1986, SQL became the standard of American National Standards Institute, or ANSI. So basically it is a database language which is used for creation and deletion of databases, and it can be used to fetch and modify rows from the table and also multiple other things. So let's head on to the next question. So we are supposed to explain the different types of SQL commands. So the SQL commands can be divided into 4 categories. So we've got data query language, data definition language, data manipulation language, and data control language. So the data query language comprises of just one command, select, though it can be accompanied with many clauses to compose queries on a database. Then we have the data definition language. So DDL is that part of SQL which defines the data structure of the database in the initial stage when the database is about to be created. So it is mainly used to create and restructure the database objects. So you can see commands like create table, alt table, and drop table in DDL. And after that we have the data manipulation language. So DML is used to manipulate the already existing data in the database. That is, it helps the user to retrieve and manipulate the data. And it is used to perform operations like inserting data into the database through the insert command, updating data in the database through the update command, and deleting data from the database through the delete command. And finally, we have the data control language, which is used to control access to the data in the database. So these DCL commands are normally used to create objects related to user access and also to control the distribution of privileges among users. And you see commands such as grant and revoke in DCL. Right, so this is the next question. So what exactly are constraints? And we are supposed to explain about the default and the unique constraint. So constraints are basically used to specify some sort of rules on the data and limit the type of data that can go into a table. Alright, so let's understand about default constraint. So the default constraint is used to provide a default value for a column. So the default value will be added to all the new records if no other value is specified. For example, if we assign the default constraint to this e-salary column and set the default value to be equal to 85,000, then all the entries of this column will have a default value of 85,000 if no other value is assigned during the insertion. So similarly, we can also assign a default value of analytics to this eDEPT column. Right. So now we'll go to SQL Server and we'll work with the default constraint. Now I'll start off by creating a new table and I'll add the default constraint to one of those columns. So I'll create a new table and I'll name this table as stu1. So the syntax would be create table stu1, and this would comprise of these columns. So there would be SID, which basically stands for the student ID, and the data type of this column would be integer. After this, there is SName, which stands for student name, and the data type would be varchar, and the length of the string, or the maximum length of the string, would be 20. And then I'll finally have the marks scored by the student, which would be SMarks, and this would be of integer type. Now after this, I will give in the default constraint and I will set the default value to be equal to 50. Right, so I have successfully created this table. Now let me have a glance at this table first. So select star from stu1. So this is our table, which is empty as of now. Now what I'll do is I will go ahead and insert some values into the table. So I'll type in insert into stu1, and then I'll give in the name of the columns. So this needs to be INSERT. So the name of the first column is SID, and then I've got SName. Now I'll type in values and give in the values for these two columns. So let's say the first ID is 1 and the name of the student is Sam. Now I'll click on execute. Now let me have a glance at this modified table now. Select star from stu1. So now we see that we have this default value of 50 in this SMarks column, And this is because we had assigned the default constraint to this column. Now similarly, let me add 2 more records into this table. So insert into stu1 SID, SName, I'll give in values. So it'd be 2, and the name of the second student is Bob. Right, so I've also added the second record. Now let me add in the third record. So the student ID is 3 and the name of the student is Matt. Right, so now I have 3 records in this table. Select star from stu1. So these are the 2 new records and the default value is 50 for these 2 new records. So this is how we can work with the default constraint. Now comes the unique constraint. So the unique constraint ensures that all the values in a column are different. For example, if we assign the unique constraint to this ename column, then every entry in this column should have a unique value. So here we see that all the names of the employees are different. Now again, let's go to SQL Server and work with a unique constraint. So again, I'll create a new table and add the unique constraint to one of the columns. Create table, and this time the name of the table would be stu2. Again, there would be the ID, and this is of integer type. Now I would be assigning the unique constraint to this SID column, and there would be a second column which is basically the student name, and this is of varchar type. Again, the length of the string would be 20. Right. Now let me have a glance at this table again. So select star from stu2. So this is our new table which is empty as of now. Now let me go ahead and add values into this. So insert into stu2 values. I'll add in the first record. So 1, which would be the student ID. Name of the student is Julia. Now let me look at this table. Select star from stu2. Right, so we have successfully inserted this record. Now let me add a new record. So insert into stu2 values. Now what I'll do is I will again give the ID of the student to be 1 and the name of the student to be Matt, and let's see what happens. So this time we get a message or a warning message, and this states that violation of unique key constraint, and we cannot insert duplicate key in object dbo.stu2. And that is because we had given the unique constraint to this SID column. That is why this has to be different. So let me change this to be 2. Now let me again run this, right? So now since this is a unique value, 2 is not a duplicate. That is why we were able to insert this record. Now again, what I'll do is let me add another record with the ID 2. So let's say now the name of the student is Annie. Now again, we get this warning message because ID number 2 is already present. So let me change this to 3. Now let me run this again, right? So now we are able to insert this record. So this unique constraint basically makes sure that there are no duplicate records inserted into this column. So now we have the next question. So again, we have this employee table with us, and we are supposed to find out the second highest salary from this table. So let's go to SQL Server and find out the solution. So let me start off by having a glance at the employee table. Select star from employee. Right, so this is our employee table over here, and we see that the highest salary is 159,000 and the second highest salary is 125,000.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which SQL keyword is used to retrieve a maximum value? A. Most. B. Top. C. Max. D. Upper. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So we are supposed to extract this particular value from this data set. Now let's see how can we do this. So we can perform this operation with the help of subquery. Now let me just type in the command select, and since we want the maximum value, I'll use the max aggregate function, and this would be E salary. So I want the maximum salary from the name of the table is employee. I'll give in the where clause and given the condition where E salary is not in. After this, I will give in the subquery over here. So the subquery again would be the same. So select max of E salary from employee. So now if you have a glance at this, you would see that both of these queries are same. So select max of E salary from employee and select max of E salary from employee. Now this subquery would give in this result, which is 159,000. So, and then this main query would make sure that this salary does not lie in this. So this would give us the 125,000 result. So select max of E salary from employee where E salary is not in 159,000. That would mean 125,000. So let me click on execute, right? So we have successfully got the result, which is 125,000. And this is how we can extract the second highest salary. So we have our next question over here. So what do you understand by normalization and denormalization? So this is a question which is very frequently asked during the interviews. So let's get to the answer. So normalization and denormalization are basically methods used in databases. And normalization is the process of reducing data redundancy and dependency by organizing fields and tables of the database. So it involves constructing tables and setting up relationships between those tables according to certain rules. And the redundancy and inconsistent dependency can be removed using these rules in order to make it more flexible. So I'm repeating it again, guys. So simply put, normalization is the process of reducing the data redundancy. And we are able to do this by organizing the fields and tables of the database. And then we have denormalization, which is a contrary process to normalization. So in denormalization, we basically add redundant data to speed up complex queries involving multiple table joins. So in denormalization, we attempt to optimize the read performance of a database by adding redundant data or by grouping the data. Right, so this is our next question. Now we are supposed to find out what exactly is wrong with the SQL query. So this is the SQL query over here. Select gender, average of age from employee where average age is greater than 30. And again, we are grouping this with respect to gender. So this is our employee table over here. Now let me go ahead and just type in the command, which would be select E gender. And then I would want the average of age. So average of E age from the name of the table is employee, where again the average of E age needs to be greater than 30. And this is being grouped with respect to gender. Now let me go ahead and click on execute. So let's see what is the error. So this warning message states that an aggregate may not appear in the where clause unless it is in a subquery contained in a having clause or a select list. And the column being aggregated is an outer reference. So this basically means that whenever we are working with aggregate functions and we are using group by, we can't use the where clause. So instead of the where clause, we would have to use the having clause. Now, let me change this to having and let me click on execute. So now again, we get an error over here, and this error says that incorrect syntax near the keyword group. And this is because if we are using the having clause, then group by would come first and having would come second. Now, let me cut this over here and let me paste this before having. Right. Now I'll click on execute. So this has to be E gender over here. Now we've successfully got the result. So just to reiterate, the error was whenever we are working with aggregate functions, we cannot use the where clause and we would have to use the having clause. And if you are also using group by with having, then group by would come first and having would follow it. So next question. So what do you know about the stuff function? So the stuff function deletes a part of the string and then inserts another part into the string starting at a specified position. So this is the syntax of the stuff function. So stuff, this takes in these four parameters: string 1, position, length, and string 2. So the string 1 is basically that string which would be overwritten. Position would basically indicate the starting location for overwriting the string. And length is the length of the substitute string. And string 2 is that string which would overwrite the string. So again, let's go to SQL Server and work with an example with the stuff function. So now let's say I have this string which basically stands like this: SQL tutorial. Now I'd want to replace this SQL tutorial with Python tutorial, right? So for this purpose, we can actually use the stuff function. So let me go ahead and write the syntax for that. It would be select, I'll give in the function stuff. So let me start with the first parameter, which is the string which is to be replaced. So the string which is to be replaced is SQL tutorial, and then I'll give in the second argument, which is the position. So the position would be 1, that is, I want to replace this, so this is position number 1, and then I would have to give in the length of the string which is substituted, right? So the length of SQL is 3, I'll just type in 3 over here, and then finally I will give in string 2, which is basically that string which would replace this over here. So I would type in Python over here. Now I'll execute. So initially our string was SQL tutorial, and with the help of the stuff function, you were able to change this from SQL tutorial to Python tutorial. So next up, we'd have to explain about views in SQL. So what exactly is a view? And then we'd have to give an example of view. So you can consider views as virtual tables, which are used to limit the information that we want to display. And these are actually nothing but the result of an SQL statement which have a name associated with them. And since views are not virtually present, it takes less space to store. So let's take this example. From this employee table, let's say we wanted to perform multiple operations on the records where the gender is female. So we can create a view only for the female employees from the entire employee table. So let's go ahead and perform this in SQL Server. Now let me type the syntax for this. So I would want to create a view which would comprise of only the female employees from the entire employee table. Now let me just have a glance at the employee table first. So select star from employee. Now I would want a view which would comprise of just these two records. Now let me go ahead and write in the syntax for the view. So it would be create view, and the name of the view would be female employee. And after this, I will give in the keyword AS. After that, I'll type in select, and then I'll give in the condition. So select star from employee, where after the where clause, I will give in the condition which actually matters. So gender needs to be equal to female. Right, so I have successfully created this view with the name female employee, which would comprise of only the records of the female employees. Now, let me delete this and let me have a glance at the view which I've just created. So select star from female employee. Right, so this is our view which comprises of these two records, and the names of the employees are Anne and Julia. Now similarly, let's say if I wanted a view which would comprise of only those employees whose age is greater than 25. So let me go ahead and write the syntax for that. So create view, and then let's say the name of the view is age, and then I'll type in the keyword AS, select. Now over here, let me give in the statement. So select star from employee, where, and then the condition would be age needs to be greater than 25. So we have created this view. Now let me have a glance at this. So select star from age. Right, so this is a view which would comprise of only those records where the age of the employee is greater than 25, and we've got 4 records over here. So Sam's age is 45, Julia's age is 30, Matt's age is 33, and Jeff's age is 27. Right, so what is a stored procedure? And then we'll have to give an example of stored procedure. So a stored procedure is a prepared SQL code which can be saved and reused. Or in other words, you can consider a stored procedure to be a function consisting of many SQL statements to access the database system. So we can consolidate several SQL statements into a stored procedure and execute them whenever and wherever required. And stored procedure can be used as a means of modular programming. That is, you can create a stored procedure once, store, and call for several times whenever required. So this supports faster execution when compared to executing multiple queries. Now let's look at the syntax of a stored procedure. So we'll give in the keywords create procedure, and then we'll give the procedure name over here. After that, we will give in the keyword AS, and then we'll give the SQL statement for which we'd want to create the procedure. And then we'll end the procedure with the go keyword. Now, after we create a procedure, we need to execute it. So this is the syntax to execute the procedure. So we'll type in exec, and then give the name of the procedure which is to be executed. Right, so again, let's have an example with the stored procedure. So now I'm going to create a stored procedure which would help me to extract the age of the employees in a very easy way. So let me type in the syntax for that. Create procedure, and then I'll give in the name of the procedure. So this would be employee age. After this, I will type in the keyword ES, and then I'll give in the select statement. So select age from employee. Now that this is done, I'll give in the go keyword. Right. So now I have successfully created the stored procedure with the name employee age. Now I'll go ahead and execute this. So it'll be exec or execute employee age. Right, so we have created the stored procedure which would help me to easily access the age column from this employee table. So next question, what do you understand about join, and explain about different joins? So a join clause is used to combine rows from two or more tables based on a related column between them. So there are various types of joins which can be used to retrieve data, and it depends on the relationship between tables. So first we have inner join, which basically returns records that have matching values in both the tables. Then we have left join. So left join returns rows which are common between the tables and all rows of the left hand side table. That is, it returns all the rows from the left hand side table even though there are no matches in the right hand side table. Then we have right join. So right join returns rows which are common between the tables and all the rows of the right hand side table. That is, it returns all the rows from the right hand side table even though there are no matches in the left hand side of the table. And finally we have the full join. So full join returns all rows from the left hand side table and all the rows from the right hand side table. So now we'll have to explain about inner join properly. So the inner join basically gives us those records which have matching values in both the tables. So we've already learned this. Now let's say we have two tables, table A and table B. And when we apply inner join on these two tables, we'll get only those records which are common to both table A and table B. So this gray portion which you see over here, so this would be the result of the inner join. Now let's look at the syntax of inner join. So we'll give the keyword select, and then we'll give in the list of the columns, following which we'll give the from keyword, and then we'll give the name of the first table. Then we'll use the keywords inner, join, and then give the name of the second table. After which we'll give in the on keyword. So this on keyword tells SQL that this inner join needs to be done on some condition. And the condition over here states that the values from column X of table 1 should be equal to the values of column Y from table 2. So let me just reiterate this. The values of column X from table 1 should be equal to the values of column Y from table 2. Now let's go to SQL Server and work with this inner join. So I have two tables over here. So the first table would be the employee table and the second table would be the department table. So let me have a glance at both of the tables. So select star from employee. Now the second command would be select star from department. So this is the employee table over here which we've already seen, and then we have this department table. Now I'd want to have an inner join on both of these tables where the EDEPT column from this table is equal to the DNAME column from this table. That is, wherever the values from these two columns match, I'd want only those records. Now let me go ahead and write the syntax for this. So I will type in select, and then I'll give in all of the columns which I want. So I want the ename column and eDepartment column from the employee table. So this would be employee.ename. Then I would want employee.eDepartment. After that, I would want the department name and the department location from the department table. So I'll type in department.dname. And then I also want department.dlocation. Right, so these are all of the columns which I want from both the tables. Now after this, I'll type in from, and then I will type in the name of the first table, which is employee. And then I'll just type in inner join. and then given the name of the second table, which would be department. Then I'll give in the on keyword and then given the condition. So here the condition is the values of the dname column should be equal to the values of the edept column. So employee dot ename should be equal to department dot dname. Now I'll execute this. Right, so this is the result. So we have our employee table over here. This is the department table, and finally this is the result of the inner join. So here we see that we've got only those records where the departments match in both of the tables. So the matched departments are support, analytics, and sales, right? So we've got support, analytics, and sales from over here because only those departments are present in this department column. So next question. Well, what do you understand about temporary table? And then we'd have to write a query to create a temporary table. So simply put, temporary tables basically help us to store and process the intermediate results. Now these temporary tables are created in the temp DB and are automatically deleted when they are no longer used. So the temporary tables could be very useful in cases where we need to store temporary data. Now let's look at the syntax of a temporary table. So first we will give in the keywords create table, and before we go ahead and give the name of the temporary table, we'll have to precede it with a hash. So again, let's go ahead and create a temporary table. So now what I'll do is I'll create a temporary table and I will name this as, let's say, book, and then before the name of the table I'd have to precede it with a hash. Right, now this would have two columns. So first would be the book ID, and this would be of integer type, and then this would have book cost, which is again of integer type. Now let me execute this. Now I'll refresh over here. I'll click on the plus sign. I'll go into system databases and I'll go into temp DB, and over here let me click on the temporary table. So we see that we have successfully created this temporary table with the name book. Now let me see what is present in this table. So I'll type in select star from, I'll put in the hash symbol over here, and then I'll give in book. Right, so as of now this temporary table is empty. Now let me go ahead and insert something into this table. So the command would pretty much be the same. So insert into, and then LB book. I'll type in values over here. So the only difference which you see when you're creating or working with a temporary table and the normal tables is you would have to precede the name of the table with a hash. So as simple as that. Rest everything would be the same. And over here let me give in the values. So the book ID is 1 and the book cost is 100. Right, now let me also add another record. So the second ID would be 2 and now the book cost would be, let's say, 232. Alright, now let me have a glance at this modified temporary table. So select star from hash book. Right, so we have added 2 records into this temporary table. So now we'd have to explain the difference between OLTP and OLAP. So let's start with OLTP. So OLTP basically stands for Online Transaction Processing, and you can consider it to be a class of software applications capable of supporting transaction-oriented programs. And an important attribute of an OLTP system is its ability to maintain concurrency. So OLTP systems often follow a decentralized architecture to avoid single points of failure. And these systems are generally designed for a large audience of end users who conduct short transactions. And queries involved in such databases are generally simple, need fast response times, and return relatively few records. So the number of transactions per second acts as an effective measure for such systems. Then we have OLAP. So OLAP stands for Online Analytical Processing, and it is a class of software programs which are characterized by relatively low frequency of online transactions. So queries are often too complex and involve a bunch of aggregations. And for OLAP systems, the effectiveness measure relies highly on response time. So such systems are widely used for data mining or maintaining aggregated historical data. And this is usually used in multi-dimensional schemas. So then we have the next question. So what is the difference between the delete and the truncate command? So again, keep this in mind, guys. This is a question which is very frequently asked in interviews. So let's start off with the delete query. So the delete query is used to delete or remove one or more existing tables. So let's have a look at the syntax. So we'll start with the delete keyword and then we'll put in the keyword from. Then we'll specify the name of the table. After that, we'll specify the where condition, but then that's optional. So let's see an example of this delete command. So we have this table. So the name of the table is STU, which basically is the student table. Now from this table, I'd want to delete the record where the name of the student is Bob. So let me write the syntax for that. So delete from, and then I'd have to give in the name of the table. So the name of the table is STU. So delete from STU. After that, I'll give in the where clause and give the condition where S name is equal to Bob. Let me execute this. Right. So we have successfully deleted that record from this table where the name of the student was Bob. So similarly, let's say if I want to delete that record where the student ID is 3. Right, so over here the condition would change. So delete from STU where SID equals 3. So now this time we have deleted that record where the student ID was equal to 3. Now let's look at the truncate statement. So the truncate statement deletes all of the data inside the table. So here we'll give in the keywords truncate table and then give the name of the table. So let's go to SQL Server and work with this truncate command. So now we have this stu1 table. So let me go ahead and use the truncate command of this table. So I'll type in truncate and then I'll give in the name of the table, which would be stu1. So before that, I'd have to type in table. So truncate table stu1. Let me run this. Right, so we have deleted all of the records from this table. Right, so this is how the truncate command works. Now let's understand some differences between the delete command and the truncate command. So when it comes to the type of language, truncate would be a DDL command or a data definition language command, and delete is a DML command or a data manipulation command. Now another difference would be we can't really execute a trigger in case of truncate. While with delete, we can accomplish a trigger. Now, also if a table is referenced by any foreign key constraints, then truncate won't work. So if you have a foreign key, then you'd have to use delete and you wouldn't be able to use the truncate command. So next question, what is the difference between union and union all operators? So the union operator is used to combine the result set of two or more select statements. For example, if the first select statement returns these 3 fish, and the second select statement returns these 3 fish, then the union operator would return the result of these 2 select statements. And if there is a record which is present in both the tables, we'll get only one of them in the final result. So here we see that this blue fish is present in both the tables A and B. Now, when we apply the union operator on these two tables, the final result of A union B would have only one of these blue fish. And this is the syntax of the union operator. So we'll give the first select statement. After that, we'll give in the union operator, following which we'll give the second select statement. Now you also need to keep in mind that the number and the order of columns must be same in both the select queries. So let's work with this union operator now. So we have these two tables over here. So the name of this table is student details 1 and the name of this table is student details 2. And if we have a glance at the columns, we see that both of the tables have 3 columns and the names of the columns are same and also the order of the columns are same. So here we have SID, SName and SMarks. Similarly over here we have SID, SName and SMarks. Now let's go ahead and apply the union operator on this. So I'll type in the first select statement. So it'll be select star from student details 1. So let me change the spelling to student details. After this, I will apply the union operator and then give in the second select statement. So select star from student details 2. Now let me click on execute. So this is the result over here. Now let me also print in the first 2 original tables. So select star from student details 1 and then I'll also put in select star from student details 2. So let me just change the spelling to student over here. Let me also change this over here. So this will be student Right. So this is student details 1, this is student details 2, and this is the result of the union operator. Now, if you have a glance at these two tables, then you see that these two records are repeating over here, right? So there's Anne, Julia over here in the first table, and there's also Anne and Julia in the second table. Now, when we apply the union operator, then we'll just have one record coming from each of these tables, right? So we've got Anne over here, we've got Julia over here. And then we finally have Matt, which comes from the second table. This is how the union operator works. Right, now let's look at the union all operator. So the union all operator gives all the records from both the tables, including the duplicates as well. So here, since this blue fish is present in both the tables A and B, the final result of A union all B would also have the duplicate value. So here we see that we've got both of the blue fish from table A and table B. Now let's go ahead and implement this in SQL Server as well. So here we have these two tables already ready, which are student details 1 and student details 2. Now what I'll do is I will copy this, I'll paste this over here and just type in union all. So union all, I'll click on execute. So student details 1, student details 2. Let me just expand this over here. Right, and this is the result of union all operator, right? So if you have a glance at this, you'll see that these two are repeating, so we would have duplicate values. So we've got Anne twice over here and also Julia twice over here. So next question, well, what is the use of the intersect operator? So the intersect operator helps to combine two select statements and returns only those records which are common to both the select statements, right? So if we've got table A and table B over here, and if we apply the intersect operator on these two tables, then we'll get only those records which are common to the result of the select statements of these two. Now let's look at the syntax. So over here, this is the syntax. So we'll start off by giving the first select statement and then we'll give the intersect operator, following which we'll give the second select statement. Now let's see an example on this. So again, we have these two tables over here, student details 1 and student details 2. Now let me apply the intersect operator on these two. So let me just type in intersect over here and I'll click on execute. Now let me maximize this over here, right? So student details 1, student details 2, and this is the result of the intersect operator. So we see that since Anne and Julia are common to both of these tables, this is the resultant of the select statement, right? So the select statement on the first table gives out Anne and Julia, and the select statement from the second table also gives out Anne and Julia. So the intersection of these two would be this. So we have our final question. Now let's say you're given a table. Now you'd have to copy the data of this table into another table. So you have this employee table. Now you'd have to go ahead and copy the data which is present in all of this table into another table. So let's see how can we do this. So this is our employee table over here. Now we'd have to copy all of this into another table. So for this purpose, we can use the insert into select operator. Now before we go ahead and do that, we would also have to create another table which would have the same structure as this table. So if the table doesn't have the same structure, then you wouldn't be able to copy the data. So let me go ahead and create the table first. So I'll type in create table and I'll name this as employee duplicate. And then I'll give in all of the values over here. So my first column would be EID and this would be of integer type. Second column would be ename and this would be of varchar type. And the length of the string would be 20, and then I would have the eSalary over here. This would be of integer again. After this, I would have the E8, which is of integer. Then I would have the gender of the employee. So the gender of the employee would again be of character type. Now I'd have to make sure that I give in commas after all of these. So let me just put in a comma after this as well. And then the final column would be EDEPT. And this again would be of variable character of length 20. Right. So I've successfully created this employee duplicate table. Select star from employee duplicate right? So as of now, we see that this table is empty. Now I'd want to copy all of the table present in the employee table into this table. So let me write in the command for that. So I will start off by giving the keywords insert into. Now after that, I'll give in the name of the table into which I want to insert. So the name of the table would be employee duplicate. Then I will type in select star from, and then I'll have to give in the name of the original table. So the name of the original table would be employee, right? So 6 rows have been affected. Now let me have a glance at the new table, which would be select star from employee duplicate, right? So we have successfully copied all of the data which was present in employee table into this employee duplicate table.
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. So guys, we have come to the end of the session. Hope you all enjoyed it. If you have any doubts, please put down in the comment section below. We will try to answer it as soon as possible. Thanks for watching.